This is your chance to learn Python for free from start to finish with Rohit Arora, a senior software engineer at Microsoft. Welcome to Newton School's Complete Python Bootcamp, a beginner-friendly guide that takes you from the very basics of Python and makes you job-ready in just one session. Whether you're a student, an aspiring developer, or thinking of switching to tech, this video is made for you. And don't just watch, practice what you learn on Newton School Launchpad. The link is right there in the description. Get ready to dive in. Grab your notebook and pen. Let's start the lessons.
So hello everyone, hope you all are doing well, and this is Rohit, and today we are going to learn what is Python programming. So let's imagine that on a weekend you are sitting, you are relaxing, and you want to watch a movie, right? You decide to open Netflix, and what you see is it starts recommending you some movies, right? And once you see those options, it feels like it's reading your mind, because let's say you want to watch horror movie, you'll be able to see, okay, it's recommending me horror movies. Or let's say you like thriller, it will start recommending you thriller, right? So it feels like it reads your mind, right? So what's making this possible? Can you think about it? So it's behind the algorithm which is running, which is making this possible, right? The algorithm is analyzing the behavior, the kind of watch history, what you have, and based on that, it's giving you options, right? So all in all, what I'm trying to say is, whenever you use an application, it has its own logic, it has its own algorithm running behind the scene, which making the everything possible, right? So from recommending products to suggesting you the next playlist. So here is another example what I can give. Once you open Amazon, it starts recommending you some products which you might already thinking to buy, right? And once you open, let's say, YouTube, it will recommend you songs which you actually like. For example, you like Punjabi songs or you like English songs. It will start recommending you that genre of songs which you highly listen, right? So yeah, the agenda for today's lecture is what is Python, why Python, where is Python used, and how to use Python, right? So let's start. So what is Python, right? So if you all have clicked to watch this video, you all might know that Python is a programming language, right? Even if you might have heard about tech, or you might have heard about languages, programming, IT industry, you might have some idea that okay, Python is a programming language, right? But Python is a game changer. That's what I want to tell you, right? Okay, you know it's a programming language, you will learn it slowly, but what I really want to tell you is little different from that definition. Python is a game changer. Why I am saying this is, once you learn Python, it will open plenty of options for you. Even if you talk about data scientist, data analyst, software developer, business analyst, backend developer, AI ML engineer, and whatnot, right? Even if you are a fresher or a working professional, it will open a lot of doors for you to work into the different fields, right? So will I find a good job in good company if you learn Python? Yes. So Python is the primary skill of top 10% highest paid professionals. Top 10% highest paid professionals, I'm saying. And almost 95% companies are hiring professionals with the Python skills, right? Isn't it crazy, right? So what sort of salaries you can expect? So here is a chart. So if you see about the data scientist in India, you can earn from 8 to 22 LPA package, 22 lakhs per annum, right? And if you talk about salaries in USA, it's even more crazy, right? It's from 120K to 130,000 US dollars, right? Similarly, there are salaries for different roles. If you will be able to crack data analyst, software developer role, business analyst role, you'll get very good salaries, right? And almost all the companies like Google, Amazon, Netflix, Microsoft, Apple, Walmart, right? Almost all the companies are hiring for Python developers, right? So Python is gonna be a career accelerator for you, right? And one more question might be coming in your mind, that if let's say someone is watching who is not into the tech career, who hasn't worked in tech, right? Will the Python accelerate your career? Yes, let me show you a few stories. So here is Falguni, who has got 90% salary hike by learning Python, who has moved from a recruiting coordinator role to the product owner, right? Who has switched the field. She was working as a recruiting coordinator and now she is a product owner just because of Python, right? Similarly, there is another example, Shrijit, who has earned 50% hike. He was working as a senior designer and now he's working as a data analyst, right? And similarly, there are many more examples who have got a very good career switch by learning Python, right? So, okay, now you get to know that Python is important. It's going to be a career accelerator. It's a programming language which you are going to learn. But why Python? Like, there are many other languages, right? Why you should learn Python? So, there are many people, or if you are watching, right, you might be one of them, who have struggled with coding in college time. Or if you think about coding, you might be thinking like, oh no, this is going to be tough for me, right? You might be one of them, right? So why you should start with Python, right? If you don't know any programming language, right? Because Python is simple and easy to learn, right? If you compare it with other programming languages, like if you see Java, right? If you compare Python with those languages, Python is really easy to understand, easy to learn, and if you're starting your career in IT, it will really be easy for you so that you can actually get that confidence to learn coding, right? So almost 51% developers are using the Python programming language along with the SQL. SQL is another language used into the data engineering, right? SQL is structured query language. So if you use Python along with SQL, 51% developers are using it globally, right? And these both languages combined are the foundational skills for data related jobs as well, right? So one more thing why you should learn Python is, let's say you have a very crazy idea to work on. You want to build an app, to find the lost pets, or you want to build a fitness tracker, right? Or you might have any idea in your mind that, okay, you want to solve this problem, you want to build an application for that. So Python is the language that powers these common applications which you might be using nowadays, like Instagram, Pinterest, Reddit, right? And if you want to build your own idea, Python is a go-to tool for you. Even if you want to become an entrepreneur or a developer, you can turn your ideas into reality using Python, right? So this is why you should learn Python. And now, where is Python being used nowadays? Okay, like what kind of industries, who are using Python, right? So let me give you some examples. So you might have heard about company Boeing, right, which works on robotics field, right? So Python is used in robotics. Python is used in game development. OpenAI, which is quite common nowadays, like ChatGPT, you might be using, right? Python is being used there. And fintech, right? Cyber security, bioinformatics, and whatnot. So there are tremendous of industries where the Python is getting used into the softwares which are being built for them. So now you know that, okay, Python is important. You have, let's say you are now interested to learn it, right? And you know it's being used into various industries, right? How you should use Python? If you have learned it today and maybe you are a fresher, you are working professional, how will you use it so that it will be helpful for you as well? So if you are a fresher, you can build simple websites or the APIs which you can showcase into the interview. You can create small projects using Python, right? It can help you in analyzing data sets. It can help you in your file management, right? So if you want to apply it into your current roles, so let's say you are already a working professional working for a company, Python can help you to analyze data. It can help you into search engine optimization. It can help you in creating dashboards as well, right? So you can use Python to accelerate your career into the current job as well, because if you have that skill, you can use it. If you want to switch career, Python can help there as well, because if you will have those skills which I have just talked about, and with Python you can enter into the machine learning, You can also go into the log. You can also do the log analysis, because there are various teams into the companies which hire developers which are working into the logs analysis, monitoring, right? Once you create applications, you have to monitor them as well, right? So it helps into the log analysis as well, right? You can automate the cloud workflows as well using Python, right? You can enter into the cloud industry as well. So even if you want to get high paying jobs, you want to switch career, you can build the deep learning models, you can do the algorithmic trading, you can also build the product recommendation systems using Python, right? So these were all the things which can help you. Now, these are some memes just to show you that yes, Python is a popular programming language into the industry nowadays. That's why these memes are coming into the picture, because Python is actually popular. So in this video, you will be writing your first Python program. I hope you are excited for it. So when you think about programming, one thing which might be coming in your mind is, why are we doing the programming, right? For example, you might have used calculator, right? What does it do is, it do the calculations for you. Either it's sum, division, subtraction, right? So basically what we do with the calculator is we provide some input to it, right? So there is a program running behind the calculator. There is some logic running behind the calculator. And that code, that is nothing but the program, right? It accepts some input and it will give you some output. For example, if you say calculator 5 plus 10, it will give 15, right? So we write programming to solve some problem, right? For example, calculator is used to make the calculations easy for humans, right? Now humans no need to do those calculations which calculator is doing for you, right? Now if you think about why are we doing programming, right? It's to solve a problem, right? And how do we solve such problems is by giving some input to the code, and in response we are expecting some output. If you think about a bigger example, right? When you open Amazon, in the search bar you give an input that I want mobile phone, and in result what output do you get? You get the result of multiple phones available in Amazon, right? So this is where we solve problem using programming. Now the first Python program, we are printing some output. So input and output are really important things in programming, right? In the first Python program, we want an output to be a printed statement, hello world, right? So without wasting any time, let's see how we can do this. So to run any program, any Python program, what you can do is you can use the Newton School Playground. You can go to newtonschool.co/playgrounds and you can create a new playground for you. After going there, click Python compiler. It will create a new playground for you, right? So this is the code. This is the code what is printing hello from Newton School. So if you run this, it will print hello from Newton School. So isn't the Python easy to understand, right? If you just see this line of code, we are able to understand, okay, this line is printing hello from Newton School. But if we want to print hello world, what we can do is, we can do hello world, run the code. Simple, right? So now I hope you are feeling really great after running your first program, first Python program. And similar thought was there from the Guido van Rossum, who was the creator of Python. And what he said was that the first time he ran the program with the Python, he was blown away. And I hope you all are feeling the same, right? So yeah, what will be the agenda for today's video? We will be learning the basics of Python programming. We'll be running what are the comments in the code, what are variables in the Python programming, and what are the naming conventions for variables. Okay. So what are comments? So comments, you can understand it with the help of a shop. So let's say you go to a big shopping mall or a big complex where there are a lot of products, right? There are products related to temple, there are products related to your kitchen, there are products related to your daily use like toothbrush, face wash, right? And if everything will be placed here and there, will you be able to get an idea where to go to get an product, right? No, right? And think of another scenario where there are proper labels in the shop. Okay, this is the kitchen section, this is the washroom section, this is the section for the car products, this is the section for the temple products, right? So similarly, comments are nothing but like a sticky note for your code. These are the notes for your code, these are the kind of the labels for your code, right? So comments are not the part of code which is being running, but it provides an idea for what that code is all about, right? So yeah, writing comments in the code is just like leaving the breadcrumbs in the forest, right? It will make enough to make sure, it will be enough to make sure that you don't get lost later, right? So how you can relate it with an example is, you have seen multiple people, working in an organization, and they are working on big piece of code again and again, right? If some person has worked on a code, might be some other person can come and see that code, right? So comments will really help them to understand what that code is all about, right? So yeah, you can write comments in multiple lines. You can have a single line comment, you can even have a multiple lines comment, right? So this, if you see the code what we have just written, above this was all comment. You can give your own comment. So just let's remove it. A single line comment, you can start with a hash. So let's say about this code you want to say, we are printing hello world. Right? Printing the hello world. Or let's say you want to print your name. You want to print your name. Print. Let's say I'll print my name. And to this I want to comment that here what I am doing is I am printing my name. Right? Printing my name. If you run this, it has print hello world Rohit. So these are the lines of code which are running, and comments are nothing but providing an idea that what that code is all about, right? Now there are multiple lines comment as well. So this is nothing but single line comment. To write the multiple lines comment, you have to use triple quotes, triple double quotes. So just like this it will end, and like this. So from here it will start, here it will end. Whatever you will write in between will be a comment. For example, what you can do is printing the name. I am learning with Newton School. This is my first program, right? Now all this is nothing but comment, right? If you run this, it will not have any impact on the code. Your code will run as it is, right? So comments are nothing but it will help you to write the clean code, and it will even assist you when you want to reuse that code later. For example, if someone will see your code, they will be able to understand with the help of comment, right? So this is one such example. If you see a is equal to 5, b is equal to 10, c is equal to a multiplied by b, there is no meaning to it, right? Although this code will run, but once you add comments to a code, it gives a very meaningful space where anyone reading this code will get an idea, right? For example, length is equal to 5. Above this, there is a comment that length of the rectangle, right? So comments are helpful to identify what that code is all about, to give an idea to the reader about that code, right? Now moving to the next section, I hope you have understood what are the comments. Variables. So variables, think of the variables just like the labels on the jar. Now in that shop, if you go to the kitchen section, if you don't find any label on any product, you will not be able to identify it, right? So similarly, in the programming language, whenever you work on some data, whenever you want to work on some input, just like calculator, you have to give some label to them, right? So let me explain it with the help of whiteboard. So just think that this is the memory in your computer. This is the memory in your computer, right? Inside that memory, whenever you write some code, it will be dealing with some data. Now, whatever data you will work on, that has to be stored into the memory, only then you can work on it, right? For example, inside the code, you have a value 5 and you have a value 6 and you want to add them, right? So let's say that 5 is somewhere in the memory here and 6 is somewhere in the memory here, right? And you want to add them, right? In the program, if you want to work on these memory locations, you have to have some of the name given to these locations so that you can work on it. Otherwise, you will not be able to work on these memory locations, right? So if I give this name to be A, label of this memory location to be A, and the label of this memory location to be B, in the code, I can say A plus B. Simple, right? So variables are nothing but like a label on a jar, right? And also you can change the item inside that jar, but you cannot change the label of that jar. So what does that mean is, if you initialize the variable with the value 5, you can even change it later. You can do A is equal to 7, right? So the variable remains same, but the value inside it is changed, right? So yeah, this is again a thought from the creator of Django REST framework, which is a Python framework, right? What does that say is that Python are just like socks. This is just again the on the similar terminology that, okay, you can change the value of a variable, but the label will remain same, right? They're saying the color can change of the socks, whatever socks you are wearing, the color can change, but they are always there when you need them, right? Variables are always available in the code when you need them, but yes, the value of that variable can change, right? Okay. So now I hope you have understood what are the variables. Let's see with the help of some code. So let's say I want to give this Rohit, I want to initialize it in memory with a variable called name. So what I can do is name is equal to Rohit. And what I can do is I can even print the variable. Now if I want to print Rohit, I no need to write Rohit in the print statement. I can simply say name, print the name, print the value of this variable, right? Simple. So what it will do is it will again print Rohit. See. Okay. So this is how you can initialize the variables, right? So variables are to identify the label, giving that label to a memory location, and to access that memory location you use variables, right? Now how to name those variables, right? So there are the naming conventions. So these are the 4 rules. One is you can only use letters which are uppercase and lowercase. You can use digits and you can use underscore. Only these things you can use inside the name of a variable, right? For example, A is a variable, name is a variable, right? You cannot start with a letter, or you can, it should start with a letter. Redo. The variable must start with a letter or an underscore, right? It cannot start with a digit. Okay. Now also the variables are case sensitive and you cannot use Python keywords inside the variables, right? What does that mean is, if you see these examples, 1, 2, 3 name, is it a very valid variable? No, it is starting with a digit. It is starting with a digit. You cannot start with a digit. It can only start with a letter and the underscore. My hyphen name, is it a valid variable? No, you can not use hyphen. You can only use these things. You can only use these things into the name of the variable, right? Class is equal to Python. Is it a valid variable? You might be thinking yes, right? Because it has all the letters in it. But no, there are some reserved keywords in any programming language which you cannot use as variable. So class is one of those reserved keywords. reserved keywords have a special meaning to them. So that's why you cannot use them as variables. Okay. So these are all the correct variables. For example, name underscore age, user underscore 123. Right. So let's see some examples just to summarize what you have learned just now. If you want to print a single word, this is how you can do. We have just now printed, right, our names. If you want to print using a variable, I've just now taught, right? If you want to print a name using variable, you can initialize it with the variable and you can print the variable, right? This is how you can do it. Using a variable, you can print a statement, right? How can you print a sentence? You can print a sentence, let's say you have a variable name and you have a greeting. Greeting is welcome to Newton School. What I can do is I can merge these two things and print it as a sentence. For example, name plus greeting, right? So plus is nothing but concatenating two strings. It is merging two strings. So see, Rohit, welcome to Newton School. If I want to give space in between, I can have a space either after Rohit or before welcome. So now it's Rohit, welcome to Newton School. Similarly, you can do it with other ways as well, which we can leave it for now. But if you want to learn those ways, we'll have multiple other sessions as well where you will learn functions, you will learn about strings, right? So yeah, these are again some of the memes about your first program when you write. For example, what was the first thing you have programmed, right? When almost everyone has learned, hello world, right? Other almost identical to hello world, right? So yeah, these are such memes which you can see revolving around the social media. Yeah, now the quiz time. Interesting. So in this video, we'll have quiz as well, where after every question, I recommend you all to pause, think about the solution, and then move forward. So what will be the output of this code? We are initializing two variables, variable 1, variable 2, and we are printing hooray. So it will print hooray, because the print has nothing to do with variable 1 and variable 2, right? Because they are not present into the print statement, right? Now what will be the output of this code? We have length 5, width 10, and area is length multiplied by 5. Length multiplied by width. What are we printing? Area. It will be 50. So which variable names are incorrectly defined based on the Python naming conventions? So you can start with underscore, var1, you can start with these alphabets. This is also a valid variable. Can you start a variable with a digit? No. So this is not valid. Now what will be the result of following code? First name is John, last name is Doe. I have told about concatenation operator, right? So your name is John space Doe. Yeah. So C is the answer. Now what does this code do? We are having X variable initialized with 10, Y variable initialized with 20, and we are printing the sum of X and Y is str of X plus Y, right? So str is nothing but it will convert that integer value 10 plus 20 to a string. It will format it into a string and it will print. So it will correctly print the sum of X and Y as part of formatted string. If you don't know about this str, don't worry, we'll have subsequent session on strings as well. So yeah, now you have done your first Python program, right? And also you have learned about comments, you have learned about variables and the naming conventions. Now what are the next steps? So far you have learned the basics of Python, and now the next steps will be you will be learning about operators into the next lecture. So the operators are nothing but which are very important into programming. Whatever data you are working on, for example, I have given example of calculators. You want to do the sum of two numbers, subtraction of two numbers, you want to write some algorithm, whatever you want to do, operators are the one which are being used, right? Because anything you want to do with a program, you have data and you want to do something on it, right? And to do that operation, you need operators, right? So Python operators are the keys to make self-driven cars, just like Tesla you might have heard. Operators are the reason in Google search engine as well, right? So next time you use an app, the operators are the one which are helping your app to run smoothly behind the scene, right? So in our next class, we'll be diving deep into the world of operators, and trust me, your code will become really smarter and faster once you learn operators, right? And as a last thing, I want to tell you that in the Newton School portal, you can also write the Python code. There is a free Python course available for you. Once you go to the Newton School dashboard, there is a Python 2 placements course. You can go there. There are plenty of learning options. You can select Python basics learning, right? For example, we have just now learned the program for Hello World. You can go there. You can write your code, right? You can write your code, you can run it, and you can submit it. Just a small idea, in every problem here, there will be a problem statement, and it will be explained with the help of sample input and output examples, right? So that you can understand the problem better, right? And this is how you will find any code whenever it is being asked into the interviews companies. This is how the problem is explained to work on, right? So this course will help you a lot to do a lot of hands-on, right? So once you run the code, it will run it on the sample input what you will provide, and once you submit it, it will submit on the multiple test cases, and it will try to see is your code running fine on all the inputs what it has into the backend, right? So before starting telling about the Python operators, till now you have learned about the what is Python, and you have also written your first Python program, Hello World. And you have learned about the very basics like variables, naming conventions, and the comments in the code, right? So these are the very basic things. So before telling you about the operators, let me give you some idea so that till now whatever you have learned, you will be able to relate, and you will be able to understand why we are learning operators, what exactly this is, right? So let me share the whiteboard. Yeah. So when you talk about programming, right? When you talk about programming, what exactly that means, right? So in programming, we write some piece of code, and right now just think that this piece of code is just like a machine, For example, we go to a factory, right? We go to a factory. Let me try to relate this example. We go to a factory, and there is a machine in a factory which actually is responsible to make paper machine. So this machine generates paper, right? Just think of your code also like that, right? So in your machine, what exactly do you do, right? From this machine, you expect some work to be done, right? Some work to be done. Now, what work exactly this machine is doing? It is creating paper for you. Similarly, just see this code, right, as a machine, right? Now, what this machine will do, this will take some input, it will work on the input, and then it will generate some output which you will get as the output of the code. Similarly, here if you are talking about a machine, it will take maybe wood as input, and in return it will do some work, it will work on it, and in output it will generate paper, right? So similarly in programming world as well, we want some input and we want to work on it. Now to want to work on it, you need operators, right? Because without operators, you can just print something, right? But you cannot work on the data, right? So for example, in the last video, I was giving you example of calculator, right? If you want to work on two data sets, A plus B, this plus is nothing but an operator, right? So I hope you get a basic idea about what programming is and where the operators comes into the picture. So operator is nothing but it gives a meaning to your code. It actually gives the actual logic. The actual algorithm is driven by operators only, right? So if you see, if we get back to the presentation, right? Operators, we are just trying to here relate it with the help of a wallet, right? So in this, those who are working professional, they get their salary and slowly it keeps on starting reducing, right? You have some EMIs and all those stuff are there. So just think of the operators like the actions happening with your wallet, right? So what exactly happens is when you want to add money to your wallet, let's say your salary comes in. So when your salary comes into your wallet, what exactly happens? If you want to see, right, your bank balance, it gets added with the money, right? So what exactly happens is, let's say your money is X, it becomes X plus Y, where plus is nothing but an operator, right? It's an addition, it's a sum, right? Similarly, when you spend money, right, your EMI comes in, you go for a shopping, it will be kind of subtraction, right? Then if you have multiple wallets, right, your money will multiply, right? And when you share your money among friends, whenever you go to the outing, you want to split it, it's nothing like you're dividing it, right? So that was just an example to relate what operators are exactly all about. So we have 7 different types of operators in Python. Arithmetic operator, we have the comparison operator, we have logical operator, assignment, bitwise, membership, and identity operator, right? So let's talk about each one of them in detail, right? So if you talk about arithmetic operators, these are used for mathematical calculations, right? So if you see this addition operator, right? If you see this addition operator, this addition operator is plus, right? You have seen in the calculator as well, right? So plus is used for addition, minus is used for subtraction, multiply is used for multiplication, this sign is used for division, this is used for floor division. Now what is the difference between division and floor division? We'll see it. This is used for finding the remainder. For example, if you divide 13 and you do, this is called as modulus 5. So if you divide 13 by 5, it becomes 2 point something, so it will be 2, and whatever is the remainder left, 3. So this is nothing but the output of this operator, right? So more you will get with the practice. So similarly, this is the exponent operator, like the power, right? A raised to power b, right? So you will get with the help of example. Let me show you. So Python division operator is like that one friend who always rounds down the bill when splitting in a dinner. So when you use the division operator, right, if it's like as I given the example, 13, if you divide it by 5, if you use this operator, divide operator, so basically what happens is it's 2 point something, right, but it's always 2, it's round down to a number, right? So it's like that. But in Python, so the division operator gives you the exact value and the floor division gives you the lower floor value of that particular output, right? So imagine you are in a maths class and these operators are the basic maths tools you use to solve the problems. These are nothing but the arithmetic operators. So okay, now I get to know about arithmetic operators, but how to use them in Python, right? Let's see that. So in this particular slide, you can see if you declare 2 variables, these are nothing but variables. We have declared A with 10 and B with 3, right? So A is declared as 10 and B is declared as 3. If you want to do the addition of them, what you can do is you can use A plus B. A plus B, it will be 13, right? A plus B is 13. A minus B is 7. A divided by B will be 3.3, right? But if you see the floor division, if you see the last one, floor division, it will be 3 because it will take the lower value, floor value of that particular answer, right? Multiplication 30. Modulus, if you divide 10 by 3, what will be the remainder? 1. So modulus is the remainder operator. Exponential, if you do 10 raised to power 3, 1000. So I hope all the arithmetic operators are clear to you. Great. Now let's see the second type of operator, comparison operators, right? So these are used to compare values, right? So if you see, double equal to is used to compare if two values are equal or not, right? And these comparison operators returns either true or false. True or false means if that information is right or wrong. So for example, let me give you an example. Let's say your A is equal to 10 and B is equal to also 10. Now, if you see A double equals to B, that means you are comparing both of them. So what will it give? True or false? Both are equal, it will return true. The value of this will be true. And if B will be 3, what will it return? False. Because they are not equal. So this is how comparison operators are used. So similarly, if you see not equal to, that means it will compare both the values, and if they will not be equal, it will return true, otherwise false. Greater than, it will compare if the left side number A is greater than B, then it will return true, otherwise false. Similarly, less than, greater than, equal to, less than. So the equal to operator in Python is like a relationship status on social media, right? If it's true, you are in love with your code. If it's false, you are wondering what went wrong, right? So it's as simple as there are some codes, some funny codes given by the Python creators, Python authors, right? So yeah, they are just trying to compare these things, these operators, and even in the last particular videos you might have seen, they are trying to compare these things with the real life terminologies, right? So these operators are like comparison shopping. You are comparing two items to see which one is better, right? So now how to use that in the code, right? If you see A double equals to B, right? Let's say the value of A is 10 and B is 3. So is 10 double equals to 3? Are they equal? No, false. Is 10 not equal to 3? Yes, it will be true. Is 10 greater than 3? True. Is 10 less than 3? False. Is 10 greater than equal to 3? True. Is 10 less than equal to 3? False. Right. So now let's talk about the third type of operators, which are logical operators. So before that, let's see them with the help of code, whatever we have learned so far. So if you see here, let's say I declare A to be 10, B to be 3, and let's say I'm printing A double equals to B. Let's see. So it gives false because they are not equal. And if I give A not equal to 3, what will it print? It will print true because they are not equal. If I say A greater than B, true because 10 is greater than 3. So similarly, so these are the comparison operators. If you want to use arithmetic operators, if I do A divide by B, it will give 3.333. If I use the floor division, you remember floor division? Let's go back and let me show you. You remember this? 2 slashes, 2 forward slash. If I use this, what will happen? It will give the floor value, which is 3. I hope it's clear. Similarly, if you do plus, what will it give? 10 plus 3, 13, right? So I hope you are clear with arithmetic and comparison operators. Now let's move to the next type of operators, which are logical operators. So these are used into the decision making, right? They help you determine what happens based on the multiple conditions. So yeah, this is again some quote from the Tom Long, right, who was a tech blogger. They said that these logical operators, so and or are two of the logical operators. So what he says is that they are like the two best friends. So one is optimistic, which says that everything is possible. So or operator is used when you are comparing conditions. But if any one of them is true, if any one of them is true, it will say it's possible, it's true. But the AND operator says that if all of them is true, only then it will happen, right? So more you will get to know with the examples, right? So the AND operator returns true if both conditions are true. So logical operators also returns true or false, just like the comparison operators, but they are helpful in making decisions. How? So if you see the AND operator, it returns true if both the conditions are true. If two conditions are given, if both will be true, only then it will return true, right? Or will return true if any of the condition is true. Any one of the condition is true. And not is another logical operator which reverses the state. If it will be true, it will make it false, right? So for example, like let's say the Scotty comes, check this out, and they says these are the two doors, right? And you have two keys, one gold key and one silver key, right? Door one needs both of the keys, golden as well as silver, and the door two needs either. So which logical operator will be used for both the keys in the door one? Just pause the video and think about it. It needs both, right? So it will need and the other will need or, because any one of them will work for it, right? So first one needs both the keys, key 1 and key 2. Second one needs either of them, key 1 or key 2, right? So the logical operators comes in handy when working with Python, right? So if you see this is the example. So let's see this with an example. So earlier we have print a greater than b using the comparison operator, right? So what was the value of it? True. Now let's say I AND it. I use the logical operator and there is another condition, a less than b. So it will be true and false. It will be false because both the conditions should be true if you want AND to be true. But if I use OR, what will happen? It will be true because any one of is true, OR will be true. So if I do not outside of this condition, not, it will reverse it. It will reverse it. So earlier it was true. This whole condition value was true. Now not will make it false, right? So it will be false, right? So I hope you got all the three logical operators. Let's move to the assignment operator, right? Assignment operators are used to assign values. So when we have learned about variables, right, in the last video. So a is equal to 3. That single equal to is nothing but a assignment operator. That is one of the assignment operator. And one more quick thing, you might be confused right now. What was double equal to we have just now learned? It was a comparison operator. It compares the left value and the right value and it gives true or false based on that, right? So assignment operators are used to assign the values, right? So this single equal to is to assign the value. Plus equal to is add and assign. So for example, if you have a plus equal to 10, that means you are writing a is equal to a plus 10. This statement is equivalent to this. So basically you are adding and assigning. Whatever value you will give here, you are adding it and assigning. So let's say the value of a is earlier 3. So it will become 3 plus 10, 13. Similarly, minus equal to, that means a is equal to a minus whatever value you will give at the right side. Similarly, divide and assign, multiply and assign, floor divide and assign, modulus and assign, and exponent and assign. Right? So I hope this is clear. Now let's see this with the help of an example. So 10 x is equal to 10. So it will assign the value 10. Simple. X plus equal to 5, it will become x is equal to x plus 5. What was the earlier value of x? 10. So x will become 10 plus 5, 15, right? Similarly, x is equal to x minus 10. So earlier it was 15, 15 minus 10, 5. Similarly, x multiply equal to 2. So what if you multiply it with 2? 5 into 2, 10. 10 divided by 2, 5.2, right? Now, floor division, 5 divided by 3, it will be 1 because it will be 1 point something. Now, modulus, 1 modulus 0.3, it will be 0.1, the remainder, right? So now let's learn about bitwise operators. So bitwise operators are just like the light switches, right? So you have fans and lights in your home, right? So each switch has a state like on and off. So bitwise operators are just like that. So if you use this single AND, it's nothing but bitwise AND, right? Before this, we have learnt about the logical operators. There we write the AND. This is a logical operator and this is a bitwise AND. That was a logical AND. This is a bitwise AND. If I go back and I show you, so this is a logical AND, right? This is a logical operator when you write AND, A-N-D. But when you use this AND, it's a bitwise AND. Similarly, this single, this is nothing but bitwise OR. This is XOR. So you might have heard about these bitwise operators earlier in maths. This is bitwise NOT. So it will reverse. This is left shift of bits. This is right shift of bits. As simple as that. Right? So if you see this, when you have 5, so x is nothing but 5. X is 5 and y is 3. If you do AND of it, right, you know the value of 5 in bitwise is this, and the value of x and y both will be this, right? So 5 is 0, 1, 0, 1 and 3 is 0, 0, 1, 1, right? If you do the AND of it, it will be this. So this is nothing but bitwise AND. It will do the bitwise operator, bitwise operation, right? On a single bit, it will do AND. So 1 and 1, it will be 1. 0 and 1, it will be 0. 1 and 0, it will be 0. 0 and 0, it will be 0. So this is nothing but AND. Similarly, OR will make it 1 and 1. If any one of them is 1, it will be 1. 1 and 0, 1. 0 and 1, 1. And 0 and 0, 0. So 0, 1, 1, 1. Right? So it's nothing but 7. 0, 1, 1, 1 is nothing but 7 because it will be 1 plus 2 plus 4. Right? So if you are not aware about the bitwise, how the bits works, right? Please go through it once. You can have a check and then you will be able to understand it better. So similarly, we have bitwise OR, bitwise XOR operator, NOT operator, left shift and right shift. So left shift and right shift do nothing but they shift the bits by the number of times. So if you are doing X left shift 1, so you are shifting all the bits to left by 1. Similarly, the right shift. So these are the, so if you see this, how to, use the bitwise operators, you should know how the bits work. So for example, if you see 1 you can write in bitwise as 0, 0, 0, 1. 2 you can write it as 0, 0, 1, 0. Because it's nothing but it works like this. The initial, if you have 0, 0, 1, 0, this will be the 0th bit. This will be first bit, second bit and third bit. So whatever you are using, so it will be 2 raised to power, this is the into 0. So 2 raised to power 0 multiplied by 0. So it will be 1 into 0, 0. Similarly, this will be 2 raised to power 1, right, into 1, right, because this is the first bit. That's why 2 raised to power 1, it will be 2. Similarly, if you see this one, this is the second bit, 2 raised to power 2 into 0. So it will be 4 into 0, 0. So wherever the bit will be 0, it will not have any impact on the value. Wherever bit will be 1, it will have impact on the value based on the which bit is it. So it is the first bit, so it will be 2. So that's why the number is 2. Similarly, 0, 0, 1, 1, it will be 2 raised to power 0 into 1, it will be 1, plus 2, it will be 3. So that's why the 3 in bitwise notation is 0, 0, 1, 1, right? So if you see how it works exactly, if you want to use the bitwise AND, it is nothing but if both the bits are 1, only then AND will be 1, right? Similarly, OR will be if any one of the bit is 1, it will be 1, right? So yeah, this is how it works. Now let's see the membership operators. So these operators are like checking the guest list, right? You are verifying if someone is part of the group or not. You are basically checking its membership. So for example, let's say you are into a club. If you will be a member of that club, right? Yes, you will be. If you have not joined that membership, you are not the member of it, right? So let's see how it works. So membership operators are two. One is in and one is not in. So you check, it will also return true or false. If the value will be present in the sequence, it will return true. If you are not into the sequence, it will return false. And similarly, not in will be the opposite of it, right? So not in will return true if the value is not part of the sequence. So it is slightly opposite of in, right? So if you see sample is a string. It's India, INDIA. It's a string. It's a data. Now you are saying I in sample. This is my code. I in sample. What will it return? Is I part of it? Yes. So it will return true. Z not in sample. Is Z not part of it? Yes. So it will also return true. So if we try to see this, let's say A is Newton school, and if we want to print just similar to this, where we have given this character in this, right, in A. Now whatever character we want to see, let's say we want to see new. Is new part of it? Is that part of the sequence? Yes. So it will be true, right? Now if I say net, is NET present in this complete sequence? No. So it will return false. So these are nothing but membership operators. You are seeing if that particular thing is member of that data or not, right? Now identity operators. So these operators check if the two objects are exactly the same or not, right? So for example, are these two people same, right? So there are two identity operators. One is and one is not, right? It is just like similar to in and not in, right? If is working in a way, is not will work in totally opposite, right? So these are used to compare the memory locations. So in the last video we have seen, right, in the memory our values are stored. So for example, in this memory location 5 is stored, in this memory location 10 is stored. So we are saying returns true if both variables point to the same object. So let's say there is a variable A. This is nothing but signifying this memory location, and there is value B. This is signifying this memory location. So are they same? Are they same? No. So A is B, it will return false, right? But if B will also point to the same memory location, only then it will return true. So if we see again the definition, these are to check if two objects are exactly same. So the variable should point to the same memory location, only then they are identical, right? So for example, if A is 10 and B is also 10, right? Is A is B? True. Is A is not B? It will return false because both the values are same, right? So let's explain the membership and identity, because we have just now seen both of them, right? So if we see this, Michael Phelps is an Olympian. Is, right? You will say true because it's true, right? It's part of it, right? You can compare it with this example. Michael Phelps is not a swimmer, it will become false. Why? Because now is not a swimmer, because he is a swimmer, right? Now if you are saying is not a swimmer, it will be false. So it's just similar to this example, right? Now, if we see not and not in, right, this is and is not, right? We have just now seen identity operators, right? We are trying to see the identity. Now, Rachin Ravindra is in New Zealand cricket team. True, it's part of it. Not in Indian cricket team, that is also true, right? So basically, in and not in, we are trying to see if that particular thing is part of that thing or not, right? We have a group and we have a thing. We are checking if that thing is part of that group or not, right? But in is and not is, we are trying to check its identity. We are trying to check its identity, right? So let's see this with an example. Let's say A is Newton School, B is also, let's say, Newton School. Now if I say A is B, what will it return? A is B, right? So it will return true because both are identical. Both will point to the same memory location, right? So these are again some of the memes related to Python operators. I hope you have got the idea that operators are really an important thing into programming language. So now again, it's the quiz time. Whenever you see a question, think about the solution, pause the video, and then check the solution. So what will be the output of following code? So x is 5, y is 3, x plus 5 will be 5 plus 3, 8. 8 multiplied by 2, 16. 16 greater than 15? Okay, this one is true. The first one is true. And x less than 5, 5 less than 3? False. Not of that? True. So true and true, it will be true, right? Now what will be the result of following comparison? Are they both equal? For example, if I give you two values, 10 double equals to 10, it will become true, right? But here it is here it's a number, right? Now are they equal? This is the assignment operator, right? So it will be false because this is acting like a number, but is it a number? No, right? Now what will be the output of this bitwise operator? 4 and 5. If I have 4, what will be its bitwise value? What will be the bitwise value of 4? 0, 1, 0, 0. Because this will be 0, this will be 0, this will be 2 raised to power 2, 4. What will be 5? 0, 1, 0, 1. Because this will be 1, 1 plus 4, 5. So if you do AND of it, it will be 0, 0, 1, 0. What is the value of it? Again 4. So what are the data types? Data types are like different types of containers. So let me explain this to you with the help of a whiteboard. So we are learning about data types. So as the word suggests, like different types of data, different types of data. So think of a scenario that there are containers which are used to ship different types of item from the sea. So some containers are made to contain a thing which is like some heavy lifting, right? So let's say some containers are used to store some kind of stuff which are heavy. Let's say this container is used to ship cars. There is another container which is used to ship bikes. There is another container which is used to ship the household things, right? So different types of containers are used to ship different types of content in it, right? So if you think about the programming world, in the programming world, what happens is when we are working on a code, right? We work on data, right? We work on data, right? In the previous videos you have seen, we have data 5, we have data 6, then we do a plus b. So we have data and then we work on it using the operators, right? So whenever we work on data, that data is stored in memory. The data is stored in memory, right? So that's here the need of data types comes into the picture. Data types, right? So let's say you have a value where you want to store 5 and there is another data where you want to store 2 lines. For example, welcome to Newton School. This here we are learning Python, etc., etc. Do you think this both data will consume same space? No, right? So in memory, the 5 will take different space in memory, and that complete sentence will take a different space in memory, right? So that's where the need of the data types comes into picture, where we actually declare that in this particular variable, for example, if the variable is meant to store integer, right? So this variable will always store an integer value, and that data type will use specific memory space into the memory. Similarly, if there is a data type B which is required to store strings are nothing but the set of characters. For example, welcome to Newton School, and there are like 2 lines of content. Now we are saying that, okay, this is string, this is going to use the space for multiple characters, right? So that's where the need of different types of data types comes into picture. So each container, that means each data type, is designed to hold specific type of things in it, right? So similarly, each data type is used to store specific type of each data type is used to store specific type of data in it, right? So you cannot put the wrong item in the wrong container, otherwise it will not work, right? So for example, if a data type is allowed to store integers, so we are already declaring that, okay, it will store integers, it will take this much space, and now let's say you start adding strings in it, right? It will not behave, right, properly. So Python has several built-in data types categorized into the different groups. So the 2 basic data types are numbers and strings, which are used to store number values and the strings. And there are 4 different data types which are called collections. So these are nothing but collection of different data, right? Like list, sets, dictionary, and tuple. So these we will learn in the subsequent sections. So let's talk about numbers. The numbers are nothing but like containers filled with quantities. We store quantities in it. We store the numbers in it. For example, amount of money in your wallet. Let's say you have 256 rupees, right? Whatever number it is. It will be a number data type. Similarly, number of cookies you have. Let's say you have 5 cookies. Similarly, distance you need to travel. For example, you need to travel 15 kilometers. So these are all nothing but numbers, right? So why did the integer go to school, right? So because it wanted to become positive and avoid getting divided into smaller parts. So integer is nothing but it's not like it is not having a division value, right? For example, a number can be 5, but it's not 5.3 something. It's not divided into smaller parts, right? So that's where this is just a funny statement given by the author of learning Python, right? So yeah, so numbers can be different types. For example, Monday you have 200 rupees, Tuesday you have 170, and it is keep on reducing as the week goes on, right? So numbers it's just a funny example to showcase that, okay, numbers you can relate it with the values, wherever the values comes into picture. For example, here you are storing numbers, right? Now with the help of numbers you can store 2 types of values. One is integer, one is float. So for example, here a is equal to 10, it's a number, it's an integer, and 10.0, it's a float. 12.234, it's a float. So with the help of numbers, you can store integers as well as float values. Okay. So the statement which I have given earlier, that was for integer, because integer cannot be divided into smaller parts, right? So let's talk about the second type of data type, strings. So first what we have learned is numbers. So strings are like shopping bags that carry text. So for example, in the first initial videos, we have printed hello world. That was also strings, right? So for example, name of the employees, that's a string. Cities the employees live in, name of their spouses. These are all nothing but string data types, right? So string holds a sequence of characters like your name, address, or a message you want to send, right? It's nothing but all is string, right? So strings in Python are like your favorite playlist, right? You can join them. You can, let's say you are playing a song, right? You can play that song, you can slice them, you can split them, right? Whatever complicated things you want to do, you can do that, right? So I'll show that with the help of examples. So string is used to store characters ordered but immutable. So string is immutable. Okay, you cannot change it, right? For example, here is a string which is storing Newton school. Newton school, right? So this is like, now if you want to store multi-string, for example, if you remember that we have also learned about comments, right, in the second video. Now the comments also used to be like single line comment, right? Single line comment used to start with hash, and then there were multi-line comments where we used to use 3 double quotes, right? Similarly, if you want to use a multi-string, right, you have to start it with 3 double quotes and end it with 3 double quotes. So now it will become a sentence, right? This is a single string, this is a sentence, this is a complete sentence. So see, this is a multi-string. It is a small example of how we can use a multi-string format to assign string values in Python. Right? I hope this is clear. So just to explain about strings, let me show you with the help of example. First, let's see integers. If a is equal to 4, it's an integer. If you print a, it will be. If you print a, it will be 4, right? If I have 4.56, it's a float value. Can a store it? Yes, a can have that. Now, if I want to store string, Newton school, will it work? Yes, Newton school. If I want to store multi-string, right? If you see this multi-string, I have to start with 3 double quotes. See, 1, 2, 3, 1, 2, 3. Now this also can be a multi-string. Like this is fine to have it like this. But let's say I want to do Newton school. Welcome to the world of programming. Here we are learning Python. So this is nothing but a multi-string, right? See, right? So I hope you are clear with two data types, two basic data types, numbers and string. Simple, right? You can play around with strings a lot. We'll come to that. Now the third data type. These are nothing but part of collections, right? Different types of collections of data type, right? So lists are like drawers where you can store things that may change, right? List is like a collection of data, right? You can put anything you like in the drawer and it can grow, shrink. You can add more items to it. You can remove items from it, and the list can change over time, right? For example, this is a list. It is storing your books as well. It is storing your clothes as well. So yeah, Python lists are just like your friends. They are keep on changing. They are mutable, and so this is how list works, right? So if you see this list is having 5 elements, 1, 2, 3, 4, 5, right? So this is kind of list of integers, right? So list is used to store collection of data, and it is ordered and mutable in nature. Mutable means it can change. Whatever order you will add, it will follow that order, and it stores the collection of data. For example, here 1, 2, 3, 4, 5, this is data. This is another list. It has a character, a integer, then a character, integer, character. So these are different types of data. So list is allowed to store different types of data as well. Similarly, here the list is storing multiple lists. So if you see, this is one list, this is another list. So this is like list of list, right? This list has two different lists. One list has a character and an integer. Another list also has a character and an integer. Right? Now list functions, right? If you all don't know about functions yet, don't worry, we'll have subsequent videos. But for now, functions, you can just simply think it as functions are nothing but just like we have learned about print, right? Print is also a function. Whatever we give in between, it will print it, right? So functions are nothing but they do some job for you. Like you are not writing code for it, but they are doing the job for you, right? For example, len. Length is a function to check the length of the list. For example, if you see here, print len numbers. Numbers is a list, right? For example, let me declare this list, same list here, numbers is equal to, this is 1, right? This 1 is nothing but these are just the numbers, so we no need to store them as strings, 1, 2, 3, 4, 5. Right? So if I want to print len of numbers, what will it print? What is the length of this list? How many elements it is storing? 5. So the output is 5. Make sense? Right? So here the numbers were 4, so that's why the length is 4. Now if you see max, max is nothing but storing the max value. What is the maximum value here? 20. What is the minimum value? 5. What is the sum of these numbers? 28, 5, 33, 10, 43. Sorted numbers. If I want to sort these, sort means bringing them into the alphabet, sort means bringing them into a sorted manner. So kind of, if you see this, now it is into the ascending order. 5, 8, 10, 20. So if, for example, here also if you do sorted, it's already sorted, by the way, 1, 2, 3, 4, 5, but let's say I divide it, I put 6 in between. 1, 2, 6, 4, 5 will become 1, 2, 4, 5, 6. See? Make sense? So these are kind of inbuilt functions given by the programming language, which are doing job for you. You are not writing code for it, but they are working for you. These are the list functions. Similarly, there are more functions. Append means adding to the end of the list. For example, if I do list.append 30, it will add 30 to it. If I do insert, insert means inserting at a particular place. So it will take two things. One is which place you want to insert. Another is what do you want to insert. For example, here I want to insert 15 at place 1. At place 1. So 15 will get inserted at place. So this is 0th place, this is first place, second place, third place. So 10, 15, then 20, then 30. So we have inserted the value 15 at place number 1. Right? So this indexing actually starts from 0. So first element has the place value 0. Now extend. Extend adds all elements from an iterable. Right? Adds all the elements from an iterable. For example, here you are saying extend 40, 50. Whatever you will give into the extend list, it will get added at the end. So 10, 15, 20, 30, then 40 and 50. They got appended at the end. It adds all the elements which are given into the extend function as a list. Cool. Now there is another function remove. Remove means remove the first occurrence of that value. So I am giving remove 20, it will remove 20. Wherever it will find 20 first, it will remove that. Right? For example, let's say I have 1, 2, 6, 4, 5, 6. And if I say remove, remove 6, numbers dot remove, if I give 6, and then I want to print these numbers, what will happen? Numbers dot remove 6. So 6 will remove which was in the middle, right? But the last 6 persist. Right? If I do again remove 6, it will remove that as well. It will become 1, 2, 4, 5. This is how remove works. Pop means removes and return the element at the given index. Right? So pop, if I give pop 1, it will remove the index 1. What is that index 1? 0, 1, 2, 30. It will remove 30. Whatever index you will give, it will remove that. It will remove and return the element at given index. So pop will remove that element and return that element. For example, if I want to print numbers dot pop, let's say in this the final list is 1, 2, 4, 5. I want to remove 0, 1, 2, second index, and then I will print again numbers. I'm not printing it. Let's remove the print here. It will confuse. I want to pop the second index. It will remove 0, 1, 2. Fourth will be removed. Now it will be 1, 2, 5. Let's see. 1, 2, 5. But if I want to print that popped number as well, I can print this as well, because this function, pop function, will return that number as well which is getting popped. So it has printed 4 because 4 is getting popped out. Now clear means removing all the elements. If you do clear, the list is gone. If I do numbers dot clear and then I print numbers, what will happen? What will happen? Empty list. All the numbers are gone. Clear? So these are list functions. Now coming to the next function, index. It check the index. For example, if I do list dot index of 20, what is the index of 20? 0, 1, 2, 3, 4. It is, the index is 1. Now if I do count, count means count of elements. If I do list dot count 10, how many 10s are there? 1 and 2. 1, 2, 3. So it will be, it will count the number of elements in the list. Right. Now sort will do the sorting in ascending order. Sorting in ascending order. For example, this is the list. It will sort that in ascending order. 10, 20, 30, 50. Right. Now if I do sort with reverse equal to true, it will sort in descending order. So I am saying numbers dot sort reverse equal to true, it will make it 50, 30, 20, 10. Right. Now if I do numbers dot reverse, it will just reverse the order. So it will become 10, 20, 30, 50. Make sense? Cool. Now the next data type is, after list, the next collection data type is dictionary. Right. So list was just to store the data, to store the elements, different type of data you can store in it. Now dictionary is something different. You have used dictionary, right, in your school time or college time, when you used to see the meaning of words, right? Oxford dictionary and different dictionaries we have. So dictionaries are like the address book where each entry is like a key value pair. For example, in the dictionary, what used to happen? There used to be a word and then there used to be a meaning for it. So just think that this is a key and this is the value for it, right? So key is like the name of the person in your address book, if you are talking about address book, and the value is like their phone number. So for this person, this is the phone number. For this person, this is the phone number. So this is like kind of a dictionary, right? So how does it work in Python? So this is again from the Python expert. Dictionaries are like smartphones. You just type in the key and it instantly pulls out what you are looking for. So in the phone book of smartphone as well, when you type the name, you get the phone number, right? It's as simple as that. For that key, give me that value. For this key, give me that value, right? So now let's get the explanation. Let's take an example of address book. So dictionary, like the name in the address book is like the key, right? The phone number is the value associated with that key. For example, in a dictionary, you are having the person which is Rohit, right? That's the name, right? Now for this particular key, the mobile number 9214 ding, ding, ding. So this is the key, this is the value associated to it. There can be another value also associated to it, maybe my address, So this is nothing but the name in the address book is like key and the number or the address can be the value, right? So it's like key value pair. Like you are saying, give me the phone number for Rohit. So what it will search is, it will check in the dictionary, it will check, okay, where is Rohit? The number will be just putting beside it, right? The number will be just present beside it, right? So it is used to store collection of data in key value pair. How do we store it in key value pair? For example, if you see this is a dictionary we are initiating, right? If you see this dictionary, here we have 1:1, right? How is it colon? Then 2 colon this. So for 1, the value is 1. For 2, the value is this list. For the key 3, the value is this. For 3, the value is another dictionary, right? If you see, for the 4, the value is a string. So it's not like it contains a specific data type. No, it can have different type of data, but key is a single data type, and the value can be anything, right? For example, for 1, the value is this. For 2, the value is this. For 3, the value is this, right? So now we will, before moving ahead to the list of keys, list of functions into the dictionary, let's see dictionary with an example. For example, this numbers, let me call it as dictionary, print the dictionary, right? So in this dictionary, I have to do it into these curly braces, right? This is how the dictionary will work, right? In this dictionary, what I am giving is, okay, for the key 1, the value is 1, right? For the key 1, the value is 1. Let's say for the key 2, the value is Rohit. For the key 3, the value is Newton, right? So if I run this, let's see. So it will print the whole dictionary. For 1, it's 1. For 2, it's 2. Now, I can also make it like this. So if I do it, school, right? Now what happens? Now the key is school, the value is Newton. So what actually happens is you can have different type of data for keys and different type of data for values as well. Now let's see the different types of functions in dictionary. The first one is keys. It returns the list of keys. For example, if I do dictionary.keys, dict.keys, what will happen? It will return 1, 2 and school. 1, 2 and school. Why? Because these are the keys. Values, list of values. It will return list of values. Right? If I do dict.values, what will happen? It will return the values 1, Rohit and Newton. Right? Now pop key, it will remove the value. If you want to remove a particular key, dict.pop, let's say I want to remove this 2, and then I want to print the dictionary, let's say. I'm popping 2. What will happen? This 2, this key 2, the value pair for the key 2 is gone. Now it's 1, 1 and school, Newton, right? It will remove the value, right? It will remove the key value pair. As I did pop, this key value pair is gone. Now pop item, it will remove the last pair. If I only do pop item, this is the pop item, right? Pop item. What will happen? It will remove the school Newton. The last pair is gone. If I do update key, update, and I give a key, it will add all the key value pairs whatever you will give. For example, if you see this, update country comma USA, it will add country comma USA at the end, right? Now get key will return the value for that key. So if I do get dot get, if I want to get it for 2, what is the value corresponding to 2? Rohit. So it will return Rohit, right? Let me remove this pop item. I'm just printing the dictionary and getting the value for the 2. It is Rohit. So I hope these functions are clear. Dictionary is clear. Now the third collection is tuples. So tuples are like the sealed envelopes that is once packed, it cannot change. It cannot change. The value cannot change, right? So just remember this, that the value can't change. Once it's packed, it cannot change. It's perfect for storing things that shouldn't be changed, right? So tuples are like your first love. that never changes, right? So that's immutable, right? So once you commit to them, there is no turning back. So yeah, so tuples, how is it different from the list? It's like, let's say tuple, let's say there is a name and a rank. Can it change? For example, you are giving some exam. Now you got your first rank. Will it change? Once you assign this value, will it change? Your rank will remain same, right? For that particular exam. So tuple is used to store the data in an ordered way, just similar to list, but it's immutable. The list was mutable, but the tuple is immutable. So it's as simple as, let's say I want to create numbers, but now in the circular basis 1, 2, 3, 4. Now this is nothing but a tuple. If I want to print numbers, what will happen? It will print this 1, 2, 3, 4. Right? It is a tuple. Now this is a tuple of tuples. These are two different tuples. Now this is a tuple which is having a list and a dictionary. So the data inside tuple can be of any type. Right? It can be of any type. Right? Now let's see the function. Count. It count the occurrences in tuple. For example, count 20. How many 20s are there? 2. So the answer is 2. Index, it returns the index of the first occurrence. What is the index of the 30? First 30? Third. 0, 1, 2, 3. So the answer is 3. Make sense? Okay. So these were the tuples. Once declared, you cannot change. Now the sets. Right? What are the sets now? We have learned about the dictionary. We have learned about list and tuples. Now the sets. Right? So sets are like the collection boxes where you store items, but you only care about whether something is in the box, not how many times it appears. Right? For example, you can compare it with a box where there are different types of items. But if there is a similar item, set doesn't care about it. Let's see, right? So let's say that you have a collection of rare coins. Each coin is unique in it. So set will have only the unique values and no duplicates are allowed. So yeah, there is another, there's a tech blogger, Tom Long, what he says about the sets is that I tried to add duplicates to a set once, but Python was like, no, you can't do that. Right? So let's get into the explanation, right? How this set works, right? So treat it as a container that stores unique values. So whenever set comes, just think that you are talking about unique values. You are talking about unique values, right? So treat it as a container that stores unique values. So the values may have duplicate entries, but it only shows unique values, right? You can store duplicate values in it, but it will only show the unique values. For example, let's say in this set you have 1, 2, 3, 4, 5, right? So it is used to store unordered. Now the order is not maintained in sets, just like lists and tuples, and it stores unique elements. For example, here in the set 1, we have 1, 2, 3, 4, 5. In the set 2, we have 1, 1, 2, 2, 3, 3, 4, 4, 5. You can add duplicate elements, but it will store only the unique elements. Let's see it. So let's say we have a set and we will have the curly braces for this, right? This is the set. I'll give it a name as set 1. Now I am printing this set 1. What will it print? It will print 1, 2, 3, 4, right? Now if I have another 4 here, what will happen? Another 4 here, it will still print 1, 2, 3, 4 because the duplicate 4, it already has 4, it will keep only the unique, right? For example, even if you have a 4 in the starting, that's why the set is unordered, right? I hope you get it now, because it will remove the duplicate elements. See, now again it is 1, 2, 3, 4. Right? It is unordered. The order is not maintained, but unique, right? So these are the functions. If you see the add function, it will add element. For example, if I say add 50 to it, it will add 50 in the end. it will add 15 then. You update function is used to add multiple. For example, I think here the example is not there. So if I want to add the element, you can add a single element, but if you want to add multiple elements, you have to use update. So what will you do is set1 dot update. So I want to add let's say 8 comma 20 comma 30. Let's see what will happen. So I have to give it as a set. I have to give it as a set. So now 1, 2, 3, 4, 7, it was present earlier. Now 8, 20, 30 is added. So update is used to add multiple elements, right, into the set. Now remove is used to remove a particular element. For example, if I want to say set1 dot remove, in this I want to remove now 20. This 20 I want to remove. So it will remove 20. Let's see. See, the 20 is gone. But if you say remove 100, what will happen? Is 100 part of set? No. It will give error. Error gives? It does not have. 100 is not there. Now discard, it will remove, but it will not give any error. For example, if I, rather than remove, if I give here discard, but with value 20, what will happen? 20, okay. Now, if I give 100, it will not give any error at least, just like remove function, okay. Now pop will remove random. Pop will remove random. For example, if I use pop, it will remove a random element. For example, here if you see 1 is gone, right? It will remove random. Now if I want to clear the set, I can do like, okay, clear. It will remove all the elements from the set. Right? It will remove all the elements from the set. Now the set is gone. Right? So I hope this is clear. These are all again the memes what you can find about the different types of data in Python. That again tells that okay, the data types are important. They are relevant in programming. Without data types, it will not behave. Your programming will not behave properly because it has to do a tight coupling with memory, right? So that's where the data types plays an important role, right? So now again, quiz time. Whenever you see a question, just think about the solution and pause for a moment and then check the solution, right? So x is 1 and then y is 1 comma. You are printing type x is tuple and type of y is int. Type is like again a function. So what is it? Is it tuple and type y is int? Is it true or false? False, right? Because you are having the curly braces. What was the tuple? If you see back, right? What was the tuple? You can have it into the circular braces, right? But if you see the int, is that a int? Is y a int? No, that's also a tuple. Yeah, now this is interesting. We have a set where we have 1, 2, 2, 3, 3, 3. What will be the length of the set? Will it be 6 because there are 6 elements? Think about it. No, it will be 3 because set store unique elements only. You can give as many duplicates as you want, but set will only store uniqueness, unique elements. Now this is dictionary, right? We have a person dictionary where name is key, John is value, age is key, 30 is value. Now we are printing person height. Now is that key present? No, so it will be a key error. Now we have an items, right? This is a list where we have apple, banana, cherry, and we are saying that okay, this list of 2 is equal to orange, and then we print it, it will become orange. So the cherry will become orange because at the second index you are making it orange. What are the different types of operations we can perform on the strings? So the first operation is concatenation. Concatenation means joining two pieces of strings. You can think of it like, let's say there are two ribbons. You are just tying them up, right? So this is anonymous Python developer's code, that why do strings always bring their friends to the party, right? Because they love to get concatenates. So it's just a funny thought about the concatenation operation, right? So let's see how the concatenation works. So let's say you have hello and you have world. These are the two different strings. Once you will concatenate them, it will become hello world, right? So this is how the concatenation is performed. There is a plus operator. Plus operator is used to do the string concatenation. So the output of this program will be hello space Python. Hello Python. So concatenation means binding two or more substrings together, right? So substring is nothing but, you can say, the part of a string. Substring is a part of a string. So you can concatenation, you can say like you are combining two strings, or you can say combining the two substrings which are going to be part of a single string. So the next operation is repetition. Repetition means we are going to repeat the string multiple times. So let's see how we can explain it in simple words. So let's say we have hello plus world. After concatenation, it will become hello world. Now, if we want to repeat it three times, it will be hello world, hello world, hello world. So how to do the repetition? Using the multiply operator. If we do S1 multiplied by 3, it will be hello, hello, hello. So let's see this with the help of a code. So let's see that, let's say S1 is a string which is Newton. Now I want to print S1 plus S2. What will be the output? It is concatenation, right? It will be Newton's school. Now if I want to do this S1 multiplied by 4, what will happen? Newton, 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 4 times. This is like repetition, right? Now next is indexing and slicing, right? Slicing a string is like cutting a piece of paper, right? For example, so this is again a quote from a anonymous developer, that why does string always get into the argument with a list? List is again a data type, right? We have learned about it in the last video. So why do they both argument? Because string said that I can get sliced anytime, right? And you just index, right? So I can slice any way I want and you just index it, right? So string means it, why the string is arguing with the list is that I can store whatever I want and I can slice, I can get sliced as well, right? So let's see how we can explain it in simpler words. So let's see what is indexing and slicing, right? So once we have this hello world, right? So slicing the text, here we are slicing the text from a space. We are slicing it from hello space world. We are slicing it. Hello becomes separate, world becomes separate. So if you see this, indexing means every index, every position of a string, it has a particular position number. So indexing starts from 0th position number. So if you see Python, P is at 0th index, Y is at first index, right? And so on. So if you see this, if we want to print text of 0, that means the character at 0th index. What is that? P. So if we see it with the example of a code, if we do S1 of 0, it will print N. If we do S1 of -1, it will take the index from the last, N. If I do -2, what will it give? It will give O. So if you give it in the negative, it will start picking from the back side, right? So that's why here text of -1 is N, right? Now text of 1 to 4, that means you are saying selecting the index from 1st to 4th. So 0, 1, Y, 2, 3, 4, YTHO, YTH. So you are printing the index starting from 1 till less than 4, till less than 4. So it's YTH. For example, here if you see S1 of 1 to, let's say I want to do 3. 1, 2, 3. So it will print E and W. So starting from 1 till less than 3, E and W. Right? So this is how this works. And now if you want to give only the second index, it will print starting from the 0th index. So till third index. So 0, 1, 2, 3, PYTH. Right? Here we are printing from the second index till end. 0, 1, 2. Second index is T, THON. Right? Here we are printing every second character. If you give this two double colon, right? That means you are asking to print every second character. So this is second character is P. Starting from P, every second character. Starting from the first character, every second character. P, T, O. P, T, O. Right? And if we give it with the double colon, if we give -1, that will reverse the string. That will reverse the string. So now it is printed in the reverse order. NOHTYP. So this is nothing but indexing, and using this we are also slicing as well. We are slicing, like in this third, if you see the third one, here we are slicing it. We are taking the string from first to third index, right? Cool. So I hope you got the idea about slicing and indexing. Moving on, strings methods, right? So methods are nothing but functions which again do some task for you, and you are not writing the code for that, right? How to write your own functions, we will learn that in the subsequent videos. Now let's see what are the inbuilt methods we have for strings, right? Cool. So see, the first method is here. Let me use the pen. So the first method here is lower. Lower means, the first method here is lower. Lower means we want to print it in lowercase, all lowercase, right? So lower means we want to print it in all lowercase. So if I do text dot lower, everything will get printed in lower. For example, if I do here S1 dot lower, what will happen? N will also become lowercase. See, everything will become lowercase. If I do upper, what will happen? Everything will become uppercase. See, so these are the strings methods, right? Now the title, right? So it make it into the title case. So if you see this title, so every first character will be capital, right? So if I do it title, and let's say the first character is also small, now see what will happen to Newton. N becomes capital, because this is how we write titles, right? So it will become the title case. Capitalize means it will capitalize all, right? Capitalize all. See, capitalize all, right? Swap case means whatever will be lower, it will become uppercase, and whatever will be upper, it will become lowercase. So let me show the swap case, right? So let's say initial characters we have NEW as capital. Now NEW will become small and TON will become capital, Newton. So it has swapped. Whatever is in lowercase become uppercase, and whatever is in uppercase becomes lowercase, right? Cool. Now let's go ahead for string checking, right? String checking means searching for the specific item in the particular string, right? For example, let's say someone has kids in their home, they want their kids want to search toys in a set of toys, right? So that will be like you are checking something in a mixed set of toys, right? So this is what we are going to do in string checking. We are going to searching something, right? So you are looking for a particular substring, a particular small string inside a bigger string, right? So let's see how it works. So let's say I want to see sharing is caring, right? If you see the string checking, so I want to check if the text starts with sh. If the text starts with sh, right? Does it starts with sh? Yes, true, right? So sh is part of sharing is caring, right? So it will return true. So what are the methods available for string checking? So if you want to analyze it, right, earlier what methods we have seen were the methods related to the string, general methods like making it lowercase, uppercase. Now we are reading the methods which are related to checking, right? So for example, we have a method with the name starts with, right? So you are actually checking if the string starts with something, right? For example, if here I use starts with and I give it like NE, what will happen? Does the Newton starts with NE? Yes, true. If I give here SH, SG, what will happen? False, because the S1 does not starts with SG. Similarly, we have other methods as well, like ends with, like if the string ends with a particular string or not, with a particular substring or not. Is alpha means if all are alphabets. For example, here we are checking S dot is alpha. Are all alphabets here in Python 3? No, false. It contains number as well, 3. And then is digit checks if all are digits. For example, if the string will be 1, 2, 3, 4, it will return true, otherwise false, right? Similarly, is all num, that means are all the characters alphanumeric, that means either alphabets or numbers. So that's why here is num is giving, is al num is giving true, because it has alphabets as well as numbers. All are either alphabets or numbers. Now is space means if all are white spaces or not. If all are white spaces or not. For example, if here the string is all spaces, now here if I give this method, that whatever the method is space, is space. So is S1 all space? True. Yes, it's all space. If I do it with S2, what will happen? If I do it with S2, what will happen? It will be false. Right. So these are all the checking methods. Now string modification. What are the methods available for modifications, right? So for example, imagine you decide to replace sugar with honey somewhere, right? That means you are doing some modification in the process, right? So similarly, there is a replace method which swaps out the part of string with something else, right? Which swaps out the part of string with something else, right? That's how you modify the string. So let's see this with an example in a simpler manner. So here we have NOWTONSCHEEL. So you want to change the spelling of the words. Now once you do the change, it will become Newton's code. So this is nothing but modification. But let's see how the modification works in code, right? So for example, these are all the methods to do the modifications. So strip is a method to remove all the white spaces in the string, to remove all the white spaces. For example, here in this Python, we have the white spaces before and after. And if I do text.strip, all the white spaces are gone. Now the only Python remains, right? iStrip means it will remove all the leading white spaces, the starting white spaces. And rstrip means it will remove all the ending white spaces, trailing white spaces. Now replace is important one, because you want to replace something into the string, some part of the string with something. So if you see this text dot replace pj, so you are asking to replace the p with j, so it will become Jython. P is replaced with j, right? So these are all the methods for string modification. Now next is finding and counting, right? So if you want to find something, if you want to look something into the string, that means finding. You are finding some substring into the string. And if you want to do some count of some characters into the string, that's what counting is, right? So let's see how we can explain it into a simple words, right? For example, here if we find and count S and I, right? Here S is present how many times? If we see in the Mississippi, 1, 2, 3, 4, and I 1, 2, 3, 4. So I is also present 4 times. So we are basically finding S and I and counting how many times is it present. So these are the methods. So find is the method to find the index of the substring. For example, if you do text.find A, right? Where is it present first? A can be present multiple times, right? But where is it? Which index is it present first? 0, 1. So answer is 1. Now text.count A, how many A are present? 1, 2, 3. So the answer is 3. This is how you can find and count. These are the functions to find and count. So now splitting and joining. Split means you want to split string into multiple parts, right? You want to make it into the smaller parts, right? And joining, how we can join two strings, right? Let's see that. So yeah, this is again a funny line from a Python expert, David Beasley, that why did the two strings get married? Because they wanted to join their lives together, right? So this is like the property into the Python, right? So let's see how the splitting and joining works in a simple words. So for example, how to understand what is splitting and joining? Let's say I want to split text and join this with a placeholder. So let's say we have welcome to Newton School, right? So you are splitting it between welcome, then to, then Newton, then school. So basically you have split it from the white spaces. Split it from the white spaces, right? And then you have joined them with a placeholder. What is the placeholder here? Star, right? So this is the literal meaning of what is splitting and then again joining, right? So these are the methods. So see, split. Split means it will split into list. It will split the string into list. For example, if I do text dot split, it will split the text from white spaces and it will create a list of those words. For example, now the Python is different, is different, and fun is different. It becomes a list, right? So the split functions gives the list of words inside a string, right? And similarly, join will joins elements with a separator. For example, here if I do this dot join words, now we have words here. Words are nothing but different strings. I want to join them using this particular separator. So Python dash is dash fun, right? So let's see this with an example. Let's say we have a string S1 where we want to say welcome to Newton School, right? Now if I want to do split, what will happen? Words is equal to S1 dot split. Now if I want to print words, what will happen? It will print the list of all the words. So welcome to Newton School. So this has now become a list, right? Now I want to join them with a separator. So let's say S2, rather than sentence, let's take S2. So S2 is equal to, I want to join them, let's say with a star. So star dot join, right? Star dot join. Join what? What? You want to join all the particular strings into the words list. And then let's say I want to print S2. What will happen? What will happen now? See, welcome star to star Newton star school. So we have split and then we have joined with the separator. Now escape characters. Escape characters are like special keys into the keyboard, right? Think of them like a secret codes, right? So let's see within example, right? So this slash n, this is required for new line. For example, if you see in a string hello slash n words, it will print hello world in two different lines because slash n act as a new line. It's a escape character. So for example, in after welcome to we have, let's say, slash n. Yeah. So it become welcome to, and then whatever is after this is coming into the new line because slash n is new line. Slash t is tab. Slash t is tab. So it will give a tab space. Tab space. So let's say I give it slash t. So now see the space will increase. See, after 2 the space is now equal to the tab space, right? Now this is backslash, right? So if you see this, this is backslash, right? If I put that particular thing, see what will happen. See, it has put a slash. If you want to put a single slash, you have to put this symbol, right? This is the backslash, right? So if you see this here, we got one backslash, right? Now single quote. This is to add the single quote. If I want to add single quote in my string, I have to use it like this. See, welcome to quote, single quote, Newton School. Now the double quote. For double quote, then slash double quote. Slash double quote. Because the reason is, if you will put the double quote directly in between, how will it get to know that string is ending here or here? Are you getting the point? So that's why the escape character comes into picture. You have to use it like this if you want to actually use double quote in between the string or the single quote, right? So these are all the escape characters: new line, tab, backslash, single quote, and double quote, right? So yes, like for example, this is the welcome to Newton School. If you want to add a new line in between, you can use slash n. So the welcome to and then Newton School will come at a separate line, right? So these are again some of the memes you can find related to the string operations, right? So yes, this actually gives the importance of strings currently in the market, because whenever you talk about different types of data, right, string is really important, because without string you cannot store the data which is very relevant. For example, if you want to store the address of a particular location, if you want to store the mobile number, all this you have to store it into a string, right? Because mobile number is a huge number, right? You can use it into the long integer as well, but the string is very important. So now again, quiz time. After every question, pause the video and then check the solution, right? So Python, and then the another S2 is Python with the P smaller. Now I'm saying S1 dot lower. What will be the S1 dot lower? P will become small, right? This will become S1 dot smaller, S1 dot lower, equal to S2, and S1 is not S2, right? So are they both equal? Are their value both equal? Yes, Python. And is S1 is not S2? S1 is not S2, yes, because both are pointing to different locations. So it will be true because both the statements are true, right? So both values are equal, but they are not same. They are not same. Okay. Now hello slash n word. So phrase will be hello and word will be in the separate line. Now we are printing the length of this phrase. How many characters are there? Hello is 5, world is 5, what is /n? So it is 11, because the new line is also one character. That is an escape character, right? So total will be 11. So now Python is fun. We are doing the swap case. Whatever will be capital will become smaller. Whatever will be smaller become capital. So see, P is smaller and rest should be capital. See, right? See, now we have data. We are stripping it. Once we strip, all the white spaces are gone. It will become data. Right? It will become data. Left and right, all white spaces are gone. Strip. Now we are actually slicing it. So we are saying greeting string 1 to 5. What is the first index? 0, 1, E. Starting from E, 2, 3, 4. ELLO. ELLO. Starting from first index to less than 5. So 1 to 4. So whenever you write a particular piece of code, what do we expect from it? We want to give it some input. And in return, we want some output. For example, let's say we have a calculator, and in the code, we want to give a number A and B, and in return, we want A plus B. That will be some number C. Right? So whenever we write code for this type of problem, what do? A is equal to 4, B is equal to 3, and then we do A plus B and we print it. It will print 7. Right? But whenever you use calculator, does the input always remain same? Do you always give 4 and 3? No, right? You can give any number anytime. Maybe you can give 100 plus 17. You can give 20 plus 50. Right? So these inputs should be taken from the user into the code. Yes or no? These input should be taken from the user. And then the output should come. For example, if A is given 20 and B is given 50, C should come 70. If A is given 5 and B is given 3, answer should come 8. So that's where the input-output operation comes into the picture. So let's start it. So think of input like receiving orders. You are receiving the orders. So think of input like receiving orders. You are receiving the order from your client. Let's say you are into the kitchen. You are taking the order from a person who has came to a restaurant that, okay, I want this, I want that. Similarly, in the code, you are receiving the order as a user input. So yeah, this is again a quote from David Beasley, who is a Python expert, that inputting the data in Python is like conversation with your computer. You are giving your own input, right? For example, when you use calculator, you are actually doing the conversation with the calculator. You are giving input, it is giving output. You are giving a different input, it is giving output, right? It's similar to like nowadays you are using chat GPT. You are giving some input, you are getting output, right? So you speak to it, you speak and it listens, but sometimes it just said, I don't understand. For example, let's say the calculator is asking you two numbers, but let's say you give some strings. The calculator code will error out, right? Makes sense, right? So the user provides the input just like a customer telling you what they want to order. Like the customer is telling you what they want to order, right? So let's see, let's explain it in a simple words. So let's say that the chef starts making a recipe, right? Now the chef says, I need a plan, right? So chef will take a pan, right? Now the chef needs the ingredients, right? Now the chef needs the spices, right? Now the chef is done, right? And the dish is done, and the input works in the same way, right? You keep on giving input and the program will give output, right? So here the chef is nothing like your code, right? You are giving input and then it is working for you, right? So to take the input into the Python code, there is a function called input function. There is a function called input function. So the input function is used to take the user input from the keyboard, So you have to use this function called input, right? So whatever input you will give, it will take it. For example, if I give 3 as a user input, it will take it like, please provide a number to print, right? And then the S1 will be whatever input you will give here, will come as output. See, please provide an input to print, it printed 3. If I give input as 15, it will print 15, right? So actually this also depends upon different types of compiler. In this Python playground, you have to give the input initially, right, before running the code. But in most of the compilers, what happens is that you run the code and then it will wait at the terminal. You can give your input on the fly, right? For example, without giving the input, you can run the code. You can try it in your any other compiler. Without giving the input, you can run the code, and then once you run it, it will wait for your input. So you can give the input on the fly. Right? So whatever input you will give here, it will be taken as a user input into the code, right? So for example, here we have the input, enter your name, and then let's say you give the name. After enter your name, the terminal will wait. You give the name Alice, and then you are printing hello Alice, right? Cool. So by default, input returns a string. The input function returns a string. It always takes input as a string. To make the numbers as input, you need to convert them into int or float. For example, if someone gives the input to be a number, right, and then you want to convert it to a int, right? Let's say I don't want to print anything. You want to convert it to int. For example, I give 20. Now the S1 will become integer. Right? Output is 20. But what if I give input as a Rohit? It will give error, because whatever input you are giving, it will not be able to convert it into int. See, invalid literal for int. So input is taken fine. There is no problem in taking the input as Rohit. But the thing is, it is not able to convert to int. Similarly, if you take float, if I give, let's say, 5, it will convert that to float as a decimal value. See, 5.0, right? So if you want to convert your string input into integer and float, you have to convert them using the int and float function. So that's why we are using int outside. See, float outside. So if you give enter your age 20, it will take it as int. Now age will be a number. 20 plus 1, 21, because we are printing age plus 1. Similarly, if you enter the price 45, it will take it as 45.0, and then you are multiplying it with 1.18. So yeah, again, there is another funny quote from Tom Chris, who is the creator of Django REST framework, which is a Python framework, right? So what will you call when the Python asks for input, but then it just stares at you because it is waiting for your input, right? I just explained, right, that in most of the terminals, what actually happens is, whenever you ask for the input in the code, you run the code, it will wait for your input. So it's something like it just stares at you. So how does it feel like? It's like the command line where it is waiting for your input. It is in relationship with you, where lots of questions are getting asked, but no real answers. You are not answering to them. So basically the Python is waiting for your answer, right? So let's say I want to take multiple inputs, right? So you can use split. You can use the split function to take the multiple inputs. For example, I take input and I want 2 numbers. So how can you get 2 numbers in one go, a comma b, using the split function. So it will take a and b as these two numbers, 10 and 20. So this is how you can use the split to take the multiple inputs, right? So here we are taking two inputs in one go, right? Now what if I want to take the input as a list? I want to take it as a list, right? So I want to take a lot of data at the same time, right? So what I can do is, so in the previous example, if you want to use this input, because earlier we were taking this input as a string, because by default input returns string, right? And we were splitting it, right? So when we were giving 1, 5 and 7, the output was 1, 5, 7. But if you want to treat all of them as integers, you have to map them to integers. If the input is a single number, you can simply do int and then you can convert it to int, right, using the int function. But here we have multiple numbers, right? So input dot split, it will give you multiple strings. So we are mapping it to integers. We are mapping it to integers. So now a, b and c will act like integers. So that's why the output will be 1 plus 5 plus 7, 13. Right? So this is how the map function works. So now I hope you get to know what is map. Now if you want to take it as a list, so what you only thing you need to do is you can just use the list function, that's it. And let's say the name of the list is a, it's a single variable, right? Now if you want to print a, it will be just a list of numbers. See, 1, 5 and 7, right? What if I don't use the map function here? What if I don't use the map function here? What will happen? So it will treat them as strings, right? For example, here if I give something different, but the space is there in between to split, right? So what will happen? See, now these all are different strings, right? So map is just to map the multiple inputs to integer. We were using it for that. And the list is used to take the whole input as a list. So I hope you get to know what is the importance of this list function, right? So the next one is default value. So if the user presses enter without typing anything, right? So what will happen is you will not give any input. Input function will try to check the user input, but there will be no input. So it will give an error, right? But if you want to give some default value, you can give it like this, or guessed, right? Here we are saying input this or guessed. So if the user will not give any input and press enter, it will take the default value whatever you are giving after or. So it will print hello, name will be guessed because you have already given the default value. Right? Now the character input. What if you want to take the input as a character? So the input function takes it as a string always. So if you want to take it as character, you can take the first 0th index, right? So for example, you want to take input of 0. So a will now be character because you are taking the 0th index of that string. So let's say you pass input as Newton. It will print a will be n. A will be n because you are taking the 0th index. Right? You can select any index whatever you want from that, but when you are expecting a character from the user input, you know that user will always give a single character, right? And then if you will take the first index, it will throw error because there is no first index, right? There is no first index. So that's why we always used input of 0 for taking input as a character because we are expecting a single character, right? So from a string which has a single character, it can only have a 0th index, right? So this is how the character input works, right? So now let's do the quiz. So I again suggest you all that whenever the question comes in, just take a pause, think about the solution and then move forward, right? So here, first of all, what is it, right? What is the output? Assume the user entered 5. It's in the triple quotes, right? Triple double quotes. So it's a multi-line comment. This is just the information for you about the code. This is not the actual code, right? So we are assuming that the user will enter 5, right? So let's see the code now. Num is equal to input, enter a number, and what is entered? 5. So input 5. So we are printing 5 multiplied by 2 equal to 10. So think about it. So what will be 5 multiplied by 2? Input always returns a string, not an integer. So if you want to take integer, you have to convert it to int, right? So 5 multiplied by 2 will be 55. Whenever you multiply string with a number, it will repeat, right? So 5 5 is 5 5 double equal to 10? No, false, right? This was interesting, right? So the next one is age. We are taking input, enter your age, and then we are multiplying it by 2. What will it print? Again, same question. So let's say the user enters 20. The comment is saying user enter 20. 20 multiplied by 2, 2020, because it will be a string. Now again, we are taking the input and then we are splitting it. And we are assuming the user entered 5 space 10. So if you split it, input will be 5 and 10, two separate strings, not integers. So we are saying first plus second, 5 plus 10, 510. Because input always returns string, if you want to create it to integer and float, you have to convert it. And if you want to take it as character, you have to take the 0th index of it. Right? So next one is input, enter your favorite color or blue. What is that? Default, right? So assume that the user presses enter without typing anything. So what will happen? Favorite color is, if the user doesn't give any input, let's say user just clicks enter, it will be blue. So favorite color is blue. So D will be the answer. So now again, input, enter a word, you are taking the 0th index. It will, and let's say the user enters hello. So it will be the output will be H. So the string what will get printed is the first character is H. A will be the answer. So let's start the topic. So what are the conditional statements? So I gave you an example of a voting system, right? For example, you go to a voting booth and there is a software to allow people to enter or not, right? So inside that software, there will be some code which will have some conditions, right? For example, it will have a condition that it should ask user as input its age, right? And if the age would be more than 18 or more the age for voting, then he or she should be allowed to enter, otherwise not, right? So these are the scenarios where conditions are very much required into the code, right? Now there is another example. Imagine that you are driving through a traffic light, right? The traffic light controls whether you should stop, go, or slow down, right? Based on the 3 lights, red, yellow, and green, right? So inside the traffic light, there must be some logic running behind the scene, which must be saying, okay, if this much time is done, I should show green. If this much time is done, I should show yellow, right? So that's where the conditions comes into the picture into a program, right? So if the light is green, you go. If the light is yellow, you slow down. If the light is red, you stop, right? So there is another example that imagine you are deciding whether to go outside based on the weather, right? So that's where the conditions comes into the picture. You will say, okay, if it's sunny, you decide go to the park. If it's rainy, you decide staying inside, right? So this is how you can think that, okay, what are the conditions in your real life as well, right? So you have to apply some conditions in your day-to-day life. Similarly, you have to apply conditions into the program logic as well. So that's where the conditional statements comes into the picture. So this is again a funny quote from David Beasley, who is a Python expert related to the conditional statements. So let's see how this condition works. So the if statement check if a condition is true and execute the block inside it, right? So let me explain this with the help of a whiteboard. So let's first understand what is if. So as you all know the literal meaning of if, right? So if means that, okay, if this condition is true, right? So there will be a if statement, and then there will be a some piece of thing you want to do. So you will have a condition inside if. If that condition will be true, this thing will execute, otherwise not. As simple as that. So let's see. For example, you have entered age. If age is 20, right? It's a hard coded. We are not taking the user input. So if age is greater than equal to 18, we are saying print you are an adult. Otherwise, we are printing you are a minor. So that's how the if statement works. So whatever you want to do, if the if statement is condition is false, you can write it into the else block, right? So if this condition will not be true, then else block will be executed. If this statement will be true, then the if block will be executed. So let's see this with the help of a code, right? So we have defined here age to be 18, and we are writing our own logic, whatever logic you want to write based on your business requirements. So we are saying if age is greater than 20, we are printing adult, otherwise we are printing not adult, right? So let's see, our age is 18. Our age is 18. It has print not adult, because it will be adult if it is greater than 20. Let's say I put it 21. Now what will happen? It will print adult. It will print adult. So this is how if else works, right? Now if the condition will be false, the else statement will execute. The block, the whatever block below else statement will execute. There is another one which is elif, right? So imagine you are on a diet and you have multiple options depending upon the meal preparation. For example, every time there will not be a scenario that you will only have two options, that if else. There can be a conditions based on multiple scenarios. For example, let's say you want to print the day, if it's Monday, Tuesday, Wednesday, based on the day number. So if it will be 1, it will be Monday. If it will be 2, it will be Tuesday. If it will be 3, it will be Wednesday. So this is how these are like multiple conditions, right? So similarly, if you have, let's say, 10 minutes, you will go for oatmeal. If you have an hour, you will go for salad, because you can prepare it. If you only have couple of minutes, you can go for a banana. So there are like multiple conditions. If else works on a single condition. Okay, if this is true, this will happen, otherwise this will happen. So elif is able to handle multiple conditions, right? So this is again, there is a statement from an anonymous Python developer that I once had a elif statement that tried to make decisions based on multiple conditions. It felt like I was running on a talent show where the program was judging multiple contestants. If they didn't make the cut, they would get eliminated, right? So let's see it with an example. So let's say age is 70 and we are having now multiple conditions. If age is less than 18, we are printing you are a minor. If age is less than 60, we are printing you are an adult. Else we are printing you are a senior citizen, right? So elif is nothing but it acts like else if. It's a second condition. So any one of them will execute. Any one of them will execute. So if age will be less than 18, it will print you are minor. That's it. It will not go into the elif. It will not go into the else. And there can be multiple elif statements. There can be multiple elif statements. So if it will enter into, if let's say age will be 40, it will not go to age less than 18. Age less than 60, it will enter. It will print you are an adult. That's it. It will not go into else. Similarly, if the age will be more than 60, then it will go to else, right? It will be greater than equal to 60, because it will not go either in if and neither it will go in elif, right? So instead of using multiple if statements, we use elif to check additional conditions, right? So now one thing might be coming in your mind, can we use multiple if conditions, right? So let's see it with some example. So what if you use multiple if conditions in such scenarios? So let's say we want to put if this condition is true, you want to execute a block. If this condition is true, you want to execute this block. If this condition is true, you want to execute this block. Let's say this is your code. In contrast, you have a code where you are saying if this will be true, execute this. Elif this will be true, execute this. Elif this will be true, execute this. Else execute this. Let's say you have something like this. Right? Now let's see the difference. Here what will happen is you will be able to execute only one out of them. Let's say if this will be true, this code will execute and then rest nothing will be checked, because this is part of the complete condition. But here what will happen is every if will check, because every if is a separate set of code. So this will also be checked, this will also be checked, this will also be checked, right? So for example, let's say you have a code where you have the code which are not dependent on each other. They are like separate if conditions, separate conditions. So you have to use this scenario. But if something is the place where you have scenario which are dependent, for example, I gave the scenario of printing the days. There you have to use this only. Because if you will use like if day number is 1, execute this. If day number is 2, execute this. So the code will work fine, but you are checking redundant if blocks. If you have the day number 4, you are printing Thursday, you should exit, right? So this is something which should work, where the conditions are dependent on each other. They are talking about the same scenario, right? So this is the difference between using multiple if conditions separately and using the elif. Now shorthand if else. So imagine you are at a grocery store with 2 lines, right? There is one line here and one line there, and one line is short but one is long, right? Now you have to make a quick decision. What will you do? If the short line is available, you will go there and your job will be done, right? Why will you stand at the long queue, right? So you can write the if else statement in a single line as well using the ternary operator. So that is something called as a shorthand if else. You no need to write a lengthy code. You can do it in a single line as well. So if you see this, let's say age is 16 and you want to do if age is greater than 18, you want to print adult, otherwise you want to print minor. So what we are doing is, this is a ternary operator. This is a ternary operator where we are using if else in a single line. So what we are saying is status is equal to adult if age is greater than equal to 18, else minor. So we are doing it into a single line and we are printing the status, right? So now let's see the nested if else, right? Nested if else. So just now we have talked about a ternary operator, which is a shorthand form of if else. Now nested if else. What is nested if else? So imagine you are planning a trip, but your decision depends on a series of conditions, right? So for example, first you check if it's weekend, and then you check if it's weekend, you check another condition, if the weather is good or not. So you are basically having condition inside a condition. So this is nothing but nested if, right? Because if one condition will be true, only then you will check another condition, right? So the first branch will lead to a set of decision, and each decision led to the further choice, right? For example, if weather is good, you decide to go hiking. If weather is bad, then you will go to else block, you decide to go indoors. But then if it's not weekend, you decide to work or study, right? So let's see it with an example, right? So this is again thought from the creator of Django framework, that if my program had feelings, right? If I want to add some emotion, some feelings, so I would imagine it get pretty overwhelmed by the number of choices I will give. So more the number of choices your code will have, you can add more feelings to it, right? So it's just like, just make a decision already, right? So let's see what is nested if else. So let's visualize it with an example. So let's say initially you have a choice, if is it a weekend, you want to check. So if it's a weekend, you'll go to if block, otherwise else block. Simple, right? So let me use the pointer. So if it will be weekend, you will go here, otherwise you will go here. Simple if else. But if this will be true, then you have other conditions. If it's weekend, you will check if it's good weather or it's bad weather. Then there is if else inside if, right? Similarly, in the upper else block, you are just saying okay, work or study. Simple. So else is done. Inside if you have two conditions, inside good weather, then you are saying okay, I'll do hiking. So basically it's like having if else inside if or inside else. It's like conditions inside condition, right? Let's see it with an example. So if you see this if block, we are checking if age is greater than equal to 18, then we have another if else inside that if. If your age will not be greater than equal to 18, then you directly go to else and you will print you are minor and cannot enter. But if your age will be greater than equal to 18, then we have a nested if else. Nested if else means it's inside a condition already, right? So then we are saying another condition if has permission. Has permission is a Boolean value. It's a Boolean value. Boolean is nothing but either true or false, right? So if this will be true, then we are printing you can enter. Else you are saying you cannot enter, permission required, right? So it's like condition inside a condition, right? So you can nest if statements inside other if statements, right? To check multiple conditions. So this helps in checking the multiple level of conditions. So that's what called nested if else, right? So these are again some of the funny quotes, some funny memes you can find related to conditionals, right? So that's what says the importance of it, because without if else you cannot add those emotions to your code, right? You will have a single track, you will keep on going, right? Your code will not work that way, right? If you want to make your algorithm taking the decisions, if you want your algorithm to take decisions based on conditions, right? That's where these conditional statements comes into the picture, right? So again, our quiz time, let's follow the same rule. See the question, pause the video, and then move forward after thinking the solution. So what will be the output of this program? We are having, I'll use a sketch pen. What will be the output of this program? We have x to be 5. We have y to be 10. We are saying if x is greater than 3. Is it greater than 3? Is 5 greater than 3? Yes. So you will go here. So now else will not run for sure. Here is y less than 10. Is y less than 10? No, it's equal to 10. So else will print. So B. B is the answer. Now another question. So score is 85. Score is 85. We are saying if score greater than 50. Is it greater than 50? Yes, you will just enter here. You are saying you are passed. Other conditions will not be executed. So it will say you passed, right? So it's saying what is the mistake in this code. So this will execute, but can you see there is a mistake? So your if will already execute. It will not go to, otherwise what it should have happen is, the score is 85, it should go to the, it is greater than 75, it should print great job. So don't you think that condition should be first, right? So if you see this, score variable is not defined, that's not the mistake. There should be additional else if block, no. The elif condition is never reached, yes, that's the mistake. The elif condition is never reached, but we wanted to make it reach based on our logic, business logic, right? So C is the answer, right? So the sequence of condition also matters, and that you will decide based on your logic, whatever business logic you want to put, right? Now see, what is the output of the number for the number 5? Okay, let's see. So number is 5 initially. Now we are saying if number modulus 2, if we divide it by 2, what will be the remainder? 1. Is it 0? No. So if will not execute. Now else response will be odd. So response will be odd. So this will execute. Response will become odd. Now if number modulus 5 is 0, is number modulus 5 0? Yes. Because if you divide 5 with 5, remainder is 0. Then response you are adding, you are appending to it, plus equal to, that means response is equal to response plus this. So we are saying odd and divisible by 5. Earlier it was odd, then we are adding odd and divisible by 5. So D is the answer. Now another question. So word is alphabet. If A in word, is A part of word? In is, we are checking that if is A in or not in. You remember the operators. So if A in word, yes, A is in the word. So else will not execute for sure. If word dot index of A less than 3, what is the index of A? It's at 0, 1, 2, 3, 4. So A is at 0th and 4th index, right? But index will give the first index, right? Is it less than 3? Yeah, so it will be first half. So first half is the answer because index will give the first index, so it will be 0th, right? Now age is 25. Next question, age is 25. Membership value is true. It's a boolean. So if age is greater than 30, is age greater than 30? Yes. Or not of membership. Not will do the opposite of membership. What is the value of membership? True. Not of true is false. So we are saying age greater than 30. 25 is greater than 30? No, sorry. So that's not greater than 30. So 25 is less than 30. That will be false. So we are saying false or not of true. Again false. So false of, so if we do false and then there is or and then again false. If both are false, it will be or will be false, right? So what will happen? Will it execute? No. Access will be granted. So answer is granted. So in any programming language, functions are very important. So imagine you are in a kitchen cooking a dish, right? So a function is just like, you can say, a recipe, right? So you follow a set of instructions. Let's say it is given to you by a function, right? And then you get a final dish, right? So you can relate it like the function is acting like a small part of your program which is doing some work for you, right? So let's see this with an example. So in the initial videos, I explained you that you can think of a program just like a factory, right? This is like your program. So in factory, what happens is you give some input and then out of the factory, you expect some output. For example, for a factory, the input can be a wood, raw wood, and the output can be a paper. Now inside this factory, there will be multiple machines, right? Multiple small machines doing their work. Think like that. So inside this factory, there will be one machine, second machine, third machine, fourth machine. And then maybe you are getting the final output. Maybe this final machine is responsible to give paper. And this first machine is responsible to take the raw input wood. But first machine is not able to do the complete work by itself, right? Maybe you can create such kind of machine, but don't you think managing that kind of machine will be complex? Because if that machine will be gone, your whole factory work will be switched off, right? So that's how what happen is there will be multiple machines, they are doing their small work. Maybe this is able to do some task, then this is taking the input from whatever this machine has created and doing another task and doing another task. Just giving an example. So similarly, in a program also, there can be multiple functions which act as a small machines helping that program to complete the work, right? Now let's get back. So that's what we are saying, that we are also able to relate it with the kitchen example, that function is just like a recipe. Now it's not like the function can be a complete recipe for your program. It can be a small, it's doing the small task and rest is done by maybe some other functions, right? Now let's understand what all are the part of functions, right? Let's see that. So let's say you have a function in a program. Let's say this is your function. The function has a code. Let's say this part is a function. Now function also expects similar to what a complete program expects, right? So a function can take an input and in return it can give output. So whatever input you give, those are called parameters. Or maybe you can call it attributes as well. Function attributes. And this is called function body. Whatever logic you will run, this is called function body. These are the input to the function. And then in return, function can give an output that is called return type. So whatever type of data, you know what is data type now, right? So let's say this function returns integer, the return type will be integer, just like that. So let's see this with an example. Okay. So similarly, for a recipe, the parameters are like ingredients, whatever you are saying. So that's like an input for the function. Then the cooking steps are nothing but the actual function. That's a body. And the final dish will be the return value, the return type, right? So whenever you want to make a dish, you follow the same recipe and you can give maybe the different ingredients. The body will remain same and then there will be different output, right? For example, if you will have a function where there will be a body, now based on whatever input you will give, it will give us different output, right? It's like we were doing till now simple programs, right? If you will give a calculator a plus b, if whenever a and b will be different, the output will be different, right? Similarly, it happens for functions as well. If you will give whatever input you will give, you will get a different output, right? So functions in Python are like superpower, right? You write the code once and then you can reuse it whenever you want. For example, let's say you write a function. How to write function, we'll get to it. But let's say there is already a function in your program which takes two numbers a and b and it returns back sum of two numbers. Now let's say you are writing your program and you want to take sum of two numbers maybe in multiple places in the code. So what you will do, okay, you have value x and y, you will do x plus y, then you have a and b, you will do a plus b, then you have m and n, you will do m plus n, right? But this is actually a small code, but think that a function can contain a big code as well, right? A function can manage the calculations, the complex calculations, right? So you can actually reuse that. So rather than doing the sum calculation again and again in my program, I can simply call this function by giving different input. And in return, it will give me the sum, as simple as that. So you can reuse those functions, right? How we can do that? We'll see it. So let's visualize this with an example. So let's take two slices of bread. Then we add vegetables, add cheese, right? So then what happens is, if you combine them, it becomes like a cheese sandwich, cheese veg sandwich, right? So now this is kind of a logic which takes two breads, vegetables and cheese. Let's say this logic is packed. Now you can use this function every time you want to make sandwich. You no need to reinvent that logic again and again, right? So this is an exercise, right? First, you will write the logic for this task. Use an, let's say you have to perform an even odd check task, right? Redo. So now there is an exercise. Let's say you have to perform a even odd checker if the number is even or odd, right? So first you will write the logic for this task. Use an input instance to get the number from the user, and then use conditionals to check if the number is even or odd. Simple. So let's do that. Let's say we have a number a is equal to input, but whatever input you take that will be string. We have to convert it. So now let's say this will be int. If I want to print a, let's say I want to give input to be 15, then it should also print 15, right? Printing is not defined. Oh, I have to use print, not printing. So what happens? It prints 15, right? We have taken an integer input successfully. Now we want to take the input from the user and we want to apply these conditions to check if it's even or odd. So what I can do is, so yes, if a modulus 2 equal to 0, then we are printing even, right? We are printing even. So I think this indentation was missing here. So it was 15, now it will print odd. If I take it to be 16, it should print even, because if you divide it by 2, remainder will be 0, right? So this is how we have did this exercise. Now what are the possible challenges here? You will have to repeat the same process every time you need to perform even odd check in your complete program, right? So just don't think it as a single program. Let's say you have a very big program. This is just 4 or 5 lines of code, right? But let's say you are writing a huge code, and everywhere, or maybe let's say in your whole project, there are multiple files, multiple logics. How is it managed? You can ignore it for now. But let's say there are multiple files, multiple logic in your whole project, and multiple places you need this even odd checker. What will happen? You have to write this logic again and again. If a modulus 2 equal to 0, print even, otherwise odd. So rather than that, can't we have it as a single machine, a small machine, which someone can call by giving the number, and then that machine can tell either even or odd, right? So that if you will have it everywhere separately, right, you will not have a good readability because the same code is repeated again and again. You will not be able to do proper debugging, maintenance, scalability, all will go for a toss. The reason is, if for a particular kind of work you need some logic, for example, for even odd checker, this is a logic. Someone can use this logic at a place, but someone can use this logic by mistake doing it differently at some other place, right? So just think, let me use the whiteboard to explain it. So let's say the same even odd checker is used in the program somewhere here, and somewhere here as well. So let's say the first person and the second person written this code correctly, but someone used this even odd checker wrong. Then, and let's say that mistake has already happened and now the code is running. So what will happen is, while debugging the code, we have to see where exactly the even odd checker has gone wrong. Is it here? Is it here? Or is it here? But rather than that, if we have it at a single place, we just need to check it at a single place, right? So it will make it easier to debug where something has gone wrong, right? So now if we use a function for this task, we will be able to reuse it. It will be having easy debugging, maintenance, it will improve readability, easy testing, and there are multiple other advantages which you will get more with the practice, right? So now functions are of two types. One are inbuilt functions. Till now we were using so many functions, like print was a function. We have seen so many functions in collections, data in the data types. We have seen functions in the string operations, right? So these are all are inbuilt functions. Inbuilt functions are, Python has provided us those functions that are available for our use without needing to write it. We don't need to write them. For example, this len, this was a function, this returns the length, right? Then type, this returns the type of that particular data, type of that object, right? If you say type of a, it will say okay, it's integer, right? Min, it returns the minimum value out of all the values. Max, sum, range. So these are all the functions which are given by Python to us. We no need to write the logic for them. And the other kind of functions are user-defined functions, which we will write, right? So an inbuilt function is like going to a fancy restaurant and where you don't need to cook your meal, you simply order from the menu and you get it, right? So you are not doing any recipe, you are not doing any algorithm for it. You are just getting it, which is already done by someone else, right? These are the inbuilt functions. So for example, if this is already given to you, can you make me a sandwich? You will just say that. That function is already ready. You don't need to invent it, right? So for example, if you have this list, this is a list, right? If you remember from data types, right? So Python provides several built-in functions that are available to use without needing any import. You don't need to import any functions. The functions are already there. So for example, if you print len of numbers, and now this numbers is nothing but now you will be able to understand. Len is a function. Inside it, it is taking numbers. Now numbers is nothing but input. What do we call it? Parameters. So here numbers is acting as a parameter for len function, right? So what happens is len of numbers will return 3. Then that 3 is acting as a parameter for print. 3 is acting as a parameter for print function, right? So this is how the inbuilt function works. Now user-defined functions. User-defined functions, this is how where you will learn how you can create your own functions in Python, right? So these functions you have to give, they can accept parameters which are the input for the function, and then they will give some output which will be the result of the function, right? So this is the syntax of a function. How you can do this is, one important thing is function name. To create a function, there are few important things. So let's see how to create functions. First, you need to decide what will be the function name. What will be the name of my function? For example, in the previous slide, this inbuilt function, what was the name of the function? Len, max, min. These are all the name of the functions. Okay, function name. Second thing will be the input for the function, which are called as parameters, right? Which are called as parameters. So let's see. So here you will give function name, and before that you have to use the def keyword. So you remember, right? In the when we learned about variables, I told you cannot use reserved keywords as variables because they have their specific meaning, right? So def is one of them. So when you use def, that means you are defining a function. So first you have to use def. So let me put it in the starting itself. First you have to use def, then you give the function name, and then the input for the function. Now it is not necessary that input is always there or the return will always be there. But these are just the things which are needed to define a function. Now if you need them, if you don't need them, that's up to you, right? So this is how you give the, this is where you give the parameters, right? Parameters are the input, and then colon from where the body will start, then the body, and then you need to use the return statement to return some output, right? So yeah, passing the arguments is very important. Arguments, or you can say parameters, right? Attributes, right? So whatever parameters you want to pass or arguments you want to pass to a function, right? That you need to understand, because you need to practice a lot how to create your functions. Then you will get the idea, okay, how I can pass arguments and how I can return. Arguments and parameters are the same thing, right? So a user defined function is like creating your own custom recipe. It's like creating your own custom recipe. It's not inbuilt, you are creating it, right? So instead of following someone else's recipe, which is like the inbuilt function, you are coming up with your own set of instructions, right? So here you are saying I will make my sandwich, right? So let's say how you can create your own functions in Python using the def keyword. So this function will accept some input and in return will give some output. So for example, I want to create a function def with the name greet. So greet is the name of the function. See, this is the name of the function. Now what will be the input parameter? Let's say that parameter name is nothing but name, or you can say n. It can be anything. So this is the argument or the parameter for the function, right? Now the function will start. Now what this function will do is it might be doing multiple things. It might be doing n is equal to n multiplied by 10. It is doing some things. And then we are saying return, and then let's say this function is returning something. Let's say this is returning hello plus, let's say we are plus doing the n, right? We are appending n to it, right? Now how we can use this function? We can just call it. We can simply call it. So what we can do is we can create a result variable and we can just call this function. Now you can call the function multiple times. You can call function any number of times. So we are calling greet with the input, let's say 4. Simple. And then let's say I want to print this result. Print this result. What will happen? So whenever we call this function, the call will go to the function. Now what is the value of n? 4. So we are making n is equal to 4 into 10, 40. So it should print hello 40. Right? Let's see. So we have to convert n to string. Otherwise, n is a integer, right? N is a integer, right? So you should also know how to solve these errors, right? So what we are printing hello 40. What if I give the argument to be 5? What will happen? N will become 5 into 10, 50. So it will print hello 50. Let's see, hello. What if you give argument to be 7? It will become 7 into 10, 70. So it will be hello 70. So I hope you got it. You can call the function any number of times. Any number of times. Let's say I want to call it with different input multiple times. 4, 5, 6. What will happen? It will print hello 40, hello 50, hello 60. So that's how you can reuse this code multiple times. We are reusing this code multiple times, right? So similarly, there is another function where you are taking 2 arguments. You can take n number of arguments. You can take multiple arguments. So here we are taking a and b and we are returning a plus b. So this is a function for sum of 2 numbers, which I was giving you the example. So if you call add with 5, 3, it will go, the call will go here. It will return 5 plus 3, 8 and it will print 8. Right? Similarly, another function. So here we are talking another concept called as default parameters. For example, here is a greet function which is accepting the argument name, and then it will return hello comma name. So you can call the greet function with John and it will print hello John, right? But what if someone doesn't pass anything? What if someone doesn't pass anything? So you can also define the default parameters, default value of that parameter. So here we are defining name to be guessed. It will act like a default value. If someone will not pass the value of name, the name will be guessed. So it will be hello guessed, right? But if someone will not give the default value, if this equal to guessed will not be there, then this greet will not work because you have to pass the argument. If the default parameter value is present, then you can ignore it. You don't need to pass it, maybe it will work. But if you will not have the default parameter, then you have to pass it. Otherwise, you cannot call that function. It will error out, right? Yeah, now important thing, lambda function. So a lambda function is a small anonymous function. Its length will be very small, defined using the lambda keyword. So till now we were using the def keyword. Now we are using the lambda keyword, and lambda functions are generally used for the short simple operations, for the short operations. So let's see, its syntax is just like, you no need to use def, you use lambda, then you give the arguments, whatever arguments you want to give, and then the expression, the code, right? Let's see. So lambda functions are like, coffee breaks in Python. You don't need a full function. It's just like a sip of a coffee, right? Sip of a code. Right? So a lambda function is just act like a quick recipe that you can prepare in just few steps. So let's see how it works. So let's say you don't have time to chop vegetables, but you still want to make the sandwich. You can take just 2 slices, just spread, use the sandwich spread and do it. So lambda functions are very small for the small work you want to do, right? So let's see how it works. So the syntax was, you can use lambda, then arguments, and then expression. See, so we have used just lambda, the arguments, and then the code. That's it. So for example, when we want to write the code for sum of 2 numbers, how was that? Let's say there is a code sum, it is taking a comma b, and let's say then it is returning a plus b. And if I want to call this sum, what will happen? Let's say I want to call this with 4 comma 5. It will print 4, it will return 4 plus 5, 9, and we are printing result. But if I want to return it using lambda expression, how you can do this is, you can simply say result is equal to lambda. So lambda is a function. You are just writing it in a single line, lambda, and then you need 2 arguments, a comma b, and then what is the logic, what is the expression you want to do on that particular argument? You want to return a plus b, right? So this is nothing but a function, and what will be the name of the function? You have to give it before equal to. Let's say the name of the function is again sum1. Now you can just call this function. So you can call this function sum1 with 2 arguments, 4 comma 5. Right? You can do it in the same way, equal to sum1 4 comma 5. So what will happen? It will again print 9. So let me just comment this code. For you. So if you just see this is a lambda function with the name of the function is sum1. Lambda is the keyword, then these are the arguments, and this is the output. That's it. So if we call this sum1 with 4 comma 5, it will return 4 plus 5, which will be 9. If I call it with 4 comma 8, it will return 12. So lambda functions are just like the shorthand functions. It is like we are using the lambda function for the short simple operations. That's it. Now functions and if-else conditions, right? So the functions and if-else conditions are like a recipe with choices. So when you are using a function, just like a normal code, whenever you write a program, function is also like a small part of your code. So whatever you can do in a program, you can do it in a function. So in a function, you can use if-else statements, right? For example, this is your function, def, check age is the name, and age is the argument, parameter. And inside it, you are using conditions, using conditionals inside function. So if age is greater than or equal to 18, return adult, otherwise return minor. So return is nothing but the function is returning something. So a user-defined function allows you to define the function that can include if-else conditions as well, right? So function is just a small machine out of the big machine, which is your complete program. That small machine can have any type of code, as simple as that, right? Similarly, if you see lambda function, so if you say lambda Then age is a parameter, right? If you see this, before colon it's parameter. Age is a parameter. Then what we are saying, adult if age is greater than or equal to 18, else minor, right? So this is like in a single line. So in the lambda function also you can use if else, right? In the lambda function also you can use if else, right? Now what are recursive functions? Recursive means one after the other, right? So for example, whenever we have a function, let's say we have a function which has a piece of code. So we can call it anytime, right? Let's say we call it, it gives us some output. Let's say we call it, it gives us some output. Simple. What if that call is happening inside the function itself? Let's say this is the function and inside it there is a logic. But there is a statement inside the function itself rather than some other code calling it. There is a statement which is calling the function itself. So calling the function inside itself is called as recursive function. We are calling the function inside function, right? So a recursive function is like a set of Russian dolls, right? Each doll contains a smaller doll and so on, right? And then to reach the smallest doll, you have to keep unpacking the dolls. So let me explain that as well. So let's say in a function there is a code, and inside that code you are calling, and then there is another code as well. Here you are calling the function itself. So what will happen? The call will go here. Will these statements execute? No. Then let's say the second call is happening. The first call came from somewhere, and then inside function you call the same function. Then the second call comes, then you call it again, then you call it again. Don't you think it will go infinite? The call will go infinite, the functions will go infinite. But this is not right. Otherwise your code will never come to an end. Your code will never come to an end, right? So to stop this, there should be some condition. There should be some condition which is called as base case. So there should be some condition to stop that recursive calls. So let's say that condition met, and then you end the recursion. So you go back, and once you start going back, this code will start executing, right? So it's as simple as you just see. So let's say from some place you are calling a function, and in that place, for example, in this code, we were doing the print of result as well, right? But till the time this function will not execute, will this print execute? No. So till the time function will come back, we cannot execute further steps, right? So this function has to return, and then rest of the code execute in the program. Similarly, in the recursive code as well, if the function is calling itself again, till the time the call comes back, the rest of the code will not execute. As simple as that, right? So that's what I wanted to talk about recursive functions. So let's see it with an example. So there is an example of factorial, right? You know factorial, right? So 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, right? And what is 0 factorial? 1. So I hope you already know this with the mathematics. So a recursive function is a function that calls itself to solve a problem, right? Recursion is typically used for the problems that can be broken down into smaller subproblems, right? So for example, let's say you talk about factorial. Let's say you want to find out 4 factorial. What is 4 factorial? 4 multiplied by 3 multiplied by 2 multiplied by 1. What is the answer? 24. Can we say 4 factorial is nothing but 4 multiplied by 3 factorial? 3 factorial is 6, 6 into 4. Can we say 3 factorial is nothing but 3 multiplied by 2 factorial? So can we break this problem into smaller problems? So because if I know 3 factorial, I will be able to calculate 4 factorial. So you can actually break this problem. So that means you can use recursion. That is one thing. So recursion is generally used when the problem can be broken down into smaller problems. Now, how we can solve this is how we can solve this factorial using recursion. So let's say I want to find out 5 factorial. Inside the factorial function, let's say you have a function where in this particular code you are able to find the n factorial, right? So can you say that you can just call this function to find out the factorial of n minus 1 and you multiplied it by n and that thing you can return. So if you see carefully, we are actually using the recursive function. We are calling the same function with the different parameter. Earlier we called it with n, now we are calling it with n minus 1. Why? Because if you take the example of factorial of 5, you can say it's nothing but 5 multiplied by factorial of 4. You can say this is nothing but 4 multiplied by factorial of 3. What if you keep on doing it? What if you keep on doing it? Let's see. Factorial of 3 will be 3 multiplied by factorial of 2. Factorial of 2 is 2 multiplied by factorial of 1. Right? And then factorial of 1, if you keep on doing it, what you will do is 1 multiplied by factorial of 0. And then if you keep on doing it, what will happen? You will say 0 multiplied by factorial of minus 1. Does this make sense? If you will do, does the factorial of minus 1 exist? No, right? So somewhere you have to stop the recursion here. This is here you have to use base case. This is where you have to use the base case. So if you simply see the function, how it works is, we are using df factorial, n is the input. So we are making the recursive call, we are returning n multiplied by factorial of n minus 1. And as soon as the base case reached, if the n becomes 1 or 2, you are simply returning 1. So that the recursion will keep on going back. Recursion will keep on going back. So if you try to do this, right, if you try to see how this code is working, so let's say you call this function with value 4, right? Let's say you call this function with value 4. Is n 1 or 0? No. So you are calling it again with 4 multiplied by factorial of 3. You are calling it with 4 multiplied by factorial of 3. Right? Then the call will go back. To the same function. Is n 1 or 0? No. Then it will again return. What it will return is 3 multiplied by factorial of 2. Factorial of 2. Is n 1 or 0? No. So what it will return is 2 multiplied by factorial of 1. Now for this particular call, is n 1? Yes. So we will return 1. We will return 1 to whom? If this call will go, this will return 1. 1 back, right? And as soon as we got f of 1, factorial of 1 to be 1, then the factorial of 2 will return, because it was already into the else condition. It will return 2 multiplied by 1, which is 2. Then this will return 3 multiplied by 2, which is 6. And then this will return 6 multiplied by 4, which is 24. So this is how recursion works. So this is nothing but recursive function. Now what are nested functions? Nested function is nothing but that is defined inside another function. So a function can have the definition inside another function itself. For example, this is your outer function, def, outer function, a and b are the parameters. And then we have inner function, which you can actually use inside the body of outer function itself. For example, you have an inner function which returns the sum of two numbers. Now you can use this function inside the outer function only, right? You can say result is equal to inner function a comma b return result, right? So you call the outer function with the parameters, then you already have the inner function, which is just a function. Without calling the function, it will not execute. Now inside the outer function, you are calling the inner function with parameters, whatever you got. It will go, a and b will go here, it will return the sum, and then it will return the value, right? So a nested function is nothing but function inside function. So you want to write some logic as part of the logic of a outer function, right? So yes, these are again some of the memes related to functions that signifies how important these are, right? Let's go to the quiz time, right? So again, whenever the question comes in, pause the video, think about the solution, and then move ahead, right? So what will be the output of this code? We have an add function where x is there and y is equal to 5. We are returning x plus 5. This is a function, right? I hope you know what is y is equal to 5. Let me show that. You remember this default parameters? You can give using the equal to keyword, right? This we can edit in between. So we are having x and y is equal to 5, right? The default value of y is set to be 5. Now we are saying print add of 2. So we are just passing a single parameter. So y will remain default. And we are returning 2 plus 5 is 7. Equal to add of 2 comma 5. Here we are passing the y to be 5. So when there is default parameter, you can pass it or you can ignore it. So it will be equal. So it's true. Now there is a function make tea where we have water, default value is hot, and leaves, the value is none. So if leaves is none, leaves is green, and otherwise we are returning, if the if block will not execute, we are simply returning f of water, the value of water, this water, then we have a string water with, then the value of these leaves, tea leaves, right? So we want to call this function with leaves value to be black. So we are passing it to be black, right? So is leaves none? No. So what will happen is hot water with black tea leaves, hot water with black tea leaves. Because we are passing the value of the leaves, we are passing it to be black, right? So now we have a function calculate sum, which is taking the two parameters a and b, and we want to print a plus b. This is not returning anything. This function is not returning anything. So we are having result is equal to calculate sum 5 comma 3. What will happen? It will go here. It will print 5 plus 3, 8. 8 will be printed. And then we want to print result as well. What will be the value of result? Is it returning anything? So if the function doesn't return anything, the value will remain none. So it will print 8 and none. The result will remain none. Got it? Great. Let's move to another problem. Here we have a function called multiply, which has parameters x and y. And we are taking the multiplication of it and setting it in another variable called product. So we are calling print function with multiply 4 comma 5. Is 4 comma 5 returning something? No. Is multiply returning something? No. It will be none. So we are saying print none. We are not passing any string. So what will happen? No return statement, right? So the error in this function is no return statement. If there is no return statement, the print function will not work, because print needs something to print, right? So it will bring out none, but print actually needs a particular string or the data to print, right? Now the scope in functions. So this problem is related to scope. So we have a message, hello world. This is a variable outside. Then we have a function, change message, and inside it we are reinitializing message to hello Python, right? We are changing the value of message. Now we are calling the change message first. What will happen? Message will become hello Python. If we print message, what will be the output? Hello world or hello Python? Let's see. So it will be hello world, because whatever you change in the function will remain in the scope of the function itself. That value will not be impacted outside. If the function call is done, we have changed the value of message inside it. That message was in the scope of function itself. That will not change the outer variable message, right? So imagine you are doing a repetitive task every day, like watering the plants, and each day you walk to the plants, water them, and you repeat the process, right? So this is just like a loop, right? The things what you are doing are like a loop, like just like your daily routine, right? So the same task you are repeating multiple times. So this is what the definition of loop is. And similarly in the programming world as well, let's say you want to do the same task again and again. Let's say you want to print a statement again and again, or you want to count something, right? Let's say there is a list of words and you want to keep on making the count of a particular number inside that list. So basically you are checking that number into the list again and again, right? So that's again a loop, right? So whatever you are doing repetitively is a loop, right? So there are basically two different loops. One is for loop and one is while loop. So for loop is like a conveyor belt in a factory. So you have seen a belt in a factory, right? And that conveyor belt will have different items, and each item moves down the belt, and at each station something is done, right? So that belt carries something, it reaches a station, do something, and then it reaches another station, do something. Like for example, first it's checking, packing, and labeling. So there are multiple stages of a product, right? So you know exactly how many items you have, and you perform the task for each one of them, right? So the for loop repeat the task for each item in a set, right? So let's see how it works. So this is again a quote from David Beasley, the Python expert, that I once had a for loop that ran so many times it got tired and started asking, are we there yet? So it's just a funny quote, because loops are like, if you don't stop the loops, it will keep on running, right? So you have to stop them as well. Just like we have learned recursion, right, in the last video. So recursive function will not stop till the time you have base condition, right? Similarly, the loops will not stop till the time you have a condition to stop them, right? So we'll understand them better. So let's see this with an example. Let's say imagine you work in a factory and there is a conveyor belt to pass the toys through the belt, right? And then each box can have 9 toys each. Every box will have 9 toys. And you have to fill each box with distinct toys. You have to keep on filling them. So don't you think you are doing that work in a loop? You are filling the boxes with 9 toys, right? So this is a classic loop example. You are doing the same work again and again. So let's see how to write the loop inside our Python program. So the for loop is used to iterate over a sequence, right? For example, you want to iterate over a list, tuple, string, or a range of numbers. So you can either iterate over a data type, for example, a list, or overall string, a tuple, or maybe you can iterate over a range, right? So let's see. So the syntax will be, you have to use a for, and then there should be a variable, and then in. So for and in are nothing but reserved keywords. So you are saying for a particular variable in this sequence, you do something. Let's see this with an example. For example, you have a list, fruits having apple, banana and cherry. Let's try to write them. Fruits is equal to, let's say this is a list, apple, banana and let's say cherry, right? Then what we are doing is we are writing a loop. We want to write a loop over this list. So what we can do is for fruit is a variable, for a fruit in fruits. So we are saying for every fruit in this fruits, this fruit can be anything, for every A in this fruits, that means for every particular element in this fruits, what I want to do is I want to print it. Let's say I want to print that A. Simple. Print that A. Right? So I want to print that particular fruit. So what will happen? Apple, banana, cherry. Otherwise, if you want to do that, you have to print it in 3 different lines. Now, but let's say this fruit has 500 fruits. You just need to write this loop to print all the fruits. So I hope you got the idea about the importance of loops, right? So let's say you want to write a loop in a range. For example, you are saying you want to print a count from let's say 1 to 100. For we are saying I is a variable in. So here we were saying A. So variable can be anything. It's just like a iterator. So we are saying I in. Now we don't want to do it on a particular list or a tuple. We want to do it in a range. For I in, let's say 1 to 100. 1 to 100. Right? So how to pass the range? We can pass it into the curly braces. For I in range. So range is a function, right? So for I in range 1 to 100, it will take all the elements from 1 to 100, right? We want to print I. We want to print this I. Let's see what will happen. See, it prints every number from 1 to 100. See, so every number range from 1 to less than 100. So that's why it printed till 99. If I make it 1 on 1, it will print till 100. Let's see. Yeah. So this is how you can use the for loop either with a sequence, either a list, tuple, string, or you can do it on a range as well. So there is another type of loop which is while loop, and this is used to repeat a block of code till the time some condition is true. So for loop is running on a sequence, on a range, right, on a particular elements. While loop you can run till the time some condition is true. So the syntax is simple, while condition and then the code to execute. So let me comment this whatever we have written till now. So basically let's see the example of while loop. So while loop is like a flowing river. The river keeps on flowing until the time it has obstacle. As simple as that. So as long as the river is flowing freely, it will keep on going. Once it hits the dam, it will stop. So that's the particular condition we need to write. So this is again a quote from Mr. Tom Long, right, who is a tech blogger related to the while loop. So let's take the same example to explain the while loop, what we have taken in the example of for loop. That you were working in a factory and you were filling 99 toys into a box. So what you could be doing there is, okay, you will fill one toy, second, third, fourth, till the time ninth will happen, right? What if I tell you that as soon as the ninth toy is picked, you have to seal the box? So basically there is a condition to make it true so that you can stop filling the box with the toys. So if you compare both for and while loop, the work they are doing kind of same. They are doing the loop. They are doing the work, the same work which you want to do again and again. They are doing it in a less line of codes, right? You no need to write the same code again and again. But the way they are behaving is different. For loop is working on a range, on a sequence. The while loop is waiting for a condition to stop, right? So in for loop, you are making sure that you stack the 9 toys, but in the while loop, as the ninth toy will come, you'll seal the box. Overall, it's the same work, but in two different ways, right? So the while loop is used to repeat a block of code as long as the condition is true. So for example, if you see this code, we have a count. So let's take this. You have a count 1, it's a variable. Then while, so there is a condition. While is a keyword you have to use, and then there is a condition. For example, in the for loop, we had a for and then a variable, then in and then collection or the range, right? This was the syntax for loop. For variable is nothing but the iterator, then in, then the collection or the range. For while, you have to just simply give while and the condition. So you are saying while count is less than equal to, let's say 50, right? While count is less than equal to 50. Let's say you want to print the count. You want to print this count, right? And then inside it, will it become 50 anytime if you will not change it? No. So in the body, you have to take care that you are changing that variable. Count plus plus. Or you can do count plus equal to 1. Right. Count is equal to, or you can write it simply, count is equal to count plus 1. Simple. Let's run this code. Yeah, so what happens is, it has printed all the numbers from 1 to 50. See? How is it running? Till the time count is less than equal to 50, you are keep on printing. So till the time some condition is true, your while loop will work. Now, the third most important thing, which is nested loops. Nested loop means loop inside a loop. So let's say you are doing some work, and let's say you want to do that work 100 times. For example, you want to print a statement 100 times, right? Or maybe you want to print the numbers from 1 to 100, but every time while printing, you want to print, let's say, 5 times dollar. So don't you think it's a loop inside loop? So for a particular thing you want to do, inside that thing you want to do something again and again. That is nothing but nested loop. So the nested loop means loop inside loop, right? So let's see this with an example. So here the outer loop, you can think of it like is doing some work, and the inner loop is nothing but doing the some another work again and again which is required for that outer work, right? It's as simple as that. So here we want to put, let's say there is let's take an example of the factory again. Let's say while putting the toys into the boxes, we also want to put a sticker and the company label before pushing the box. So don't you think inside that particular task, like you are filling a box 9 times, then again 9 times, but while filling the box 9 times, you want to do some other task also again and again, right? So this is how the nested loop works. Let's see how we can write it. Let me comment this out. So let's take the same example what I was giving, right? So let's say I want to write for I in range. I want to take range, let's say 1 to 5. Let's say I want to print I. Print the I. Let's see what will happen. Right? So it has printed it has printed from 1, 2, 3, 4. Let's say I take it from 1 to 6. 1 to 6. So it will print 1, 2, 3, 4, 5. Now let's say for every print, what I want to do is for j in range, let's say I want to put again 1, 2, or let's say I put 1 to 3 or 1 to 4, let's say. So basically 1, 2, 3. Then I want to print I, and let's say I also want to print j as well. I want to print j as well. Right? Let's see what will happen. The colon is missing. So see, when I am printing 1, for that I want to print 1, 2, 3. See, 1, 1, 2, 3. Right? So if you see the outer block, I have the range from 1 to 5, and then I want to print from 1 to 3. So I am printing I and j, right? So I am printing I, 1 and then 1. So then I am printing 1 and 2, then 1 and 3. See, 1, 1, 1, 2, 1, 3. Done. Then you go to the outer block. Then you go to the outer block. What will happen? 2. For 2 again you are printing 1, 2, 3. So see, 2, 1, 2, 2, 2, 3. Right? Then you go to 3. 3, 1, 3, 2, 3, 3. Then you go to 4. 4, 1, 4, 2, 4, 3. Then you go to 5. 5, 1, 5, 2, 5, 3. So for every outer block, you want to run a loop inside the inner block as well. Right? So for every outer loop, you want to run something. You have a logic where you want to again run a loop. As simple as that. Right? So for this outer loop, this is the body. For this inner loop, this is the body. As simple as that. Right? So this is how the nested loop works. You can also write the nested loop using the while loop. That will also work in the similar way. Right? Now the last thing about loops is whenever you are writing loops, 3 keywords are very important, which actually controls the flow of the loop. How the loop is flowing, it will control that. One is break, one is continue, one is pass. So break means you want to exit the loop. So whenever the break will encounter, the further loop will not execute. For example, we have a loop for I in range 1 to 6. So it will run for 1, 2, 3, 4, 5. But we have a condition, if I is equal to 3, break. So when it will become 1, 2, 3, it will break. So it will only print 1 and 2, because as soon as it will become 3, we are breaking the loop. We are exiting the loop. So this loop will print only 1 and 2. Right? So this loop exit as soon as the I becomes 3. The further loop will not execute. Now continue. Continue means you want to skip that particular iteration. For example, we have I in range 1 to 6. So it will run for 1, 2, 3, 4, 5. But if I is 3, you want to continue. Right? Continue means skip that iteration. So it will print 1, 2, 4 and 5. 1, 2, 4 and 5. Because the loop will skip printing 3 and continue the next iteration. Now the next is pass. Pass means you want to do nothing and it is used like a placeholder. So the pass statement does nothing and allows the loop to continue. For example, if I is equal to 3, you are saying pass. You are saying do nothing when I becomes 3. Right? So if I is 3, you are saying pass. Otherwise, you are saying print. Right? So this will also print 1, 2, 4 and 5. Because for 3, you are just doing the pass. Right? It just act as a placeholder. Right? So let's see the summary for loops. Right? For the for loop, if you see, there is a scenario if you want to iterate through a list, you can do that. This is how the code will look like. If you want to iterate over a string, you can do like this. If you want to iterate over dictionary, you can do like this. And if you want to iterate over range, you can do like this. So I recommend you practicing this piece of code, right? And similarly, here are the examples for while loop as well, which you can use for the different types of inputs, right? So these are again some of the memes related to loops, and yes, the loops are very important in Python programming language. So yes, now the quiz time, right? So again, you should pause the video after watching the question and then move forward for the solution, right? So what is the output of this code? We have a count starting from 0, and then we have a nested loop where I is in range from till 3. So it starts from 0. When you don't give any initial range, it starts from 0. So I in range 0 to 3, then j in range 0 to 2, right? We are counting it. We are increasing the count by 1. So when the range will be, when I will be 0, j is going from 0 to less than 2, 0 to 1. So every time count will increase by 2 for the outer loop. And outer loop is running 3 times, 0, 1, 2. So the count will become 6. So this will be false. So yes, next interesting problem. Let's see. Let me use a pen here. So here I is ranging from 0, 1, 2. And inside it j is ranging from 0, 1, 2. And we are saying if I will become 1, when the I will become 1 and j will also become 1, we will break it. Otherwise, we will keep on printing, right? So initially I will be 0, we will print 0, j will be 0. Then inner loop keep on running 0, 1, 0, 2. Then I becomes 1. So it will print 1, 0, 1, 0, 1, 0. And as soon as it will become 1, 1, it will break. So it should go till here, right? 1, 0. And then this 1, 2. I think we can check this later. So now we are saying for I in range 392, we want to print I, right? What will be the output of this program? We have the 3 range, right? So that means we are giving these 3 numbers as a collection. So it will print 3, 5 and 7. I think this we haven't discussed, these giving 3 numbers in range. So how are we putting it into the quiz? We can just ignore this. Now the next question, we have x is equal to 10 and we are saying till the time x is greater than 0, we have a condition. So while condition, and we want to print x. And then every time we are reducing x by 1, we are reducing x by 1. So x is starting from 10. Is x greater than 0? Yes. We want to print it. 10 will be printed, right? Then we reduce x by 1. So x will become 9. And if x will become 5, we will skip it, right? So 9, we will print 9. Then we again reduce 8. So basically we are keep on reducing it, but we'll skip 5. So 10, 9, 8, 7, 5 should not be printed. 5 should not be. So 10, 9, 8, 7, 6, 4, 3, 2, 1. Right? Cool. Now we have a question. For I in range 2, that means I will go from 0 to 1. And j in range 3, that means 0, 1, 2. We want to print ij. So how many times will the print statement execute? So it will be 0, 0, 0, 1, 0, 2, 3, 1, 0, 1, 1, 1, 2, 6.
So until now, you have learned a couple of things. You've learned a variable, okay? We learned that, you can store some data in a variable, all right? It could be an integer, it could be a float, it could be a string, it could be a Boolean value, and so on and so forth, right? We learned how to compare two things, all right, using operators. We also learn how you can implement a particular logic, or how do you make a decision using if-else structures. We also learned if you want to repeat some task, all right, you can use loops. And then we saw some sort of collections, which are built-in methods, functionalities which you can use to store the data and perform some task on it. All right. Now let's deep dive a little bit more into the collections. Okay, and we will see what data structures does Python provide us to basically work with the data. All right. Now I don't have to explain, that as a developer you would be working with a lot of data. All right, and you would need some sort of method, some functionality which helps you store the data, access the data, maybe modify it, or even remove it, right? I'll take a very simple example of my college days. All right, for me, when I used to have just a couple of shirts, maybe 2 t-shirts or a pair of jeans, etc., the easiest way for me is that I used to put everything on my bed, all right, where I'm working on my study table, right? And then I have to sleep at night, I'll just shift them and lie down, right? That was my way of accessing my clothes much easily. Not perhaps the best way, but yeah, for works for a bachelor, right? uh, you may be better, you may be storing, you may be keeping your clothes in a cupboard. Now there also you can do a lot of interesting things, right? You can sequentially place all your clothes, all right, in hangers with a specific methodology, all right, that okay, first we start with t-shirts, then we start with some jeans and shirts, etc., and so forth, right? And if, let's say, if you have to go on a vacation, you would just place clothes on a pile wherein you would ideally want to place the clothes that you would wear on day one on the top, right? Think of a queue, all right? If you've gone to watch a movie, you're standing in a queue, right? You will be accessing, essentially, the theater guys would be giving the ticket to the first come first serve, right? They will give them the ticket, and then essentially that person gets the ticket, gets out of the queue, and then second person would come into the picture, right? The common theme here is that we have a lot of elements, we have a lot of data points. If we think one cloth, okay, has a data, and all right, not just we would want to store it in a particular fashion, we should be able to access them, do some modification, perhaps remove it, etc., and that's where the idea of structures comes into the picture. All right, in order to store the data and manipulate it, all right, we need different structures. All right, um, to start with, we will be working on creating a task management app. All right, think of your usual day. Okay, it's a Monday and you have to do a lot of tasks. Not a very heavy Monday, you just have 4 tasks to do. Still a lot. I have to complete a project report, I have to attend a meeting, I have to review the code. And most importantly, a feedback session with your manager. Imagine, on Monday, right? Now, your 4 tasks, it's easy. You can just create 4 variables, and I'm calling it task 1, task 2, task 3, task 4, etc., and so forth, and just storing some strings in there, right? Life is easy. Okay. The same task management app now has to, store all the tasks that you have to do in a particular week, all right, or particular month or whatever. And imagine that it can scale up to 1,000 tasks, 100 tasks, 50 tasks, whatever, right? Now, technically, I can actually create some 100 variables, okay, store it in different variables as strings, right? Technically, there is no problem in this, right? But here are some interesting challenges. Imagine task 98, which you were earlier planning to do in a priority sequence of 100 tasks at position 98. Now your boss comes to you and says that, hey, Anand, you have to do this on priority. All right. Now you would have to shift its priority to, let's say, task 2, task 3, whatever, right? But I have something already saved in the variable task 2, right? Should I remove it? Should I store it in some other variable, etc., You can imagine that the manipulation of the data, all right, can be very daunting, can be very crazy if you have to do a lot of tasks, right? Um, Another use case, let's say if I finish task 1 and task 2, okay, ideally the task 3, okay, which is now the new thing that I have to do, should be called as task 1. All right, so task 1 and task 2 should ideally be removed, and all the data points in your sequence, the remaining task, should be shifted, correct? What we need here is that something which can store all your tasks in a sequential fashion. All right, perhaps remove the task one by one as you complete them. You should be able to access any particular task. All right, you should be able to know, let's say, I have, what is my 10th task for the day, etc., etc., and so forth, right? So you need a data structure, okay, in this, which can sequentially store all your data, okay, as your task. You should be, of course, able to read. You should be able to say, hey, what is my 10th task? Okay, tell me what is my 10th task. All right. Or you can say, okay, what is my last task for the day? Something like that. Okay. You should be able to update your task. All right. If the details of the task changes, let's say the due date, let's say description, etc., etc. And of course, you should be able to delete it, right? What we call this as CRUD, okay, in short. So ideally, a data structure should be able to store the data and should be able to help us with CRUD operations. What are CRUD operations? Create, read, update, and delete. All right. So we should be able to, okay, do these things in a good way, all right, in an efficient way. Okay, let's start looking at our very first data structure. You have already seen list, right? I'm assuming that you have worked with list already. Okay, essentially you store, all right, a data. Okay, and I'm just making some data points as circles here, but it could be anything. It could be a string, it could be integers, it could be a mix of all of these things. But essentially you should be able to store your data points in a sequential order, all right, and you basically wrap it up in square brackets, right? This is what you've done before, all right? So in this case, let's say if I have 5 tasks to do, I have stored complete project task as the first element, code review as the second element, and so on and so forth, right? But hey, the positioning index in Python starts from what? 0, correct? So this is at my position 0, this is at my position 1, this is at my position 2, 3, 4, and so on and so forth, correct? I hope you're able to understand. Now, what I'm going to do is that I'm going to go to the Newton playground, okay, write some code for you. We should be able to first create a list. We should be able to access some elements. We should be able to do some modification, and we should be able to remove it, all right? And then we'll come back again, summarize all of these things, and move to the next data structures, all right? Sounds good? All right, so I am here on the Newton platform. Okay, what I did was basically I opened a new playground, okay, in Python. I hope you would have done it. And what I did is I basically created 4 variables, all right, with some dummy data, all right, for the task I have to do, right? Let's say if I have to create a list, okay, I would say tasks, okay, equals to task 1, task 2, task 3, task 4. Okay. I could actually add a task here directly also instead of creating a variable. So I could say, okay, dummy task, and this is also fine. All right. But for the sake of it, just to kind of save some time, I created these as variables. All right. Let me just quickly show and check if that if this list is created. So I have written print tasks. Okay, I'm gonna go and quickly run it, see if my all 4 tasks are running or not. All right, there are some print statements that I've added in the start. Let me just perhaps comment them so that it doesn't disturb our flow. Okay, let me just run it quickly. All right, so I have created a list which has essentially 4 tasks. All right, so creation is done, CRUD. All right, creation is done. I will now go to read. All right, by read, we should be able to read, all right, this list in different ways. All right, So the easiest way of reading a list is what? Run a for loop and read all the elements one by one. So I can just say for task in, let's say, the list tasks, okay, print the task, okay. This should be, giving us, okay, the list of the task one by one. All right, let me just put this print statement as a command, as a comment. All right, so as you can see, all these tasks are printed, all right, using this statement one by one. All right, so it basically iterated over each task, okay, one by one through the for loop, okay, and printed this. All right, let me just put this also in command and start with accessing, okay, some elements one by one. Let's say if I have to print my first task, all right, we have learned indexing in past. How can I do it? I can say task square bracket, and within square bracket I'm going to put what? I will be putting the index which I want to access. Since I want to access the first task here, I will be putting what? 0. Make sense? 0, because the positioning or the indexing in Python starts from 0. Let's quickly run it and check it. This should ideally be printing what? The task 1. And what is our task 1? Complete project report. So this should be printing, hopefully, if we are right, it should be printing complete project report. Let's quickly check. Yes, it says first task, complete project report, and we can move to the next one. In the next one, maybe give it a pause, all right, and try it by yourself, all right. As I am doing these exercises, I would genuinely suggest you that you pause the video once in between, try probably like, thinking in your head, or maybe like code along with me, writing by yourself, then replay. If you're not able to understand, go over it again and try code along with me, all right. Now I have to extract the 8th task. Technically, I don't have the 8th task here, right? But let's try. Ideally, if I had my task 8, I would have been writing what? Tasks, whatever the element is there at positional index 7. All right. Let's quickly run it. Let's see what it is it gives. Okay, it says, okay, there is some error. Okay, it says index error. That means the error is related to the index, and it says list index out of the range. It doesn't exist in the range, right? Makes sense, right? Let me put these statements as comment now and move to the next one. The next one says, hey, print the last task. All right. How can we access the last task? Technically, in this one, I have what? I have 4 tasks. So I can say task position what? 3, right? But hey, I think you would have learned negative indexing also. What will be the negative index for this task, which is the last task? -1. All right. So I will say tasks and -1. Let's quickly run it, check it. Last task. Yes, last task. Feedback session with your manager, the scariest one, right? Shall we try slicing? What is slicing? Slicing is that I should be able to access a slice of my sequence. All right. Let's perhaps try maybe accessing the first top 3 task, priority task. Since we are storing these tasks, okay, in an ordered fashion, all right, in an ordered fashion, I will be, I want to access the first 3 tasks, all right. How will I access it? I will say tasks, okay, and I want to access starting from the first task to the top 3 or the first 3 tasks, all right. So position 0, position 1, and position 2, all right. But the last position is not included, and since I want to access the first 3 positions, I will say 0, 1, 2 is what I want to keep, but I will write the position index till what? 3, okay. So I will say 0 to 3. Let's give it a try. Let's run it quickly. We have first 3 tasks. Interestingly, you can actually skip writing even 0 here, right? You can just run it, see what do you get. You should be able to get the same thing. Make sense? Now it says, give me the next 3 tasks for tomorrow. All right. We have very less tasks defined here. Perhaps we could have mentioned more, and I will make changes to this code. All right, to make things more interesting. But maybe let's try extracting the next 3 tasks. All right. Since we don't have next 3 tasks, once these tasks are done, we just have one. So we'll try just writing maybe, okay, give me all the tasks, okay, starting from index what 3 up until end, because I know that all the tasks are not there. Ideally, if there would have been more than this task, we should have mentioned 3 to what 3 4 5. So 3 4 5 is what we want to extract, and the last position is not included, so you write 3 to 6, right? But let's just quickly run it. See, gonna put this as a comment, run this. Woohoo! We've been able to extract the first task of the next day, right? Awesome. Now, I've done creation. I have been able to read. Okay, let me just quickly summarize it by going to the slides. Okay, so the way that you do, let's say, creation is as follows. You basically add all the tasks in the list. Okay, and maybe just print it. Here I have also, what I'm doing here is that I am also printing the length of the length of this list. All right, so it essentially gives me the number of elements present in this list, right? Next, we saw how can we read some tasks. So if you have to access the first task, you will be mentioning 0. Okay. If you want to access the 8th task, you will say task 7. If you want to access the last task, you can do it using -1. First 3 tasks, 0 to 3. Next 3 tasks, 3 to 6. That makes sense, right? I'm going to use this example in the playground as well. Okay. For our remaining lecture. Okay. Now we will get to update. Okay. How should we updating it? And we'll discuss this in the next video. We are done with most of the operations on list. Okay. We have done C, create, R, read, U, update, and now we are left with D, delete, right? So in this case, specifically, we would have 2 things to do. Okay. We would actually want to delete a particular element by providing its value. Basically, what is the value stored at a what is the value of the element which we want to delete, and sometimes we may want to actually delete using the positional index. Let's quickly check it out, both the cases. Okay, so I have this list with me. Okay, I'm gonna first try doing what, removing first occurrence by actually giving it a value. Okay, so let me say tasks dot remove is the method that you will use here. Let me say that I want to remove this particular value, which is say organize code repository. Okay, let me quickly run this and show it to you. Okay, so what you see is that in the output there is no mention of organize the code repository. Okay, if you want to, let's say, remove a particular element by its index, in this case I want to remove the value at index 5, which is the 6th element, 0 0 1 2 3 4 5. That will be plans next week task. So ideally, if I remove this one, okay, if I say removed task equal to tasks dot, okay, pop is the one which we will use here. If you want to enter a particular index, I will say 5, and hey, I am saying that it should be popped and saved in a particular variable. Okay, here there's nothing to store, right? Because I am telling it that okay, this is what you should actually remove. In this case, I'm providing it an element. We may also want to know what has been removed. So I'm gonna actually print what specific element that has been removed, what was the value present there. Okay, So what it says is the plan's next week task is essentially what I am removing from here. Okay. Next up, what we will see quickly is another thing, which is list of list. It's a very simple, okay, a very simple concept. The idea here is that, hey, until now, I was just storing the description of the task, let's say complete project report, etc., etc. But now I may want to store some other things also, some other details as well. Let's say what is the priority, okay? What is the priority of a particular task? What is a due date, okay, of a particular task, right? So now every task has three things to be stored. So what I'm trying to do here is that I will actually create a list of three elements storing details, okay, let's say description, priority, and due date, okay, due date, okay, as details of one particular task in a list. And I can create multiple such lists of different tasks and create a list of list. Now, what is happening here is that there is a list or which has some elements, okay, equivalent to number of tasks, okay, number of tasks, and every element is not an integer, a float, a string, or a boolean. Every element is also a list in itself, okay. So list of list, okay, you can compare it or think of it as a 2D matrix also. If you are someone from maths background, or if you've done some bit of matrix multiplication, all of that, you'd be able to understand. And don't worry if you're not able to understand. But yes, essentially you can think of it as a matrix. If you think of a list as one-dimensional list, or you can think of it as list of list, right? Now, if I want to, let's say, specifically, okay, want to extract the details of a particular task, okay, I could just say task details 0. This will give me what? It will give me all the details of the first task. But if, let's say, if I say task details 0, it will give me the details of the first task, and then I am mentioning another index, okay, in another square brackets 1. So it will go to the positional index of the first list, and what we have here is high, okay. So this will essentially return high, okay. Are you able to understand? I'm not going to go into the details of the code. You can just check it and like perhaps try it at your end. But this is essentially what you can do if you have more elements to store in a list, okay. There are, of course, better examples, better ways of storing this, but that basically will be done as we study the next data structure. Okay, so we have more than one details of any task, right? We have details, description, we have priority, and we have date. Life is good. You have created 5 lists storing all these data, okay? And you have created a list of lists to store all these 5 lists, correct? There is one problem though. The details, priority, and dates are sequenced in a particular order, right? So in case if you want to check the priority, if in case if you want to just get, okay, what is the priority of task 2, okay, you would have to remember that you have to go to index 1, okay, of any task to basically extract the priority. Now, dictionaries are better way to kind of work around with this kind of challenge, wherein what you do is you basically create key value pairs, okay, key value pairs. All right, let me give you a quick demo, okay. You can perhaps code along with me. So I had a list of lists stored as task details. What I have done here is I have created a dictionary. Dictionary is created with curly brackets with a key value pair, okay. So here we have key as the description and the real description as the value. we have priority as the key and high as the value. Okay, this is a dictionary corresponding to one task. All right, how can this be helpful? If in case if I want to check, okay, priority for this task, I will say task 1, within square brackets, I will mention the key. Okay, I will mention the key over here and make it run. Okay, this will give me high. If I had to do the same thing using list of list, I would have to write task 1, okay, the name of the positional index where priority is saved. That's what 1. Okay, let's run it quickly and see. Oops, task 1. Okay, it should not be task 1, it should be tasks details, and then I say task 1, which essentially would be 0, and so on and so forth. Okay, okay, so as you can see the difference in here. Okay, what do you think, which one is a cleaner way of printing the priority of my task 1? This one, of course, right? So what I can do is I can mention all of these, okay, all of these tasks as dictionary, and instead of creating a list of list, I can create a list of dictionaries, right? So this is again a list, still a list, but what I do here is that I will define each task details, okay, as a dictionary. Okay, so let me just try perhaps extracting details of second task. So I'll say tasks details second task. So I will use index 1, and this would essentially give me my details of the first task. Okay, okay, I can access a particular detail, for example, let's say date. Okay, so I'll say due date. Okay, and this will give me just the due date of my second task. Okay, I hope you're able to understand. Pause the video here, probably attempt it from your end, code along with me, just pause, see if it works at your end, and then you can resume to follow along. All right, okay, so next up, what we can also do is, instead of creating it as a list, how about I create a nested dictionary? What do I mean by that is that not just it's a list of dictionary, it's a dictionary of dictionary. All right, so I could also give a key like task 1 here, and the value I define here is a dictionary in itself. All right, so just to save some time, I have kind of written this code prior to this. Okay, so I defined a tasks. Okay, let me call it tasks details. Okay, just to remain the same. Okay, let me just stick to tasks. Okay, so tasks is a big dictionary wherein each element, okay, is also a dictionary with a key as task 1, task 2, task 3, task 4, etc. And the value also is a dictionary, and that dictionary contains the real details of that task, including description, priority, and due date. All right, let's see a couple of interesting things here. Okay, so here are a couple of tryouts. You should be doing it along with me. Okay, perhaps trying some other things as well. So let's start with actually just checking how many tasks are present in this. Okay, so I'll say len, okay, tasks. Let's see if it gives me an answer or not. Yes, it tells me that the number of tasks are 4. Let me print uh, these things. Okay, sorry, stop printing these things so that we have a cleaner output. We will say number of tasks is this. Next up, we will print the details of the first task. How will you do that? Again, it's a nested dictionary this time, so you have a key. You don't have a positional index. You will say task square brackets, and within square brackets you will mention the task that you want to extract. You want to extract the first task, right? So you will just say simply what? Task 1. Let's see. Let's run and see if we get the answer or not. Yes, it gives me the details, all the details of the task as a dictionary, right? Each one is a dictionary, correct? Now I want to get, let's say, the priority of the second task. How do I get it? I will say tasks, okay? Which task do I want to extract? Task 2, right? So I'll say task 2 as the dictionary, okay? Now this part will give me the entire detail of the task 2, right? But I just want to extract what? The priority, right? So I will say, just give me the priority. Okay, this is a nested indexing format, correct? Let's see what's the answer. Yes, so we've gotten the priority of the second task. That's what? Medium. Okay. Last couple of tryouts. Let's say you want to print the task 1 details. Okay, this is pretty simple. Oh, this is something that we have done already. Let's try this one. You want to print the details of task 5. Okay, give it a try first by yourself. Okay, I'm gonna do it here, but you can quickly pause and try coding along. Okay, I'm gonna say tasks. Okay, and in this I'll say task 5. Before I run this, you check it at your end. Okay, pause it for 10 seconds. Okay, seems like we have some error. Now I would like you to think why this error is coming. Let's try reading the error alongside. Okay, it says it's a key error. Okay, task 5 is a key error, and what is perhaps happening if we look at the error is that it was not able to find anything named task 5. Can you see that we have defined task 1? We have not, right? So this is what would happen if in case if the key that you try to access a particular value of, if it's not defined, it will give you a key error because that key doesn't exist, correct? So this was intentionally put in so that you can understand, and if you get an error you can figure out that hey, should I even check that if I have defined this or not? All right, that happens pretty much a lot. Okay, cool. So we have all of these things. I'm going to comment out this part and move to the next bit. Now we should be checking how do I iterate over all the details one by one, right? Now if you have to iterate anything, what do you use? You use a for loop, correct? I can use a simple for loop here. Let's say for task in task, let me just say for task in tasks. Okay, let's see what it prints. Interestingly, it is just giving me the names of the task. Okay, I have not comment out one line, one statement. So let me just go up and quickly comment out one of these lines. Okay, here it is. Okay, for task in tasks. Okay, interestingly, it is just giving me the names. Why? Because if you actually run a for loop, that for loop runs on the keys of the dictionary, not the values. Okay, so if you want to access both keys and values, what you will have to write is task dot items. Okay, now let's try running it again. Okay, now can you see that every time it is returning me task 1, which is the key, and the value. Okay, I can separate it as well. So I can say for task comma key. Okay, now this time basically, oops, not task and key. I would say task key, task value, and let me print the same. So task key comma task value. Okay, now let me try running it. Woohoo! So now we have been able to print both of these things, and this way you can extract keys, you can extract both key value pairs, you can just extract values, and so on and so forth. All right, I hope you would be able to iterate through all the data if in case required from a dictionary. Okay, just to summarize the dictionaries part. Okay, until now we have learned 2 data structures. Okay, we have learned lists and we have learned dictionary. Okay, when is list helpful? List essentially is nothing but a sequence of ordered elements. All right, it's a sequence of elements that you store in a particular sequence, and those elements, I'm sorry, can be accessed using positional indexes. So if in case if I want to access the first element, which positional index will I use? 0. If I want to extract the third element, let's say, which one will I use? Which positional index will I use? 2, correct? 0, 1, 2. That will give me the third element. If I want to access the last element, okay, which positional index will I use? -1, correct? Now dictionary actually helps us in case if we want to use something else but not positional index, okay, that means an integer, as a key to access something, right? So instead of, let's say, using those boring numbers 0, 1, 2, 3, 4, and I wouldn't remember it, I can use some interesting fancy words, values, even integers, anything to be used as a key of a dictionary. Now, there are some possible only few valid keys in a dictionary. Let's go and check them out quickly. Okay. What we see here is that any valid key, okay, any valid key for a dictionary should be immutable. Okay. It should be immutable. That means it should not be changeable. Okay. What do we mean by that? Let's try to understand with an example. Let's say if I have a variable x, okay, and I am storing 2 in this, okay, what is happening in the backside is that an object of type integer, okay, is getting created, okay, and it is storing a value 2, okay, and that starts pointing to the variable x. Now, when I say x equals to 3, okay, do you think that this 2 will get replaced by 3? No, that does not happen in Python. Okay. What happens here is that another int object, okay, will be created having value 3, and this will start pointing to x, okay, and this linkage will get deleted. The learning from this example is that, okay, an integer object is immutable, right? That means you can't change the value of it. If you want to if you want to replace it, what you'll have to do is you'll have to create a new object. Okay. Are lists, dictionaries mutable or immutable? Think about it. Maybe just take 10 seconds to think about it. What do you think lists and dictionaries are? Mutable or immutable? Remember, we actually changed some values of a list or a dictionary, right? We saw CRUD operation, CRUD, right? In the U operation, update operation, we were able to change the elements of a list, right? We can similarly change the elements of a dictionary also, right? So these are mutable. All the primitive data types like integer, float, string, bool, okay, are immutable. Okay, why? Because if you want to change it, you'll have to create another object. The data structures that we have learned until now, lists, dictionary, are mutable. And what we say in the case of valid keys of a dictionary, you can just use the ones which are immutable. So if you want to use integer for a key, go ahead. If you want to use a string, we have been doing that. If you want to use a Boolean value, true or false, yes, please make sure, no problem. Okay. What you cannot use is list because it is mutable. Sorry. You cannot use dictionary. Again, it is mutable. You can make a lot of changes. We will see 2 more data structures, tuples and sets, and we will see that you can use tuples, okay, because they are immutable, and you cannot use sets because they are mutable. Okay, take a little bit of time to just absorb this. Okay, if you're not able to understand, you do not have to worry. Okay, all you can remember here is that the valid keys of a dictionaries are integer, float, strings, and Boolean. Why? Because you cannot change them. Okay, if anything is changeable, that is not a valid key, okay, for a dictionary. All right. After this, we will be starting with another data structure called sets, and after that, we'll learn tuples. So I'll see you just in the other module. Hi everyone again. I hope you're enjoying the course on Python for data analytics. So we have learned lists, we have learned dictionaries. Okay. Both of them have their own strengths. Okay. You will actually get to know that accessing any details, okay, through a key is not a very heavy task. All right. When you learn data structures and algorithms in detail, all right, you'll get to know that accessing any value using key, all right, is pretty fast. actually much faster, okay, than list, all right? So I'll suggest that you start using dictionaries for a lot of things, all right? When all you have to remember is just the sequence, all right, and nothing else, right? You can then use simply a list. Now, in this section, we will go through another interesting, super interesting data structure called sets. Okay, you might have learned sets in mathematics also. Okay, but let's start from scratch. Okay, now let's say if I want to store some elements, 1, 2, 3, let's say, okay, and I store it in a list, okay, calling it R. Okay, now I can do something like R dot append, okay, or R dot insert to insert another element. Correct, I can do that. Now that's not a problem. Let's say if I end up, okay, adding one more element here, it will be added. And there is no one stopping me from adding a repeated element over here. So I can add a 2 again, correct? Now, why is that a problem? It's technically not a problem if repeated values are allowed. But let's imagine a scenario, okay? You are on the internet scrolling something, and you want to download a file, okay? When you download a file, okay, uh, if in case any other file of the same name exists in that folder, okay, your OS gives you a notification, okay? Do you want to replace it, okay, or do you want to create a new file? And when you say create a new file, it will actually add some suffix like 1, 2, 3 in the end, and it ensures that all the files in a folder are of different names, right? Which means you can't have two files in your folder with same names, correct? Now, in such cases, what you're trying to do here is you're trying to create a set. That means no repeated value is allowed. If you want to use a data structure wherein any repeated value should not be allowed, you should not be using a list. You should be using a set. Okay. Set does not allow repeated value. And that's it. This is what a set is. Okay. In a very simple form. Okay, it will have all the unique elements. So if you've defined a set, you can be rest assured that everything will have all different elements. Now the interesting part which comes in sets is, one, how do you define it? Okay, we'll just see in a while. It looks something of a mix of list and dictionaries. So you don't use square brackets. Instead, what you use is curly brackets. All right, but hey, don't we use curly brackets to define dictionaries? Yes, but in dictionaries, what we have is a key value pair. Whereas in sets, we just have essentially values. All right. So what is the way to kind of define a set without a key value pair? You can just simply use curly brackets and put elements with comma separation, just like how you do it in list. We'll just see in a while when we actually go to understandings the sets a little bit more. There are couple of common operations that you can use on sets, following names as union, intersection, difference, okay, and symmetric difference just in a while. Now, to motivate this part, I'm going to use another case study. Now that you've learned a little bit of Python, you've started applying for jobs, okay, and you may have some other skill sets also. In this case, I am saying that you know design as well, okay. So here, okay, as an HR or a talent acquisition manager, I am storing a set of two candidatures. Okay, why set? Because I wouldn't want two resumes, okay, two same resumes of same people to be like added to my list. All right, I would want all the candidates application to be unique. All right, so I have applicants, okay, who have applied for a tech role. I have applicants who have applied for design roles. Okay, so here is basically two sets. Okay, one is for tech, one is for design, and I have, okay, jotted them down as sets. Okay, so let's just go and quickly see, okay, what interesting operations we can do on it. So I'll go to the Newton playground, okay, define these sets. Just to save some time, I have defined them before, and I will try to get answers for the following. First, try out, list everyone every person who have applied regardless of their roles. So what I'm saying is that, hey, I don't care about whether they've applied for tech. I don't care about whether they've applied for design or anything for that matter. All I'm saying is that, okay, give me basically list of people who have applied at Newton School, let's say, for something. Okay. So I will say applicants tech or applicants design. Now, what do I mean by this? I am saying, okay, just give me applicants who applied for tech or for design. Okay. In order to visualize it a little bit better, okay, I will just go here and try to explain it using something called as Venn diagram. Let's say this one circle, okay, basically represents all the people who have applied for tech. And this set, this other one, actually represents those who have applied for design. Okay, so A is tech, B is design. Okay, now I am saying that, hey, give me all the applicants who applied for either tech or design. Do I mean that I am basically looking for this entire set, right? A or B. Okay, so A or B is typically represented with this line, and it is also called as a union operation. You're uniting both the things. Okay, union of two things, uniting two things. Okay, in case, let's say if I want to do something else, say maybe if I want to get those people who applied for design. Okay, so it will be simply what? This set B. But the interesting question is, I want to look for people who have only applied for design. Okay, only applied for design. How do I get it? Let's first try to understand what do I want to get here. Can I say that I want to get this part? Okay, how do I get this? Can I subtract? Can I take the entire B? Okay, can I take the entire B? Okay, oops, and remove this part, the intersecting part. Okay, so should I first find the intersection of these two? What is intersection? Those who have applied for both the roles. Okay, so for intersection, what we use typically is, okay, this is a little bit messy, so let me just clean this up a little bit. Okay, let me do intersection first. Okay, so here is what you want to do. You want to get the intersection. Okay, this part first. Okay, so both design and tech. Okay, so for this, what you will do is you will say A and B. Okay, those who have applied for tech and applied for basically design as well. Okay, now if in case if I want to calculate, okay, if I want to get those applicants who have applied only for design, right? If this is what I am interested in, okay, so I will do B minus intersection of A and B, B minus intersection of A and B. Correct? Correct? Or I could also do union of A and B minus, okay, this part. That's the same thing. So we'll try to understand sets using another case called job applications. Okay, so let's say you have learned something and you've started applying. Okay, and you're applying at Newton School. You decided to apply for a tech role and you applied for a design role as well. Okay, now ideally what I would like here is that any applicant's resume is just present once. Okay, we wouldn't like two resumes for one single applicant to be present in the set, right? So you will not use a list here, you will use a set. So I've defined two sets here: applications tech, Alice, Bob, Charlie, Diana; applications design, Charlie, Eve, Frank, Diana. Okay, that's fine. And I have defined them using curly brackets. Okay, now I want to answer a couple of questions related to these sets. Okay, so we'll see that. Let me just remove this part and explain from scratch. So in mathematics, if you would have learned, you define one set using a circle, okay, in Venn diagram. Okay, so I have defined a circle, let's say A, another circle, let's say B. And here, A is defining all the people who have applied for a tech role, and B is defining all the people who have applied for design role. Okay. To start with, if I want to say, okay, give me a list of people who have applied for any role. I don't care about what role they have applied. I just want to know the details of all the people. Okay. Which means essentially the set that you want to get details of is this entire part, right? So you are uniting these two sets. Okay. You are taking a union, or you're uniting these sets. Okay. The way you define union, okay, is through a vertical line. Okay. So when I actually, say print applicant's tech, vertical line applicant's design, ideally it should be giving me a union of both. And since it's a set, okay, in the output, any person, let's say Charlie, if they have applied twice, their name will essentially only come once. Let's run it and quickly check the results. Okay. Can you see that every value or every applicant's name is only appearing once? Okay. Next question is that you have to define a list of people who have applied for both the roles. That means you have applied for both tech and design. Let's see how will we do this. Okay. So I will again define set A as people who have applied for tech role. I will define B as set of people who have applied for design role. Okay. In this case specifically, what you want, basically a list of people who have applied for both the roles. Okay. So what you are trying to take here is something called as intersection. What? Intersection, right? And the way we define intersection is as follows. You will use an ampersand sign. What? You will use an ampersand sign. Okay. So I'm going to say print, okay, applicants tech, okay, and applicants design. And ideally I should be getting what? Since Charlie has applied for both the roles and Dinah has also applied for both the roles, I should be getting Charlie and Dinah in the output. Okay. So Charlie and Dinah. Okay. I hope you're able to understand. Okay. Try some interesting things to do by yourself. Okay. Make interesting use cases. Next one is something that, I would want to probably you to think a little bit before you try it out. Okay. Otherwise I'll explain. Okay. Next question is list of people who are interested only in design. Okay. Only in design. Okay. So I will just again define these sets A and B. Okay. And notice that what you're looking for is those people who have only applied for design. Okay. Can I say that this is nothing but essentially B minus intersection? B minus intersection? Correct? So let's perhaps try it out. Okay. I'm going to say print. Okay. You take B, which is what? Applicants design. And what you're trying to do is you're trying to subtract, okay, those who have not applied for, or those who have applied for both tech roles and design roles. Okay. So I can simply copy this part. Okay. I can simply copy this part. Okay. Let's give it a try. Okay. So it says that Eve and Frank are those people who have only applied for design role, because yes, Charlie and Dinah has, they have also applied for tech role. Okay. Now the next one is saying list of people, give me the list of people who are interested in only design or only in tech, but not both. Okay. Only in design or only in tech, but not both. Let's try to maybe visualize this. Okay. So I have set A representing tech, B representing design. Now this time I'm looking for people who have either applied for tech only or who have applied for design only. Correct? So in this case, I can take a union of both and subtract the intersection. So I can take the union of both and subtract the intersection right? Let's give it a try. I will say print, okay. I will take this part, which is essentially union, okay, put it in bracket, and then I will say subtract, okay, this part, which is this one, okay. Let me try running it. And yes, this basically gives me list of people who have applied either for tech role only or people who have applied for design only, but not both. Dinah and Charlie, they have applied for both the roles, and hence Dinah and Charlie's name is not present here. Okay. One last thing that you can do here, very interesting stuff, is that let's see what if you just simply, okay, do applicants tech minus applicants design. Okay, applicants tech minus applicant design. Okay, let's see and try to guess what do we get in the output. Okay, what we are getting here is Alice and Bob. Now think about it, why you are getting Alice and Bob here. Alice and Bob are the ones who have applied for tech, okay, but haven't applied for the design. Just think about it. Which one of these are actually similar to this one? Can I say that this one, actually the reverse of it would be similar, right? So I can, if I would have done, let's say, design, okay, minus tech, I would have gotten this answer. Let's give it a try. Eve and Frank here, Eve and Frank here. Okay. So instead of calculating an intersection, you can just simply say that, hey, okay, just perhaps, remove tech. Okay. Just give me all the people who have applied for design minus people who have applied for tech. I don't even need to, calculate their intersection. Okay. Now, this is not symmetric difference yet, right? What you tried replicating is you are just saying that, hey, give me people or give me the list of applicants who have applied for design, okay, but not tech. Similarly, you could also do the reverse. You could say applicants, okay, applicants tech minus applicants design, okay. In this one, this will give you only design. This one will give you only tech. Now, if you do this operation, okay, wherein you say applicants tech, symmetric difference, which is defined by what? A caret. Okay. You'll get a very interesting answer. Okay. What you'll get here is as follows. You will get Frank, Bob, Alice, and Eve. Okay. That means you are not getting those people who have applied for both the roles. Okay. So symmetric difference essentially is giving you either tech or design, but not both. Okay. But not both. Okay. I hope you're clear with sets now. Okay. As we said, there are three, okay, operations that you can do. Union, okay. Union will give you a union of both the things. You are uniting the sets. Intersection will give you what is common between both, okay. Difference will give you, if you do A minus B, it will give you all the values in A which are not in B, okay. If you do B minus A, it will give you all the values in B which are not present in A. And if you say A, symmetric difference, which is basically represented using caret. Okay, if you say A symmetric difference B, it will give you either A or B, but not both. Okay, so this was sets. Okay, very helpful. Okay, in terms of creating a non-repeating list of elements. Okay, I'm saying list of elements, but you get the idea, collection of elements or whatever. And yes, you can apply very interesting operations on it. Okay, we will go through one more interesting data structure, and the last data structure we'll be talking about, and this is called tuples. Okay, I will take another interesting use case of saving flight records to make you understand this. So what you have to do here is that you have to save the following details. You have to save passenger names, flight number, departure city, destination city, seat number, meal preference, and so on and so forth. Okay, you can store all of this in a list, correct? You can store this in a list, you can store it in a dictionary, but for now, for the sake of it, let's just try to store it in a list, okay, to start with. Okay, so I have created these list, okay, storing all of these details, and I created a list of list. That's something that we have learned. Okay, we call it 2D list as well. Now the interesting part, what I can do here is that, let's say a user comes to me, okay, and ask me that, hey, instead of having a veg meal, okay, I want to have a non-veg meal. Okay, the first user, uh, or the first traveler, Alice, they basically want to have a veg meal. Okay, I can do that. I can say tickets, okay, first user, which is Alice, 0, and I will try to extract, okay, its last element, which is their meal preference, and try to make it, let's say, non-veg. I'll try to make it as non-veg. Okay, would this be possible? Yes, lists are mutable. Okay, so I should be able to make the changes. Let's give it a quick try. Let's print it quickly and see. Yes, I have been able to change Alice meal preference to non-veg. Okay, Alice's meal preference to non-veg. Let me just comment this out so that you don't get a lot of things on the output. Okay, so this is fine. But hey, just the way I have been able to change their meal preference, Alice's meal preference, I can change anything, right? I can change Alice's name also. I can change Alice's ticket number also. Tell me, would you actually prefer that any detail is actually changeable? No, perhaps, right? So instead of using list, typically what we do is we actually store the data in what we call as tuples, okay? And the only difference in the way we define a list or tuples is that instead of using a square bracket, what you use is a round bracket, okay? So now I will try to change this thing again and let's see what happens. But just to kind of show, the first element is now a tuple and the second element is now a list. I will try to make the same changes for my second element as well. Okay, so I'll try to change their preference to veg. Okay, this is the second element, so I'll write it. Let's quickly see what happens. Okay, it says tuple object does not support item assignment, which means you can't change any element present in a tuple. Okay, whereas is it possible for a list? Let's check it. Okay, let's run it for the second one. Yes, I'm able to make the changes, correct? So tuples won't allow you to make the changes. So if you want to define a collection, a sequence of some elements where you don't allow changes, okay, you should be using what? You should be using a tuple. Okay, so let's negate this part and try to understand what is the right way I should have defined this. Okay, I should have created a dictionary wherein the things that I do not want to change, for example, the name and let's say the flight code, okay, I can define it as a tuple. And again, this is a key. You should be using something which is immutable as a valid key for a dictionary. So you can just define it as a key and the other things can be defined as a dictionary. So seed, meal, etc., etc. All right. So in this case, I can say, hey, I access the booking dictionary okay, and I try to access, let's say, Alice, okay, Alice's data. I will define it as the key. And here I would say, hey, I want to change the meal to non-veg. Non-veg. Woohoo. Let's see if this permits us to make the changes. I will just print the dictionary again and see the results. Yes, can we see that the meal options for Alice is changed, but other things remain same? You can't, of course, it's a tuple, so you can't change it. We can even try changing it. It won't get changed. Okay. And then other things remain the same. All right. So this was tuples. Okay. In case if I just have to explain it in a very short go, okay. Tuples are something which you can't change. Okay. Tuples are immutable. Okay. And if you want to store any sequence of data which you do not want to change, you should be saving it in a tuple. And if you want it to be changeable, you should be storing it in a list, right? And typically what we do is we use a mix of dictionary, list and tuples to store our data depending on what use case is. Okay. This is where the real things happen. All right. Until now, think like, you were making uh, a UAV project, okay, just making an MVP, all right, which can just perhaps, take a fleet of some 30 meters, etc., etc. And now you are actually building a real autonomous flying vehicle, right? So it's like that. Why do I say this, right? It's because of three very powerful libraries that we will learn in this module. We'll start off with Numpy, which is essentially what this specific lecture is about. All right. We will then delve into pandas, and then we will learn two libraries. One is Matplotlib, the other one is Saban. Okay. And these have a very different role in how AI, machine learning, data science has shaped today's world. Think of anything in data science, think of anything in AI, all right? Everything is powered by at least one of these libraries, okay? Or perhaps their inheritance, okay? Uh, I would just say that mastering this particular topic would be very helpful, okay, in order to do anything in data science, machine learning, LLMs, learning transformers, building AI agents, etc., etc. So focus on this module and learn it. Give your heart and soul towards understanding it. Uh, Today we will start with Numpy. Okay, uh, it's very interesting because some people call it Numpy. Okay, some people call it Pi. Okay, and perhaps you can tell us in the comments which one you are. Okay. I am a NumPy person for all the right reasons. But yes, do let us know. It doesn't matter actually whether you call it NumPy and NumPy, but what matters is how powerful it is. And let me tell you a story uh, to explain the very importance of NumPy. NumPy actually helped me pass a course in machine learning. Okay. It's like if I have to make noodles, Hakka noodles, okay, first I would have to boil the noodles. I would have to chop some vegetables, put in some masalas, etc., etc. All of that, put in some oil. That essentially what I was doing in my machine learning project. All right, writing a lot of for loops, okay, nested for loops, everything. And think about NumPy as this 2 minutes uh, instant noodle solution, wherein you just stir something and it's done. All right. So whatever you've done until now, you would see how you can just do it with NumPy much more easily. And not just that, you would see how NumPy and libraries like NumPy are actually powering today's transformers, models like ChatGPT and neural networks. So let's get started. Uh, for this module, we will focus on something what is called as a Jupyter notebook. Jupyter notebook is nothing but it's essentially a sequence of code cells. So until now, what you had is just one code cell wherein you type something, couple of statements, run it, and it runs all the statements. And it was difficult, right? We've seen, right, that I would have to comment out all the past statements in order so that, it doesn't run it again. Now imagine that I have these separate blocks which I can run, which I can execute separately. Okay, that's what Jupyter Notebook is. And cherry on cake, you can actually convert it into a proper notebook by adding headings, by adding paragraphs. You can even add images, you can even embed videos. So the most interesting Jupyter notebooks are actually what they're called as. They're actually notebooks. Okay. Uh, I'm going to tell you how you can access one, although you can have a Jupyter notebook set up in your laptop, in your personal computer, in your local as well. But I would suggest that you start with a Google product. Why? It's online, it's cloud-based, and everything is just much more easier. Okay. So you go to your Google, your favorite search engine, and I don't know if your search engine is a Google search anymore, or perhaps something like Perplexity, or you're just using ChatGPT as your Google search. But I will stick to it. I will just say Google Colab. Okay. It says welcome to Colab. Okay. It's a Google product, as you can see. And as soon as I click, it actually opens up a new notebook for me. Oh no, it shows me if I want to open some other notebooks that I've worked with, or I want to create a new notebook. Okay. So I'll just create a new notebook for you. Okay. You can perhaps, pause this video here and do along with me. Okay. And come back when you're done. So here, this is essentially what it starts with. Okay. And it's very simple. If you want to just write a code, let me say x equals to 2, print 2. Okay. I can just click this button, as you can see, which looks like a play button. Okay. Just put this up, run this, and it will take a little time to kind of like connect to a Google server, okay, for executing. But then once it is connected, okay, it will be pretty fast. As you can see, it gives me an output. Now I can add a text cell here, say, okay, this will be my first text cell. And then what you can also do, instead of playing, you can enter shift and enter. You can press shift and enter together. That actually also does the job of running a particular cell. Either it's a code cell or a text cell, whatever. Now, if I write something over here, okay, let me say again x, okay, what you will see is that whatever I have run in the memory, okay, it stays in the memory. So this is my current runtime environment. Okay, I can stop my runtime environment by saying disconnect and delete runtime. But if I have ran something, okay, and I am still in that runtime, it will store all the variables, it will store all the objects that I have created. To give an interesting example, if I want to, let's say, add another cell over here, let me just say maybe x plus 2, okay, x plus 1. Okay. Now it does x plus 1 for me. Okay. Why? Because x was already present, right? Even if it's above this one, even if I take this up, okay, as the very first statement, even if I run this right now, it will actually run for me. Okay. I can just maybe make changes and show it to you that, it will work. However, if I have disconnected from here, and if I have let's say, restart the session, okay, now if I try doing x plus 4, okay, it will give me an error. Why? Because it could not find where x was defined. So I will have to define it again. I will say x equals to something, let me say 0, and yes, now it will function fine. Okay. As you keep on using Jupyter Notebook, you will get a better hang of it. You can just simply use this play button or press shift enter. Okay, shift and enter to kind of run a cell quickly. And the entire next module, which will be focusing on Numpy, Pandas, Matplotlib, Seaborn, these Python data science libraries, or I would say Python AI ML data science libraries, we will be using a Google Colab. Okay. Now, in order to save some time, what I've done here is I have pre-created a Colab notebook, right? I added some headings over here. I added some subheadings, I added some code, which I wouldn't have to write again, so that we can go faster. Okay. Let me maybe write this content at least. Okay. Or I may have another notebook which doesn't have this much of wordy content. Let's stick to that. Okay, cool. Now the first thing that I will do here is I will say import numpy as np. Okay, I am saying that, hey boss, import numpy and call it np. I can literally call it anything. I can call it Rahul, I can call it Vishal, I can call it my name, I can even call it anything, literally any variable name that you want to give. All right, you can give technically to this, right? But np remains a standard alias. And what do I mean by alias is anything but like, a standard short notation of anything. So a very standard short notation for numpy is actually np. Okay, so I said import numpy as np, so that if I want to use this numpy module, I would call it as np and not numpy or anything else, right? You can call it anything if you would like, right? Now, what I've done here is I have created a list. You're aware of list, a sequence of elements. Here it is a sequence of integers, and it's fine. And I've saved it in a variable called a, right? Now, if let's say, if you have to do this task, okay, of adding an element to each element, how would you do it? Very interestingly, you would see that, since Google Colab is powered by Gemini, okay, it will actually, explain the code for you, sometimes gives you some autocomplete suggestions, etc., etc. See, it is actually giving me a autocomplete suggestion of how you can perhaps use it. And I press a tab and this actually writes code for me, okay? I made Gemini write this code for me because, we have learned it before, all right? So what it is doing here is it's saying for I in range in length of a, which essentially is saying that, you run this for loop n times, or basically equal to the length of the list. And what you do is at every element, you increase that element by adding +2 to it, right? We could have done it in a much more easier fashion also. I could say I +2 for I in, let me not call it I, otherwise we'll get confused. Let me just call it A, okay, or something, let's say B, for B in, let's say A, okay. So I'm saying for every element, okay, let me just call it element, okay, for every element in A, okay, add +2 to that element and store it maybe in A again. The only difference here is that this is a list comprehension. This will create a new list, right? The earlier code actually updated the list, right? So we do not want this. We want to keep the old list intact, right? So we will stick to this. Okay. Now I'm going to show you how you can do this in NumPy. I will say np.array, and within this, you can just provide the list that you want to create as a NumPy array. Okay. We don't call it a NumPy list. We call it a NumPy array. And in about 10-15 minutes from now, I will explain why we call it NumPy array and not NumPy list. But let's just stick with this name, right? This is a list that I want to convert into a NumPy array. Okay. I could instead say A also here, right? But A is changed, right? So let's not call A, but let's stick to writing it like this, okay? And I will call this as AARR. ARR stands for array. So I'm just saying that, hey, this was a list and maybe this is an array, okay? Now, just guess how easy will it be to write something like this in NumPy, okay? I'm going to show you. I'll say print A RR, which is the name of my array, and I'll just simply say +2, okay? And this does the job. This is the fun, very fun part of it. What I'm doing here is that I am telling NumPy, hey, I want to do this operation with all your elements. Whatever you are saving, just do this operation on this. If I say multiply by 2, okay, it will multiply 2 with every element present in that NumPy array. So imagine for loops are gone. You don't have to iterate anymore. You can just say that here is an array. Okay, here are so many elements. You just do whatever operation that I want you to do on every element present inside you. Okay, so for loops are gone technically. You'll be thinking कि for loop सीखा ही क्यों भाई? For loop की जरूरत पड़ेगी, ठीक है? बहुत सारी चीजें हैं जो NumPy array से नहीं कर सकते. However, NumPy arrays are super strong. Okay, so we can see that one of the edge that we have, okay, for using NumPy is to actually have a cleaner code. Okay, and we'll see how we can make this code efficient. Let me just charge my laptop and get back to this thing again. Okay, so until now we have seen how you can write cleaner code with NumPy, right? Let's say if you have to perform any operation on all the elements of any list, right? You would choose to actually use NumPy array. Why? Because you can just assume that that NumPy array is nothing but an element in itself, all right? It's an element and you're just performing that operation on that element, right? But that's not all. NumPy allows you to actually write much more efficient code. Okay, so we'll see a couple of examples. The only thing that I'm changing here is that instead of this list which has some 7 or 8 elements, I am creating a list of 1 lakh elements. All right, if let's say if I have to do some operation, for example, let's say adding 2, which is what you've been doing until now, I'll just do it. So I'll say for element in, let's say, a list. Okay, what do I want to do? I want to do element plus 2, correct? Now, to do this operation, what we will do is we will check how much time at an average, okay, a Python native list will take. All right. In order to do that, if I kind of want to check the time duration at an average to perform an operation, all right, taken by a particular statement, all right, in Python, especially in Jupyter Notebook, I can use a percentage time it. Okay, let me just run it and show to you. Now, what this will do is it will tell me at an average how much time this operation will take. Okay, so this is telling me that, okay, boss, it will take me about 5 milliseconds, okay, to do this operation. Now, let me actually do the same operation for a NumPy array. Okay, how will we do that? I'll write again time it. Okay, I'm saying just time whatever I'm doing, and Gemini in Collab Notebook is smart enough to suggest me that hey, you write this. Okay, let me run this very quickly, and the answer comes to be 55 microseconds. Now, to give it an idea about microsecond and millisecond, right? 1000 microseconds make a millisecond. Okay, so it's 51 operation like such. Okay, took 55 microseconds. That means if you do about 15-16 more operations, that is how much time, okay, even this operation for 1/5 of the list will take. Okay, if you didn't get the maths, simply a microsecond is much smaller than a millisecond, right? And this code is actually 100 times faster when you write in NumPy, right? So not just you have clean code, you're getting an efficient code also. Now, to motivate a little bit on using the usage of NumPy array, okay, what I've done here is I've defined two 2D NumPy arrays, right? By now, I'm hoping that you know of what a list is, what a 2D list is. 2D list is nothing but what? It is a list of lists, right? So essentially, every element in this 2D list, right, is a list itself, right? So this element is a list, then the other element is list, right? And since I've wrapped it up in np.array, it becomes a 2D NumPy array. Similarly, L2 is also a 2D NumPy array. I can perform any operations on it. I can just say L1 plus L2. Let's see what it does. It actually gives me a sum of these two arrays element wise, right? So let's say if I sum 1 and 7, okay, this will give me 8, right? I could do L1 into L2 also, right? And I can technically do any element wise operation. I can compare, I can multiply, I can divide, etc., and so forth, right? But the most important task wherein NumPy proves to be a game changer is matrix multiplication. Why? The neural networks, AI, most of the AI stuff that you're building today, all right, is on top of neural networks, right? Transformers are neural networks. LLMs, Chat GPT, all of this is neural networks. And do you know what is the core of neural networks? It is matrix multiplication. It's the matrix multiplication operation that we study in class 11th and 12th. Okay, most of the boards have it. I am assuming that you may have done some bit of matrix multiplication. If you've not, it's a very, very simple operation. Okay, now I will just show you a one quick example of multiplying a matrix of size 2 by 3 and a vector. Vector is of size 3 by 1. Anything which has only one dimensional would be a vector. Okay, I will just show you how easy it is to write this in NumPy. Let me say matrix, okay, at the rate. Okay, why at the rate? Because if I put multiplication sign, it will do an element wise operation, just like what we saw here, right? We don't want to do this. We want to do matrix multiplication. So I'm going to write at the rate here. That's basically a short form for performing matrix multiplication. All right. Now, let me just take this time to kind of summarize what we have learned in NumPy so far. NumPy helps us write the cleaner code, right? It helps us write the cleaner code. How? You can just assume that this big NumPy matrix or NumPy array, whatever, right? Whether it's one dimensional, two dimensional, three dimensional, etc., and so forth, you can just think of it as one single element. And how would you do that operation on one single element? You can do plus, minus, multiply, etc., on that element. And just assume that NumPy will take care of doing that operation for all the elements present inside a NumPy array. Now, this specific thing, although very simple, people often use a very hectic word to kind of explain it. This is called as vectorization, all right? Just very wordy, I know you wouldn't like it, but yes, people just, when they say vectorize, it essentially means that, you don't use any for loops. You just treat the entire array as an element and perform some operation on that, all right? That's what it literally vectorizes, right? NumPy not only does that, NumPy helps us writing an efficient code. You could see the same operation that I would do by iterating on each and every element one by one in NumPy, in a Python list, right? You can do much more efficiently in NumPy, okay? And the most important one, LLMs, neural networks. At the base level, they are just matrix, and NumPy allows us to write very efficient and very clean code for this. So you can imagine, if at all in your daily life you're using any kind of AI, any kind of machine learning model, neural networks, Chat GPT, etc., it is nothing but lot of matrix multiplication operation. Do check it out. Just Google search, you would find a lot of stuff, right? And you'd be surprised that it is just doing matrix multiplication again and again and again and again and again. So forth. Now, we have finished the first part of NumPy, which was essentially understanding why this library is so important. Now, let's start getting into the nitty-gritties, just so that you can do these operations, understand these operations better, and utilize it when you start learning data science and machine learning, okay? So the first thing I will do is I will explain a couple of operations, okay, of creating a NumPy array, okay? I think the first one is something we have already used, so we don't need to understand. You put something inside as a parameter to this function and just call np.array. That would essentially convert any list or anything essentially into a NumPy array, right? A NumPy array. Now, depending on your use case, you can have a one-dimensional NumPy array, which is nothing but just simply like a list. You could have a 2D, you could have a 3D, you could have 4D, etc., and so forth, and you can reach up to n-dimensional array. Imagine the world is built in 3 dimension. Okay, people say that time is my 4th dimension. With NumPy, I can actually work in an n-dimensional regime. Okay, imagine how amazing it is. All right. The next thing is that if, let's say, if you have to create a NumPy array with a sequence with certain steps, what do? You use a range function, right? You do, right? Let's say range. Let's start from 1, go up till 100, and let's take a step of maybe, I don't know what, 10, right? That will create what elements? 1, followed by 11, followed by 21, then 31, and so on and so forth, up until 100, right? Whatever is excluding 100, correct? Instead of range, in NumPy, you call it np dot range. No, np dot arange. All right, array, arange, right? And I'll just tell you just in a bit why, it is different from a typical function like range. What else NumPy can do, which a typical Python range function cannot do. Okay. But yes, we will see some other interesting use cases like linspace. And then, you can create an array of zeros, you can create array of ones, you can create an identity array, and so on and so forth. We will be getting into this, seeing this on a playground in a Jupyter notebook one by one. All right. So let's do it. So I'll start with creating a NumPy array. I am not doing this because we've done it 2-3 times already, but just for you to understand it clearly, how I define a NumPy array, I can define it like this, right? And I can pass any tuple, any list, or anything that would convert into a NumPy array. Now, here, if I have to create a sequence, as I said, in native Python, I would use a range function, right? In NumPy, I will say sequence array equals to np dot arange, okay? And I'll say 1, 100, 10. Let me just quickly maybe print this sequence, okay? Let me run it for you. It created the sequence, right? Now, interestingly, if I would have to convert this and say take a step of 10.5, I'm saying that, hey, I want to go from 1 to 100, but instead I want to take a step size of 10.5. Let's try doing that. It works, right? 1, 11.5, 22, 32.5, and so on and so forth, right? Let's try doing this in regular Python. Let me say range, okay, 1 to 100 and 10.5. Let's just see what happens. It gives me an error. It says float object cannot be interpreted as an integer. That means in a range function, all the 3 inputs that you provide, which is the start, the end, and the step, all of them have to be what? Integer. Whereas NumPy actually gives you a power to actually have them float as well. So technically, it is much more powerful. And for a powerful thing, we would not call it the same thing. We wouldn't call it np.range. We call it np.arange. A is what? Array. All right. So we have learned how to create NumPy arrays. We have learned how NumPy arrays are super strong and faster. Let's dive into creating and working with some n-dimensional arrays, right? Until now, we just worked with 1-dimensional arrays. I'm going to explain and take 1, 2 or 3 more use cases of 1 or 2-dimensional, and then we'll start getting into 3-dimensional space, 4-dimensional space, and I'll start generalizing things, okay? All right, so let's actually start working with n-dimensional arrays. We'll start again with 1D or 2D so that, it's easier for us to kind of incrementally build on, okay? So here is array 1, okay, which is 1D, and array 2 is 2D, right? The first thing that I want to do is I want to actually just find the number of elements of my 1D array, right? You can simply use what? Len function, okay? You can simply use len and say arr1, okay? Let's see what you get. You'll get that there are 6 elements. Now, I'm going to actually introduce you to one more function. You say arr1 dot shape. let's see what this shape gives. Now, shape is actually giving this to me the same thing, but it is giving me in a tuple. We'll just get to understand why it is different from this. So hold on for a little bit, just for 1 minute. Okay. You'll just be able to understand why is it doing so. Okay. Now, I will do the same operation for a 2D array. I will say, okay, tell me the length of this array. Okay. This is going to tell me that the length of this second ARR2 is actually 2. Now, take a pause here. Just pause your video. Maybe think for 10 seconds why it did give me 2. Why it did not give me 6. Why it did not give me 3. Why it did give me 2. Because the length of the outer array is actually 2. There are 2 elements in the outer array. Can you see? The first element is this one. The second element is this one. There are just 2 elements in the outer loop, and that's what essentially length gives. However, if I say print ARR2 dot shape, this will tell me what exactly is the shape. Now this is saying that on the first dimension, okay, and hear my words clearly because this will be very helpful for us to understand the later concepts, and there's a reason why I'm speaking like this. In the first dimension, I have 2 elements, okay, and as in I go in my second dimension, which is this inside list, there are 3 elements, okay. A better way to think about it is as follows. If I think of this 2D array is like this, okay, your first dimension is this one, okay, the vertical one. Your second dimension is the horizontal one. Let me just mark it for you. This is my first dimension. This is my second dimension. Can you see that there are 2 elements along the first dimension and there are 3 elements along the second dimension? I'm sorry, right? And that's what essentially this shape thing is telling me, that hey, it is a 2 by 3 matrix, or it is saying that I have 2 elements along my first dimension, and I have 3 elements along my second dimension, right? Now you can guess why this was written in bracket, because it is saying that, I just have 1 dimension, okay, and it's 6, and then other dimensions are undefined, okay. Did you get this idea? Maybe just try to absorb, assimilate what we have understood, okay, what we've learned. Just spend 1 more minute, okay. We can do a couple of more interesting examples so that you understand it better, right? But let me just explain the concept of dimensions by taking this specific example, okay. I had what? Let me just check. 1, 2, 3, 4, 5, and 6. So this is my first list. This is my second list, okay, and this is wrapped in another list, right? Now think about it, okay. Earlier, when we just had one list, let's say 1, 2, 3, this is the only dimension I have, and I'm going along this, and I have 3 elements here. Now when I added one more list over here and created a 2D list, okay, so one more element got added here, and now along this side I have 2 elements, and I'll call it as a 2 by 3 2D array, right? So the new axis always come from the left side, correct? The new axis essentially would come on the left side. We'll see more examples. Let's just try to understand. This is a scalar, okay, it has no dimension, okay. This is a number, okay, it has no dimension. When it turned into a vector, basically it got 1 dimension, which has what? 3 elements. So I'll write it as 3 comma, okay. When we started moving in 2 directions, okay, so we saw that along the first dimension I have 3 elements, along the second dimension I also have 3 elements, so this becomes 3 comma 3. Now this is the most interesting one, okay. Along the first dimension I have 3 elements, along the second dimension I also have 3 elements, and this is my third dimension. think about it. Am I thinking about it right or wrong? Is it my third dimension or my first dimension? Your first dimension always, your last dimension will always getting added from the left side. Okay. So when you had a vector, you basically added one more dimension to it in the left, and it became 3 by 3. Now you're adding one more dimension, which is essentially taking a stack of multiple 2D arrays right on top of it. You can think of it as like a cuboid or any 3D object, right? The dimension is getting added in the left side, right? So this will become 3 comma 3 comma 3, right? If there are 3, no, there are 1 2 3 4, there are 4, so this will become 4, right? I hope you are able to understand the idea of dimension. So you can think about this, right? If you're standing here in a particular direction, you don't have any direction, you're directionless. All right. Essentially, if you are at scalar, you're dimensionless. Okay. When you actually go in a particular direction, all right, when you start navigating, all right, you start going in a particular direction, right? That's what makes you 1D, right? Now, when you kind of start building up such things, right? You think of stacking, such lines on top of each other, right? You build a plane, right? Now think of stacking these planes, all right, on top of each other. That will actually give you a depth also, and that will become a 3D object. Now think of placing these 3D objects in a particular dimension, which we can't visualize because we are humans and we can think of a 3D space only. But you can imagine placing these multiple boxes across different time points. Think of a YouTube video, okay? You have one frame, all right? And it goes, something changes in every dimension, right? I mean, something changes in every second. That's the time direction, right? So you can think of an object actually moving, all right, a long time, right? So that is essentially the fourth dimension. And now try thinking about n dimensions. You won't be able to, of course, because sadly we're stuck as humans in a three-dimensional space, right? But you get an idea, right? What I'm saying. You'd be very excited to know that an image is actually a 3D object. It has 3 channels, okay? So an image has 3 channels. One is R, second is G, and third is B. Okay, RGB. These are primary colors that you can see. All right. So any pixel that you see at any point, right? So any one pixel, okay, which is like, one little point on the screen that you see is mixed of 3 colors, R, G, and B in certain proportion. That's you can actually create any color using, just three numbers essentially, right? That's RGB. So this is actually a 3D object. If you'll see, these are 3 2D list placed together. And now if I travel in one more dimension, which is time, this becomes what? A video. So an image turns into a video. So video is actually a 4-dimensional object, right? And when we see a video, we see it in 2D, of course, but then in the very core of it, in the very crux of how video is stored in forms of numbers, all right, is actually a 4-dimensional object, all right? I hope you are enjoying this. Let's try maybe indexing and slicing these arrays, okay? So I'm going to start with a simple array 1, which was a 1D array, okay? I am going to say, give me the 4th element, okay, of this array. How will you get the 4th element? You can start actually coding along with me, because this is something simple. You have done indexing, slicing a couple of times. By now, you should be able to attempt these alongside me. Just pause, attempt, then start, then pause, attempt. All right. ARR1, okay. And then I will say the 4th element. What will be the 4th element? This is 0, this is 1, this is 2, this is 3, and this is 4, right? But we want to get the 4th element. That means we should be using what? Index 3, right? So I'll say ARR1 index 3, and this gives me the 4th element. Okay, some indentation error. Okay, so forgot to indent it properly. But yes, this gives me what? My fourth element. Fourth element is what? 67, and it's showing that, it's an integer 64 numpy object. Okay. Let's try to slice from index 2 to 4, but I want 4 to be inclusive. Now, if I want 4 to be inclusive, shouldn't I say array 1 start from index 2 and have 4 inclusive? So I would have to write what? 5, right? Let's just quickly run. Okay. Now the interesting part is when 2D arrays comes into the picture. Okay. Just for your ease, I will try to write the 2D array like this. Now it is saying access the second array, index 1. Now, which one is the second array? Sorry, second row. Second row is this one. Okay. And I have to access index 1. That means I want to index 5, right? Do think about it. How can I do it? I will say array 2, okay, and in this one I will say, hey, access the second array, right? Second row. So I will say 1, and then I will say again 1, right? This will give me essentially what? 5. But here is one interesting thing. This is how you do not write in NumPy, right? Because what it will do is it will first slice off this part and then slice off this part. However, this is not computationally efficient, right? If instead you end up writing like this, right? All the dimensions separated by comma, right? You would be able to, NumPy would be internally able to slice this as one single go, one single attempt, right? So that's how you write NumPy code. It's okay to actually slice in steps. You slice across the first dimension, then you slice across the second dimension, then you slice across the third dimension. But this is how you should be ideally doing it. Let's give it a try for one more. It says access second of the first row. So you want to access the second element of the first row. First row is this one, and second element is this one. How will I do? I will say array, okay, first row, that means 0, comma, I want to access the second element, right? So I will use index 1 over here, okay, and that's how, oops. That's how I will access it. Oh, I should be saying array 2. Perfect. I hope this is clear. Let's try one more, just one more for indexing and slicing, and we'll try to kind of update, do some changes in the array just after this. But the last one says, hey, I want to access the second and third elements of the first row. Okay. So this is the first row, and I want to access the second and third element, which is what I want to access. I want to slice 2 and 3. What will you say? Hey, across the first dimension, I want to access the first element, which will be at index 0. Okay. And then I want to access these elements, right? That means starting from positional index 1 and until the end, right? That's how I can write it. And this, okay, again, it should be array 2. It gives me 2 by 3, 2 comma 3, right? I hope that you're able to understand, because you've learned indexing and slicing before also, okay? If you are not able to understand this, I would generally suggest that you go back and check indexing and slicing basic tutorials. You do a couple of questions before you come back, right? But ideally, this part should be quite graspable, all right? In the next part, we will check, how can we make certain updates, okay, to a NumPy array, okay? So let's switch, do some questions, and we start learning more. Okay, so until now, we have learned how to work with 1D array, 2D array, and in fact, we've learned 3D array also. We learned how you can index them and slice them. Now let's see how we can update any elements at a particular array, right? So let's say if this is my array, okay, this is my array 1. I'm just going to copy paste this, okay? So if this is the array I'm working with, I want to replace my element at second position, which is essentially at index 1, okay, with some value, okay. I will write this and I will say, okay, change it to 12 maybe. Let's say change it to 12, okay, and I'll try to print the array. This actually prints me the answer, okay. But let's try to do something interesting. Let me try to update it with some character or some string. Okay, so let me just say maybe okay. Let me try doing this. This is giving me an array error. Now, why? It says that it's an invalid literal for integer with base 10. Now, what is happening in NumPy here is that NumPy can store, although any kind of data type. It can store integer, it can store float, it can store string, it can store boolean, but you can only store one kind of data. And that's the only one part where NumPy array is actually inferior to Python list. But here, this was an intentional decision taken, okay, in order to optimize for the efficiency, right? So the flexibility that you lose, that your lists are versatile, you can store any kind of elements, okay. For a NumPy array, all the elements have to be of the same type, right? And it allows NumPy to actually store them together in a contiguous memory fashion. All right, you don't need to get into all the details about all of that. I'm just saying it for the sake of it, for the sake of completion. But this is essentially what actually powers NumPy to do all the calculations, everything much more faster. And turns out the reality is that most of the operations that you'll do in mathematics, right, will just have one type of uh, 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 operands, right? It will have either integer, it will have either decimals, it will have strings or whatever. And neural networks, it's all floating numbers, right? It's all decimal numbers. So it works, right? So something like this won't be possible. However, if you happen to define a NumPy array with strings, right, then it should be okay, right? But the type of the NumPy array, okay, has to be different, okay? And when you define a NumPy array, it automatically detects, what type it is, right? So in couple of answers you might have seen when we tried slicing a particular value, it says that it's of type integer. Okay, cool. Now let's try maybe some operations on NumPy array. All right, just because it's simple, so I'm not gonna write it, okay, to save some time. But if let's say if you have a list, okay, you convert it to a NumPy array. If you want to calculate this mean, you can just say np.mean. Okay, you want to calculate its median, you just say np.median. You want to calculate the max value, you do np.max. You do np.min. You can do np.sum. You can do np.prod. And whatever typical, very popular or very common operations that you have to do, turns out NumPy will actually have a function for it. You can just Google NumPy function, how to do this, and NumPy, etc., whatever you want to do. And NumPy most likely will have a function defined for it already, so that you do not define a not so efficient code. All right, they figured out for us what's the best way, what's the nicest way to do it. We will see its power when we work with 2D arrays or 3D arrays. All these functions that we are working with, np.mean, np.median, np.max, all of this will actually be applicable on a 2D array, 3D array, 4D array, and so on and so forth. Okay. Now, here comes the next thing. Okay, we start working with a multidimensional array. I'm just going to leave all of this. You can just perhaps try it on your own. np.prod, np. Here I'm just taking the size of the NumPy array, all of that. All of this is very much easy. Okay, I think one thing which I can stress on is this function. So let's say if you have this NumPy array, if you do np.unique, okay, and say salaries 2, okay, it will actually tell you how many unique elements are there. Sorry, how many, which elements are unique present, which of the unique elements are present here. So 10 is there, 15 is there, 20 is there, 25 is there, 30 is there. Then 15 and 20 is repeated. So it's in a way is actually giving you like a set, right? Remember a data structure called set, right? In Python, right? That essentially it gives you all the unique values. If you want to find number of unique values, you can just say np.nunique. Okay, number of unique, right? So this will give you, oops, there's no, okay, that's perhaps pandas. It should be n unique. Let me just quickly check. See, this is the beauty of learning how to code. You don't have to remember all the functions, and that's why I chose to actually not remind you or teach you one function. You can just Google. All right. Turns out np.nunique doesn't work. what works, I can check. I can say unique values in numpy count. Okay, let's see if there is a function for that. It says numpy.unique, which is something I know, and it says, oh, you can say return count equal to true. So it will start giving you a return count as well. Okay, so let me just try it. I will say return counts equals to true. Okay, see, you do not have, as a Python engineer, you do not have to remember the functions. All right, you should be able to figure out how and what to use to get the best thing from your part. Okay, and that's pretty much sufficient. Okay, so if in case if you just want to find unique values in this list, you can just say np.unique and you're done. It tells you how many unique values are present. Okay, go back, check a couple of functions. Okay, np.mean, np.sum, try it out for a couple of values, check that your answer is good, and if you are able to understand it, we can move forward. Okay. Okay, so now it's the good time. We start working with n-dimensional and 4-dimensional, 5-dimensional, etc. is like super fun. Okay, so here if you see, what I have done is I have actually created two-dimensional arrays. Okay, two-dimensional arrays. When you stack two-dimensional arrays, essentially that gives you a 3-dimensional array wherein you will have two elements in the outermost list or array. What it means is as follows. Let me go to the slides to explain a little more. Okay, so this is my first array. Okay, this is my second array, and this is 2D, this is 2D. When you stack these together, a new axis of two elements, okay, is created, and the dimension of this will be 2, comma, this is what, 2, and this, which is what, 3. So this array essentially will be a 2 by 2 by 3 array. Try to look at it a little more clearly. So you'll see that a 2D array that you created over here is actually a 2 by 3 array, a 2 by 3 array, right? Or a 2 comma 3 array. When you try stacking two of them together, you add one more axis towards the left side and it becomes 2 comma 2 comma 3 array. Okay, that's what essentially a 3D array is. Let's try to understand if we understood this concept properly or not. So for that, let me just perhaps show a couple of examples. So first of all, if I create such array and if I try to check the shape of this will give me 2 by 2 comma 3, 2 comma 2 comma 3, right? I can also check maybe length of T1. Okay, when I check length of T1, what do you expect? What will be the answer? Give it a pause, give it a try. The answer will be 2. Why? Because in the outermost list, there are only 2 elements. There is one more interesting function, attribute that you can check. That is T1 dot size. What is your guess? There is this length, there is size, there is shape, so many things. What is your guess what size will do? Size essentially will actually tell you the number of elements in the array in total. Doesn't matter what's the axis, how many axes, how many dimension does it have. It just plainly tells you how many elements together are there in this array, right? And as you can see, there are 6 elements here, 6 elements here, and that's why 12 elements in total. Should we try perhaps maybe trying a couple of examples on this? Should we try that? Okay, so the first thing is that I may want to know, oops, let me just remove these parts so that we can perhaps try it by ourselves. The first thing that we may want to try is accessing the first 2D block. Okay, I am saying that I want to access the first 2D block. First 2D block essentially is this, right? How can I access this? This is the first element in my first dimension. So can I say T1, okay, provide me the first element in the first dimension? That gives me the first block. Okay. Second question says, accessing the second row of the first 2D block. Now I still want to work with the first 2D block, which is this one, but I want to access the second row. I just want to access the second row. Okay. So on top of this, can I say T1? Okay. I'm going to access the second row. Okay. So 0 for accessing the first 2D array, and then 1 for accessing the second row, right? But hey, we learned that we can do a better job by actually writing it like this. And this actually allows me to access the second row in my first two-dimensional array. Okay. Hope you are able to understand. Just rewatch it. If you're not, you'd be able to understand. Okay. Accessing the second element of the second row in the first 2D block. We're still in the first 2D block. Now I want to access the second element, which essentially will be the second row. Okay. And what would I want to do? I want to access the first 2D block, and within that I want to access second row, and within that I want to access the second element. Okay. So it's simple. I mean, you can think about it. Second. No, first, second, right? So T1, 0, okay, 1, 1, right? That gives you 5. 5 is where? 5 is here. It says access the first 2D array, okay, first 2D array, and within that access the second row, okay, and in the second row give me 1, as in the element present at index 1, which is what? 5, right? So you get 5 from this. All right. Let's maybe try doing a couple of more operations on this. So if this is the 2D array, let's say if I have to take mean of this, I will say T1 dot mean, and this will give me a mean, right? This will give me a mean. But here is the interesting part. If I say, let me add print to this. If I say print T1 dot mean, but I am asking this to give me a mean in a particular direction. Okay. I say that, hey, give me the mean across axis 0. Now, axis 0 is this one. Let's see what happens. Okay. I'm going to say axis equals to 0. Okay. So the answer we get is 4, 5, 6, 7, 8, 9. Let's try to understand why it is coming. Okay. This is the most important bit. Okay. You have to figure out why taking a mean of this along axis 0, okay, is giving me 4, 5, 6, 7, 8, 9. Okay. If you have to understand this concept in an easier fashion, think about that you are basically compressing whatever axis that you are giving. So if you have given axis 0, you essentially want to compress axis 0. Okay. Axis 0 in this particular case, okay, is this one along the horizontal line. That means I want to compress this axis to just have one element. Okay. That means I will take a mean of 1 and 7. I will take a mean of 2 and 8. I will take a mean of 3 and 9, and so forth. What is the mean of 1 and 7? You add 1 and 7. This is 8. 7 plus 1 is 8. You divide it by 2. You get what? 4, right? You are getting 4 here. Then you take a mean of 2 and 8. 2 plus 8 is what? 10. 10 divided by 2 is what? 5. You get 5. Let's try this one. 5 plus 11. 5 plus 11 is what? 16. 16 divided by 2 is what? 8. You get an 8 over here. Correct? Now, the dimension of this guy would be this. I can check the shape of this using this. Oops. Oh, I can't do print, right? So I will have to write shape inside, right? So it tells me that the answer is 2 by 3. The answer is what? 2 by 3. Remember what was the shape of this array? If I remind you, it was T1 dot shape. It was 2, 2, 3. I tried taking a mean along axis 0. That means I try actually compressing or basically squeezing the axis 0. Axis 0 got squeezed to 0, and hence the final answer returned was 2 comma 3, right? Had I taken a mean along axis 1, okay, the final output again would be a 2 by 3, right? Because this one and this one is left. Had I taken a mean along axis equals to 2, this dimension would have actually gotten squeezed. The answer would have been 2 by 2. Let's check it out. Let me say axis is equal to 2, okay? The answer is actually 2 by 2. And what is the answer? Let's print that also. I'll say T1 dot shape, okay, axis equals to 1 or 2. 2, yeah? Oops. T1 dot mean. Okay? You see what is it trying to say? It's saying squeeze the axis 2. Where is the axis 2? So this was my axis 1, or my first axis basically, with axis equals to 0. This was my axis equals to 1 or 2. Think about it. Think along this. It is kind of challenging. It is not as easy as you would think. Let's try to think using some scribbling. Okay, so I'll just go back here. I will say, okay, this is my array. We're using the same array. And what I'll try to do is, I'll try to put these in a single line. Okay, in a single line. Okay, single line would be difficult. Let me just perhaps draw it. I will say 1, 2, 3, 4, 5, and 6. Okay, this is my 1 2D array. This is my second 2D array. 7, 8, 9, 10, 11, 12. Okay, and this is wrapped in another array. And that's what makes it a 3D array. Right? Now, how many elements along my first dimension or axis equals to 0? 2 elements, right? This one, the first one, this one, and this one, right? 2 elements. Now, for number of elements, checking along axis equals to 1, okay, I would have to get inside one of this, right? So in this, my first dimension is this one, right? How many elements are there this side? Again, 2 elements, right? And in my final axis, which I can perhaps use a different color. Okay, let's go with this pinky ponky pink. Axis equals to 2 will be this one. And I'll have what? 3 elements over here. So 3 elements. Now, if I'm trying to say NP dot mean, okay, axis equals to 2. I'm trying to say, hey, squeeze this element, squeeze this dimension. That means you take a mean of 1 and 2 and 3, you take a mean of 4, 5 and 6, you take a mean of 7, 8 and 9, and you take a mean of 10, 11 and 12. Okay? What will be the mean of 1, 2 and 3? 2 plus 1 is 3, 3 plus 3 is 6, 6 by 2 is 3, right? So essentially, after taking mean of this, you would essentially get 3, right? Think about it. When you do an NP dot mean axis equals to 2, all right, you are trying to take, all right, you are trying to actually take a mean along your third dimension or your second axis, which is shown through this pink color. In this one, you will take a mean of 1, 2 and 3, okay? 1 plus 2 plus 3 upon what? 3, right? This will give you what? 6 upon 3, which is what? 2. Let's check if we got 2 or not. Did we get 2 or not? Yes, we've gotten 2, right? Let's try it for one more. I'll say take mean of 10, 11 and 12, right? Take a mean of this. 10 plus 11 plus 12 upon 3. okay, upon 3, right? 10 plus 11 is what? 21. 21 plus 12. 21 plus 12 would be what? 33. 33 by 3 would be what? 11. Let's check if we got 11 or not. Yes, our last element is 11. I hope you are able to make sense out of it, and also understand that here I took a mean. I could do np.sum, I can do np.prod, I can do np.median. Whatever operation I want to actually perform on any array on a particular axis, I can do all of that. Now imagine what all it takes to kind of do these operations in native Python. I hope you are able to understand the importance of NumPy and how powerful it is. Okay, so in the last part of this module on NumPy, we talked about 3D arrays, right? We started with 1D array, we went to 2D arrays, and we saw how you can extend this idea to an n-dimensional array, wherein in case of 3D, it's a 3D array, correct? A 3D array is nothing but when you stack multiple 2D arrays on top of each other, right, it becomes a 3D array. Just see the case here. I have one 2D array here, I have another 2D array here, and I'm going to stack it, right? I'm going to stack it simply. And this is where I have created another axis. And remember, the new axis is going to become what? 0. If this axis becomes 0, all right, the old one, this one becomes what? It becomes what? 1. And this one becomes what? 2. Correct? Now it has 3 axes, right? Now, if I'm trying to do a sum across my 0th axis, right? It says axis equals to 0. It's saying that, hey, sum the array across 0th axis. So essentially that means is that, hey, take all the elements along this axis, which is axis 0, and just sum them up. How many elements do we have along axis 0? We have 2 elements. Remember, one is this element and another is this element. Now, when you sum 1 and 7, what do you get? You get 8. When you sum 2 and 8, what do you get? You get 10. When you sum 3 and 9, what do you get? You get 12, right? However, summing across a different axis would have been different, right? For example, let's say if I say axis equals to 1, this time I want to sum it across axis 1. Remember which one is axis 1? Axis 1 is this one now, all right? This one. And I'm not talking about these two elements. These are along axis 0. Okay, I'm talking about these rows, all right, this dimension particularly. I beg your apologies, of course, like it's very difficult to kind of represent this array in a 3D setting, right? So the two axes essentially would appear to go in the same direction, but these are two different directions. Here I'm talking about when I say I want to sum along axis equals to 1. Remember, the first element is 5. Do a quick guess. What elements would essentially give you a 5? Can 1 plus 4 give you a 5? Can 2 plus 5 give you a 7? Can 3 plus 6 give you what? A 9? Can 7 plus 10 give you a 17? 8 plus 10 gives you a 19, and 9 plus 12 gives you a 21. That means it is saying that, hey, okay, take this element and take this element, just sum it. Take this element and this element, sum it. Take this element and this element, sum it. Now you are essentially summing across the rows, right? So the row axis, the axis along which rows are represented was axis 1. The axis along which columns were represented was what? 2. And the axis along which 2D arrays, all right, were concatenated, that was axis 0. I hope you are able to understand the idea of axes. I hope you are able to understand the idea of ND, 1D array, 2D array, 3D array. See, it's not an easy concept, all right? It takes much more time to kind of get to understand. I would sincerely suggest you that you try a couple of examples here, and even after that, just sink it. Next time when you'll use it, you'll understand it better, all right? I have kind of been known about this axis system for almost 5-6 years, but at the same time, everybody around, I have seen everybody getting somewhat confused about it. So it's more about like practice. And at the same time, it's more about intuition. It's not about remembering. All right. So that's my 2 cents after explaining this. Next thing that we're going to talk about like is a couple of other miscellaneous functions that we can use. All right. Now, let's say this array is a 1D array and it is storing scores of the students. All right. So let's say there's a test and 3 students, let's say, appeared for it. They've scored 85, 92, and 78 out of the test. Right. Now, I want to check which numbers are greater than 82. Had I been doing it in the native Python, I would have run a for loop. I would say for I in this list, check if it is smaller than 82 or not, or greater than or 82 or not, etc., etc. What is the condition? And just print it, right? Now, what we learned in NumPy is that I can simply just say score 1 greater than 82, all right, and it will give me a true false, right? So for all the places where it shows true, all right, it means that it is actually a number greater than 82, all right. And for all the places where it shows false, that number essentially is smaller than 82, right? Now, what if I have to put multiple conditions into it? For example, let's say I want to check if the number is greater than 80 or less than 90, right? So essentially I want to check if the number is in between 80 and 90, right? How can I do that? I'll say score is smaller than 80, okay? I will put it in the bracket and I'll say score 1 because that's the name of the variable, okay? I'll explain why I have put it in the bracket and I will write AND. But hey, this AND is used in the native Python. Here, I will not be using this AND. Let's actually see what happens when you do this kind of an AND, okay? Let's see, maybe it works, okay? Let's say that this should be smaller than 90, okay? Let's run it. It says an error. It says the truth value of an error with more than one element is ambiguous, all right? Because AND is not able to understand it. AND essentially wants to take two Boolean objects and just wants to compare it, right? So what you do here is you rather put an ampersand. Ampersand is a special character and, okay, this is what essentially is used when you want to work or do an AND operation for NumPy array, all right? Let's see if it works or not. Yes, now it works. It says, okay, 85 is, okay, did I put a wrong condition? Yes, score 1 should be greater than 80. Okay, let's see the answer now. Is 85 greater than 80 and smaller than 90? Yes. Is 92 greater than 80 and smaller than 90? No. Is 78 greater than 80 and smaller than 90? No. All right, so true, false, false, right? However, at a lot of times, I just don't want an array output of trues and false, all right? I may want to also know the indexes at which the condition is true, right? So simply in that case, what I can do is I can say np dot any, okay? np dot where, okay? When I say np dot where, okay, it essentially, okay, some error, let me quickly check. Have I put the required number of brackets? No. Let me just put one more bracket. Okay, np dot where. All right. I am trying to ask here, hey, what are those indexes where essentially the number is between 80 and 90? Okay, I could actually do without one more extra bracket. I kind of ended up doing it. So let me just remove it. Yes, it is kind of trailing me that, hey, it is only at index 0 where this condition is met, right? You want to check if this condition, if this np.where functionality is something that you can use actually for checking if this condition is true for multiple cases or not. Shall we make some changes to the condition? Shall I say maybe 93? Okay, 93. In this case, essentially, it should meet for 85 and 92 both, right? So it should give us index 0 and 1, let's say. Yes, it is giving me indexes of both 0 and 1. How cool is it? When you want to just simply get an array of trues and false, you can just get that by, doing the comparison. And if you want to even check which indexes where this condition is meeting, you can just put np.where and you have the answer. All right. Now, more fun part is if you want to check, let's say, if any of these cases meet this condition, or if all of these numbers meet that condition, so you have functions for those as well, right? So in case, if you want to check, let me just write it for you. If you want to check if all the numbers are meeting a condition, okay, then check it by using np.all. And if you want to check, let's say, if all the numbers are, if at least one number, okay, is meeting the condition. Is there even one element which is meeting the condition? Okay, then you actually check np.any. Okay, np.any. Now in this case, I want to check if there's any value, okay, any value that are smaller than 78, right? That are smaller than 78. Is there any value which is smaller than 78? It is not. So what should it say? It should say false. Okay, it should say false. Let me say smaller than equal to 78. It should say what? True. Why true? Because now there is at least one number which is smaller than equal to 78. Now what will happen? Pause off for a minute and figure out that what will happen in case if I say if are all the numbers in this array, okay, actually smaller than equal to 78. Let me say np.all, okay, and let's check. Of course, it is meant to come as false. Why? Because yes, not all the numbers are smaller than equal to 78. Yes, there is one number which is equal to 78. However, not all the numbers are equal to 78. I don't think this should be very difficult to understand. So I'll quickly jump to another cases as well. We will do one more exercise wherein we'll try to check this condition. It says find indexes where the condition a greater than 2 is true. All right. What it is trying to say is that, hey, I want just the indexes of those cases, right? What do you think where a is greater than 2? It is greater than, is it greater at this index? No. Is it greater than 2 at this index? Yes. And for all the numbers after this, it is greater, right? And what are these indexes? These indexes are essentially 0, 1, 2, 3, 4, and 5. So it should output 2, 3, and 4, 5. Let's see. I'll say np dot what? Where? Any or all? Where? Yes. And I will say, hey, tell me where all, okay, this thing is greater than 2. So I'll say greater than 2. Okay. It says that at indexes 2, 3, 4, 5, the number is greater than 2. I hope this is clear. Now, when you're clear about this, we will now start about learning matrix multiplication. So now, in this specific part, once we've done this, we will talk about matrix multiplication. All right. Matrix multiplication is something that we've seen essentially before also. So here is a matrix. Okay. What do you think? What is the shape of this? Guess the shape of this matrix. It has, okay, 2 rows and 3 columns. So is it 2 by 3? Yes, it is 2 by 3. Okay, let's see the other matrix. It has 3 rows and 4 columns. So it is what? 3 by 4. Remember, for a matrix multiplication operation to be actually valid, all right, this is 2 by 3, this is 3 by 4. Okay, for any of the matrix multiplication operation to be valid, this and this has to be same. Okay, okay, the number of columns of the first matrix and the number of rows, okay, of the second matrix, they have to be same. Correct. Now this is the valid case in our case, okay, and the output here will be a 2 by 4 array. All right, this is essentially how matrix multiplication happens. I'm not going to go into details. You can check out some other YouTube videos or perhaps Google of how to do matrix multiplication, but this is essentially what happens. Now if you see the output, I'm using np dot function. Earlier we discussed that you can use @, all right, @ simple also to do a matrix multiplication. The output should be 2 by 4. Is the output 2 by 4? Yes, it has 2 rows and 4 columns. It has 2 rows and 4 columns. So there's no magic over here, right? Matrix multiplication is simple. But where is the magic is something we'll see. So in this case, I'm going to tell you I'm going to give you a simple example. Actually, a real world case of how Numpy matrices can be used. So imagine that you're working for delivery. Delivery is a supply chain management company, right? I hope you're aware It's called delivery. Delivery with Delhi. All right. Started with Delhi. The idea was to kind of like, deliver things in delivery, but they have pan-India operations now, perhaps outside also. But yes, it essentially, it's a logistics company, tries to like, send your parcel, etc., elsewhere. All right. All of that, right? Now, what happens is that they kind of need to do some kind of forecasting. And for that matter, any e-commerce giant, a warehouse, all of them have to kind of do some sort of a forecasting as well, right? And basis on that, they kind of predict what will be the revenue for the next quarter, next month, next week, etc., etc. All right. Now, in order to do that, they kind of need to know the unit price. That means price of one unit of that product. All right, and there are multiple products. All right, they need to know the unit price of each of the product, and they have to predict how many of those products will be required. How many of those products do you think we will have to deliver, etc., etc. All of that, right? Delivery may have their warehouses. Zepto has their dark stores. Amazon has their warehouses, etc., etc. All of that, right? Now, in this case, I am taking a matrix wherein I am actually putting something in this first matrix. It's a 2 by 3 matrix, and as the description says, it has 2 forecasts and 3 products. All right. That means this matrix is storing 2 different forecasts. All right. So the first forecast model, let's say machine learning model, is forecasting that the product A will be sold 10 units, sorry, 100 units of the product A will be sold. 200 units of product B will be sold, and 150 units of product C will be sold, right? Whereas the second forecast says that 80 products of product type A will be sold, 250 and 120, and so on and so forth. All right. So essentially, this matrix is storing that, okay, what are the 2 forecasts and what each forecast is forecasting or predicting that how many units of a particular product is sold, right? I have another matrix which is 3 by 3, and what it is storing is, it is storing the per unit prices of those products for the last 3 days. All right. Let's say the prices of those products are changing, right, due to some discount, etc., etc., or it's like, a perishable product, for example, fruits, etc., etc., bananas, apples, and they are perishable, perhaps their prices will also change. So what this matrix is actually giving me is the prices of these products for the last 3 days and their per unit prices, right? Let's say this happens to be my prices of 3 products for the first day. This happens to be my prices for the next day, and this happens to be my prices for the third day, right? When I actually do a matrix multiplication, which is nothing but a dot product, all right, for 2D arrays, right, I gets this kind of an output, right? This kind of an output. Remember, my input matrix one was 2 by 3 in nature. The other one is actually 3 by 3 in nature. The number of columns of the first matrix and the number of rows of the second matrix are same, and hence this matrix multiplication is valid, and the output of this matrix multiplication will be a 2 by 3 array, right? Is it a 2 by 3 array? Yes, it has 2 rows and 3 columns. But what essentially it is giving me? It is essentially giving me the revenue. How? If you want to calculate the revenue essentially will be what? Revenue will be the price of 1 unit, all right, the number of unit that you forecast, correct? And then there are 2 forecasts. So essentially you get revenue of 2 different forecasts, right? And can you see that there would have been multiple equations or multiple calculations that you would have to do, and matrix multiplication is nothing but just putting that idea together in a simple way wherein it is easy to carry those operations if you have tons of data, right? Essentially, this is what we learned, that hey, I may want to use NumPy for doing my operations quickly, faster, and then, in a more simpler way, correct? Now the interesting part is here. I have another matrix which is actually telling me the delivery cost of each product. All right. Say the delivery cost of my first product is 100 rupees. The delivery cost of my second product is 150 rupees, and the delivery cost of my third product is 120 rupees. Now, I may want to add this cost, all right, 100, 150, and 120, all right, to my revenue, all right. And I may want to add 100 rupees, 150 rupees and 120 rupees to my revenue also. It doesn't matter what is the actual cost of the delivery. It is the cost of the delivery that I am charging to the people. So that actually gets added to the revenue. If you have some basic idea of business, all right, that's how essentially you would calculate the revenue. In general, I would say that, hey, just add revenue and delivery cost. And this is what I'm doing, right? But can you add a 2 by 3? Can you add a 2 by 3 matrix, which has essentially what? 2 rows and 3 columns to just a matrix which has 1 row and 3 columns? No, you need to have something over here, and something over here, right? That's where broadcasting again is very useful, because Numpy is smart enough to understand that, hey, this guy is 2 by 3, this guy is 1 by 3, and I can't add these things, right? Because I don't have enough number of elements in my both the arrays to do an element wise operation, right? But when I have to do this, what I'll do is I'll just simply repeat this thing 2 times. That means it will say that, hey, I will create another matrix 100, 150, 120, adding 100, 150 and 120 2 times, right? Now it has created this matrix and it becomes a 2D matrix of size 2 by 3. Now you can add them. And you don't need to tell Numpy to all of that. Even when you say, hey, just add revenue and delivery cost, it will just add these together and it will give you the answers, all right, by simply just doing it, all the operations. So Numpy is this smart, right? This is essentially what is called as broadcasting. There are 3 broader rules for broadcasting, which we will not go into the details, all right, in this course. However, if in case ever you come across the situation where you say, hey, these dimensions are not matching, but somehow the operation is happening, how? You should know that it is broadcasting, right? You don't need to know the rules of the broadcasting. Although if you're curious, you can just say broadcasting in Numpy, 3 rules, etc., etc. You'll be able to find it, right? The next part, we will talk about a couple of just small miscellaneous methods, and we'll just end the Numpy. We have learned a lot. I know Numpy was super cool, but trust me, as when you start learning pandas and when you learn matplotlib and Seaborn, the whole horizon will be crazy and you can't just imagine what all you'll be able to build. All right. So let's quickly talk about these miscellaneous methods also, right? We have done, for example, any, where, all these are miscellaneous methods, but we'll talk about 1 or 2 more. All right. Let's say you have these 2 matrices here. Again, these are matrices. Why? Because this is a 2D array. Now you'll be able to see it better when I write it like this. All right. Let me write this also like a 2D array, and you'll be able to understand this part much more better, right? Can you see that these are 2D arrays now? Yes. What is the dimension of these 2D arrays or shape? It is 2 by 2. Both of them are 2 by 2, right? Now, if you want to concatenate them, all right, how do you do? All right, I will say np dot concatenate, okay, concatenate, okay, and I'll say current year, okay, current year and previous year, okay. Okay, Collab was doing the job for me, but then I ended up pressing something and it could not. When I say axis equals to 0, it will essentially, okay, np dot concatenate current year, previous year, and axis equals to 0. All right, so I know what is the error. But hey, when I'm trying to use axis equal to 0, what should happen? Should it not actually concatenate these 2 things along axis 0? Yes, right? But hey, I could actually give multiple arrays and ask np.concatenate to concatenate them. How will np.concatenate understand, what are these all arguments? So I need to put them into the bracket, all right? So that np.concatenate function understands that, hey, this is just one element that you've part, which is essentially a list of some elements, and now it will be able to concatenate them well, all right? I'm actually glad that this error happened. Otherwise, I would have forgotten to tell that you have to put these things within a bracket. So to Numpy to understand that, hey, this is essentially data. You can just add the data, you can put the data, pass the data to NumPy, and like, okay, this is array 1, this is array 2, this is array 3, and just you figure out like how many arrays are there, right? You put it in the list and say that, hey, this is the entire data, and you check how many numbers or elements are there, and then you do the operation, right? Yes. Last thing but not the least, we will learn how to transpose the data. Now, what do I mean by transposing? I'll say current year. Okay, let me just print it. If I say np dot transpose, okay, np dot transpose, this comes very handy in mathematics. All right, np dot transpose current year. What it will do, it will essentially, change the axis of the array. That means it will turn rows into columns and columns into rows. What do I mean by that? The first column was what? 70,000, 90,000. Look at the first row, 70,000 and 70,000 and 90,000. So what it has done essentially, it has actually converted the first column into the first row. It has converted the second column into the second row, right? And vice versa. That's essentially what transpose is, right? So we've learned the entire NumPy, okay, and I know it must be overwhelming because you've learned a lot of functions. Trust me, you need to understand this intuitively. You need to kind of like, do some hands-on work, and you will be able to understand. Do not try to mug up everything. Do not try to learn everything. All of these concepts will become much more crystal clear when you do a couple of questions, or when you start using this to work on the real data. We've not started working with real data yet, but we'll do. All right. And that's where actually the real power of NumPy, or in fact the tools that you learn, all right, in the next module, pandas, matplotlib, seaborn, etc., it may come into the actually life. All right. So see you for the next module on pandas. I hope we remain connected.
You have just finished a complete Python bootcamp. Great job. But this is just the beginning. We have got many more tutorials and live sessions coming your way, all designed to help you level up your coding skills. Tell us what you like to learn next in the comments, and don't forget to subscribe so you don't miss out any updates from Newton School. Keep practicing on Newton's Launchpad. The link is right there in the description.